Good morning, everyone. Thank you all for coming today from near and far to Tours, and where we warmly welcome you to the 4th Infectious Diseases and One Health Day, called From Challenges to Solutions, One Health's Role in Combating Climate Change. We have an exciting day full of presentations from experts across the field internationally, and are offering up their knowledge, passions, and vocational work for making us more resilient in the wake of climate change. We will both be your co-hosts for today, friends and graduates from Cohort 6. I am Jade Wong.
And my name is Stan de Schrijver. Let us give you a little bit of an outline of what we're going to see today. So we're going to start with session 1, namely climate change at the health interface, during which for 6 talks we will discuss topics including the past and the future of One Health, as well as climate change and emergency response, and climate change and antimicrobial resistance. Afterwards, we have some room for 7 current students who are going to present a little bit of their work. So we actually get to see what Idoh students do, what they did during their internship, for about 3 minutes each. And after that, we have a well-deserved lunch before we go into session number 2.
So session 2 will be moving towards bridging knowledge and practice, multidisciplinary solutions for resilient futures, where we'll delve into the specific case studies from countries like Bangladesh, Afghanistan, and Indonesia. We'll enter with our speakers into an array of climate solutions to mitigate health impacts from multiple levels of society, from individuals and communities to the strains on health systems, all whilst being adapted to specific socio-cultural contexts, underpinned with a systems thinking and data-driven approach, and grounded in co-creation, inclusion, and empowerment. Then we'll have a roundtable where we'll be talking about how to effectively train and prepare our next generation for this important One Health work. Then it'll be followed by an awards ceremony from the graduate flash talks, and we'll round off the day with the 2025 graduation ceremony. We'd love if you could stay for the whole day.
Now, before we go into the depth, I'm happy to present to you President of the Université de Tours, Philippe Rongard, with an impressive career in cellular biology and virology. He's worked on emerging diseases, as well as hepatitis, as well as HIV, and is currently working on a vaccine against hepatitis C. He's won numerous awards for his work, and now he also filed a patent for this vaccine. Thank you for being here. Thank you for taking time out of your busy schedule. And the floor is yours.
Thank you very much. I'm truly delighted to open this 4th edition of Idoh Day. I am effectively a professor of cell biology here at the University of Tours, the Faculty of Medicine, and a researcher in a field of viruses, as mentioned. And I have taught in this Idoh Master. I have regularly attended previous edition of the Idoh Day, which I've always found to be of very, very high standard, both in terms of organization and the excellent quality of the scientific presentation. But today, it's a new feeling for me, as I have the honor of opening this meeting as a president of the university. I have been elected at this position by university community about a year ago in December, and I will serve as a president for the next 4 years. So, as mentioned, this is the 4th edition of Idoh Day, organized by the alumni and the students of the Idoh Master Program, whom I warmly congratulate for this. And under the coordination of Frédéric Tersac, and I thank very much also for her tremendous work and investment in the Idoh Master Program, as well as Stéphanie Germont, Aurélia Hiron, and many others working for this wonderful program. The theme of the present day is, as mentioned, from challenges to solutions, One Health's role in combating climate change. This is certainly a topical, a critical issue, of course, even if, I should say that, unfortunately, some governments deny the climate emergency and even want their country to withdraw from this type of research, which is, I think, terrible, and going so far as to lay off researchers working in this field. And as university president, I believe that free science, access to knowledge, are absolutely essential, non-negotiable elements of any democracy, guaranteeing fundamental human rights that everyone should enjoy everywhere. And I would like here to recall the value of universality, tolerance, academic freedom, international openness that are very essence of any university, and of course, the University of Tours in particular. So there will be 11 speakers today, including an alumna of the master program from the promotion 2020 to 2022. And other, of course, from prestigious European and global institutions, including hopefully some institutions from the US, FAO, WOAH, Swiss Tropical and Public Health Institute, the Columbia Climate Change, the Kit Royal Tropical Institute, the Clinton Health Access Initiative, the French is France, Barcelona Supercomputing Center, Imperial College of London, and others. There will also be, as mentioned, flash talks by several students from the 7th cohort who will present their master thesis work, and it's going to be wonderful. We must thank our sponsor, INRAE, Powidian Energy, Loire Vallès. This is a major program for university, a program funded by the French government to support university, so including our university, wishing to strengthen their axis of excellence. And perhaps some of you were present last year, where myself I presented this program and showing how infectious disease is an important field in this program. Infectious disease is one of the 3 axes of excellence of the University of Tours. I would like to thank also today our partner university for the Idoh master degree, the Universitat Autonoma de Barcelona, the UAB, the Medizinische Hochschule Hannover, the MHH, and also, I don't forget, the University of Edinburgh, UOE, which was our pre-Brexit partner, we can say that, who has always supported us and stay close to us despite the unfortunate Brexit story. Here at the university, I'd like to thank audiovisual, communication, student life, and technical services, also the print service. And of course, I wish to thank the Erasmus Mundus Master Alumni Association and the Erasmus Mundus Association, the EMA. I would like to remind you that this event is being broadcast online on our YouTube channel. There are approximately 120 people registered on site and as many online. Also participating are students from the E2VB master program, which is the master program in French of our university in infectious disease. And of course, the HACE Idoh class, the only self-funded class with 12 students this year from 8 nationalities and 1 funded by the FL scholarship from the French government. Finally, I would like to tell you how much I appreciate this master program. Of course, as a university president, this is a master program with an international visibility, which is very important for universities' international position, but also at the personal level. Since, as I told you, I have been a teacher in this master since the beginning of this master. And in fact, I will continue to teach a little bit, several hours in this master. I say that because, you know, when you are a president, you don't have so much time to be anything else than a president. This is a full-time work. So I had to give up my teaching at the medical school, but I kept some several hours of teaching at the Idoh program. Finally, I hope that we will be able here at the University of Tours to keep this master program alive and obtain support from the European Union to fund it regarding our renewal application. Unfortunately, as my schedule is very tight, I'm already running late for another meeting at the university. So I won't be able to stay to listen to the talk. It's a pity, but it's my new life. And of course, I wish you an excellent meeting today and rich in scientific exchanges. Thank you very much.
There we go. Let's see how often that happens today. Thank you, Professor Rangaar. Now, let's dive into the science. It is my absolute pleasure to welcome and to announce our keynote speaker, Dr. Jacob Zinstag. As head of the group Animal and Human Health at the Swiss Tropical and Public Health Institute, the Swiss TPH in Basel, he works in zoonosis control and will give us a short overview of both the past and the future of One Health. Please welcome Dr. Jacob Zinstag together with me.
So 25 minutes from now. Good morning, everybody. It's a great pleasure to be with you and to talk to this audience. It's my first time to tour. Merci beaucoup pour votre invitation. Mais désormais, je vais parler en anglais. I would like to introduce to you the landscape, the disciplinary landscape of One Health as an integrated approach, among others, in the disciplines and sister disciplines of public health, but in relation to climate change. So we will compare eco-health, which was actually the first one, One Health and planetary health in a paradigmatic landscape. I think that is very important that you know what you are doing and how you are doing it. And we compare it to the standard discipline of public health, environmental health, disease ecology, like the natural foci of disease, veterinary public health, and medical anthropology. This is not exhaustive, but we chose these fields because they are most closely connected and influencing One Health. And all this we want to relate it to climate change. So I marked in green what relates to climate change whenever we come to it. And we want to present how we can address climate change through a One Health approach. What are the main methods and main challenges we have? The first will be integrated environment, animal, human disease surveillance. Then I will introduce to you the concept of One Health in social ecological system as an extension of the economic theory of governing the commons by Elinor Ostrom, which is a game theoretical approach. And I argue that this is probably the cutting edge of One Health methodologies. And we will then quickly look also into operationalizing One Health. And I hope that we can discuss at the end climate neutral healthcare. So let us start with environmental health. Environmental health is well-established field of the effect of the environment on public health. So it is about air pollution, it is about water pollution, it is about pesticide use, and in this field has made improved public health massively in the last century and is also influenced by climate change, in particular air pollution, but also water pollution. So paradigmatically, we can represent it as an arrow going from the environment into the human health. That arrow is one directional, and typically you do statistical analysis, you do logistic regressions to estimate the effect of the health of humans, typically through environmental parameters. This is also a linear way of addressing health. Then the second field is the beginning of disease ecology by Yevgeny Pavlovsky, who introduced the notion of natural foci of infections and also landscape epidemiology. He recognized the importance of wildlife as natural reservoirs of disease. So we can point an arrow from the environment into public health, but also into animal health, because he also saw how natural reservoirs are influencing animal health. I give you one example. Yersinia pestis, the causative agent of plague, is in marmots in Mongolia. And if hunters shoot them and fleece them, then they get infected with plague. So marmots are a natural foci of plague. Then veterinary public health. Veterinary public health was founded after the Second World War, largely by James Steele at CDC, who was a vet. And his diplomatic skill was to make the doctors say what he wanted, and not him. So this was his diplomatic breakthrough, that he was able to introduce the contribution of veterinary medicine to public health. This is not One Health. It's still a one-directed arrow that goes from animal health into public health. And then the fourth field is medical anthropology. Medical anthropology is a self-standing subdiscipline of social anthropology, but it is pivotal on the social determinants of health next to the environmental determinants of health. And I also draw it as a one-directed arrow from from environment and society into public health. And medical anthropology is also in a huge change, and this will be actually the far-reaching consequences of One Health, that it puts upside down the academic disciplines if we start not only looking at humans, but if we start at looking at humans in their environment. I would like to refer here to Corinne Peluchon, the French philosopher, who actually calls for a new enlightenment. I don't have time to go into that, but I just flag it. So if you look at this picture again, you see that the arrows always point in one direction. From the environment into public health, or from animal health into public health, with one exception. So integrated approaches started off largely by Calvin Schwabe. There were, of course, precursors to that, but in the 20th century, I would claim that Calvin Schwabe really stated that there is no difference in paradigm between human and animal health. So he recognized that we should not only look at the health and well-being of humans, but also at the one of animals. So you see now, for the first time, this arrow points in both directions. And already here, we can no longer work only with statistical methods. We need to include mathematical approaches to address this situation. Then came eco-health, that, and also actually the first time mentioning the term One Health in 2003 by this paper by Wilcox. And eco-health actually recognizes already the inextricable linkage of humans, animals, and the environment. The first who really came up with One Health in the 21st century was the World Conservation Society, addressing the issue of maintaining wildlife healthy in conservation areas. So conservationists and disease ecologists and veterinarians, we can say, were at the origin of the modern concept of One Health. And the term One World, One Health was coined along the so-called Manhattan Principles in 2003, claiming that if we want to sustain wildlife in conservation areas, we must keep humans and animals surrounding the conservation areas in good health. We came in 2005 going a step further. We said It is not enough to recognize the inextricable linkage of humans and animals and the environment. We must demonstrate an incremental benefit from a closer cooperation between humans, animals, and the environment. We went further to postulate One Health in social ecological systems in 2011. I come back to that when we discuss the game theoretical approach. And planetary health actually came in 2014, addressing the big global change aspects, the planetary change aspects like climate change, but also migration, but also antimicrobial resistance, the effect of the changes of the essential life support systems on human health. Planetary health is explicitly anthropocentric. If you show me one paper that formally includes animal health, I will change my mind. Otherwise, I will stick to the presentation. Here you see One Health, as we postulated, as an incremental benefit of closer cooperation in terms of health, in terms of economic savings, but also in terms of sustaining environmental services. And with the new definition, I will also come back to it, of OLEP, of optimizing and balancing the health of humans, animals, plants, and the environment. And here you see the planetary health, which essentially look at the planetary life support systems in relation to public health. So this is how I would represent the landscape, the paradigmatic landscape of the three major integrated approaches of health that we have today. And interestingly, One Health is really the leading one because it is best institutionalized today with the quadripartite, the OLEP, and the G7, G20 recognizing the importance, and most national governments attempting to set up One Health platforms. A pillar to all of these integrated methods is transdisciplinarity. What does transdisciplinary mean against interdisciplinarity? We argue that if you work between academic disciplines, say sociology and medicine, this is interdisciplinary because it's between academic levels. However, if you engage with non-academic actors like communities or authorities, so you enter into a multi-epistemic approach because you bring together the academic knowledge and the practical knowledge of communities and actors. So we bring together decision makers, concerned population, and scientists in one room and negotiate the problem solving. You have here the website transdisciplinarity.ch. This is the website of the transdisciplinary network of the Swiss Academies of Science, which has a lot of toolboxes on how to do it. If you engage in this kind of processes, I strongly advise you, if you are not yourself a sociologist, engage with an anthropologist or a sociologist, because this is tricky. There are many pitfalls that you can fall in. You can be instrumentalized in such meetings. You see here on the left side, that's a big meeting in Ulaanbaatar in Mongolia where we work on echinococcosis. On the right side, this is 2006, 100 kilometers north of Timbuktu in Mali, where we engage with Tuareg communities on problem solving. And I can tell you, this is absolutely a pillar of One Health. One Health cannot be generalized. One Health can only be contextualized. Every context is different. The situation in Mongolia is totally different from the situation in Mali. And if you don't listen to the people and if you don't listen to those authorities, you go dead wrong. You can just bury your project. I mean, if you would build a hospital to the Tuaregs on this picture here, they would never use it. For them, a house is a prison. The best way for a hospital-like structure would be a tent city. Then they would use it. Just to give you one single example. So the transdisciplinarity is pivotal to integrated approaches of health, and we draw it here actually as an orthogonal vector or orthogonal double arrow to the academic plane of interdisciplinary collaboration, because epistemologically this is really different, because we have to bring together the epistemology of the academic knowledge generation and the epistemology, the traditional knowledge of the communities and the practical authority, the practical knowledge of authorities. Now, what can we do to address climate change from a One Health perspective? In the forefront is actually the increased risk of a new pandemic. This is evident not only because of climate change, but climate change enhances it. So we need to bring together surveillance response systems. Contemporarily, surveillance response systems are either for humans or for animals, but very rarely they are combined. I will talk about that. Then we need to address food security. Food security is massively threatened by climate change and increased climate variability. And then, of course, we have to address the urban spaces. Urban spaces are hugely vulnerable to climate change because they are just heating up. So one way is to store more water. This is what we call sponge cities, or also to increase the green spaces. I do not work personally in that field, but I work on the third part, is how can we address the sustainable management of natural resources and healthcare in the same time. So these will be the three examples that I will present you now. So this is the current situation based on a framework that the World Bank has presented already in 2012 in two books on One Health. And it claims that if a new disease emerges in the environment or in wildlife, the related costs, that is the red arrow, the red line, are relatively low. But if the disease gets into livestock, the cost already increase. And if it gets into public health, the cost explode. And COVID is a wonderful example validating this conceptual thinking. And today we have the World Health Organization with the international health regulation that covers the whole public health part. And we have the World Organization for Animal Health that covers with the performance of veterinary services the animal part. But these systems are pretty in separation. So through a closer cooperation, what we call a One Health governance, we argue that if these systems communicate better, we can anticipate exposure and we can reduce forthcoming cost in a better way. So this is where One Health can really make an important contribution to prevent the next pandemic. If we prepare now, if we are all willing to cooperate and communicate, we can handle the next pandemic in a much better way. The microphone doesn't like me. I'm too small. So there are examples that put this already in place. You have the integrated West Nile virus surveillance system in Emilia-Romagna in Italy that in the same time looks at West Nile virus in mosquitoes, in wild birds, in horses, and in humans. And the system communicates and can already save money. And basically, this is what we should do in Europe. This is how we should expand the integration of surveillance response systems. this is what we do also in Africa, in South Ethiopia, in the Somali region of Ethiopia. The two people you see here on the left side, on the left side of the left picture, are a veterinary officer and a public health officer in a district health office, receiving calls from community health workers and community animal health workers. I give you just one example. Recently we had a storm of abortions, and the officers had a suspicion of Rift Valley fever and asked the communities not to drink milk and not to touch the aborted fetuses. And in this way they can prevent exposure to zoonotic diseases. This is how One Health integrated surveillance can work in practice. Here you see our study area in the Adadle Woreda. This is really at the Somali border of Ethiopia. And this is one pond that I always look at when I drive through. And in 2020 it was full, the children were bathing and the livestock was drinking. And 2022 we had a drought, and it was just a few goats who looked for a bit of water. But there was a huge mortality of livestock, you see here. And the problem is that these animals cannot just go away and find water. They have just to stay there and will die. And the diet is essentially milk-based. And we are currently studying how we can, what is the productive capital of the dairy basin of this city, Gode, and we hope that we can develop a powder milk plant that we could store milk ahead of periodic droughts. These droughts occur every 2 to 3 years. There's just no rainfall. So food security strategies are certainly one of the key elements of a future and of a present One Health approach. In this case, we had to provide also the drinking water, because the sedentary populations, they cannot move. They have to be watered essentially. And the mobile pastoralists, of course, they could move away with some of their livestock and find areas where water was still available. But this is not a sustainable practice. This is really a humanitarian emergency practice. Now, how can we bring together the aspirations of the One Health high-level expert panel's definition of One Health? If we would have time, I would ask you if you know it by heart. But here I present it to you. One Health claims that One Health wants to sustainably balance and optimize the health of humans, animals, plants, and ecosystems. How can we do that? So we start off with Garrett Hardin. Garrett Hardin says, if there is a common pool resource, like a pond or a meadow, everybody will use it until it is destroyed. Everybody will go fishing, or everybody will put his sheep on the pasture until there is no grass. This is what we call the tragedy of the commons. And this is a reality. This is true. It happens. So, for example, the biodiversity crisis is a tragedy of the commons. Nobody cares. We just lose species by species every year. But there is a way out, and that way out is shown by Elinor Ostrom, first woman to get the Nobel Prize in economics. She says, the tragedy of the commons is true, but there are many communities in the world that manage their common pool resources since, merci beaucoup, c'est très gentil, since centuries. Interestingly, the first example in her book that got the Nobel Prize was the mountain village of Kerbel in Switzerland, which has a 700-year tradition of managing its mountain pasture and forest sustainably. She proposes a social ecological system that is composed of natural resources, resource units, governance systems, and actors. So we have expanded this system to humans as a resource. What does that mean? All of us contribute to the per capita income of our nation every year. If we fall ill or if we die, that human capital gets lost. So by including the human capital benefits in the social ecological system, we can include health and the natural resource use in a sustainable way. We have shown this at the first case study in Africa, where we compare post-exposure prophylaxis of humans against coordinated dog mass vaccination, which becomes the dominant strategy if we include human capital benefits. This is not just a benefit cost analysis. This is, I know I should close. This is a game theoretical analysis. And I would argue strategy analysis is the future of One Health methodology. Here is the general mathematical framework. And I just want to mention this latest case study that we have been doing, where we can show that the Mongolian pasture is currently in a tragedy of the commons because they have too many animals. And if we reduce about fifths of the animals, we would get into a sustainable natural resource management. And interestingly, brucellosis control becomes not a dominant strategy in the unsustainable pasture use, but it becomes a dominant strategy in the sustainable pasture use. So there is an interaction between disease control and natural resource management. I just want to mention here the operationalization. This is an evidence review report for the European Union that I was co-directing last year, and where the European Union analyzes all existing policies that could be converted into One Health policies. To close, I'm also the editor-in-chief of KB One Health, so you're most welcome to publish with us. You can also produce case studies, or you could also contribute to the knowledge bank. Thank you for your attention.
Thank you very much for the fascinating talk. Are there any questions in the room? I see one question. There you go.
Thank you very much for this fascinating presentation. I just have a question about the tragedy of the common. Could humans become victims of the tragedy of the common? And if so, does, in a way, the human population needs to be regulated in such a manner?
Well, humans obviously are victims of the tragedy of the commons. But interestingly, in the first case study of Ostrom, of the mountain village of Törbel in Switzerland, this community was self-regulating its population. There was a very restrictive marriage policy. There were many celibate people. Only a few could marry. That is true. But you know, at the planetary scale, actually we are probably just running over the peak of the demography. Most countries, even China, are starting to decline. Africa will be the last continent that will start to decline. It's an interesting phenomenon, but I would never dare to ask for action on that side. Yeah. Yeah.
Thank you very much for the question. Are there any other questions? Okay, then I want to thank you again, Dr. Hinstag. Sorry, there's another question. Go on.
Thank you for your presentation. You discussed bringing in anthropologists or sociologists for this delicate dance, let's say. how have you seen the health world and the agriculture world interact with each other when someone has to make a bit of a sacrifice? So, for example, in Mongolia, talking about reducing herd size, because in many countries there's a pushback when these conversations are had.
Well, you can never ask this from the outside. That must come from the inside. But I can tell you, in Mongolia there is a Mongolian Federation of Pasture User Groups, and they choose a value chain approach, which means that if they reduce the herd size, they fetch a better price on the carcass and also on the cashmere wool. Because currently the cashmere quality and the carcass weight are declining. So by choosing a value chain approach, the people can be motivated to keep less animals but more productive animals. But this must come from the inside. And this cannot be, in French, on ne peut pas octroyer. You cannot impose that. Yeah.
Thank you very much. Thank you for the question. And thank you very much, Dr. Zinstag, for your wonderful presentation. The next speaker will be joining us from online, Dr. Talia van Noes. She's working for the World of Animal Health, the World Organization for Animal Health, the WOA. She's a One Health senior specialist who deals with threats to human and animal health on a daily basis. We're very happy that you could take the time to join us today. The floor is all yours.
Thank you very much. Thank you for the invitation, and apologies I couldn't be with you in person. It's very hard to come after Dr. Jakob Zinstag because of his wealth of knowledge and experience in the topics. I will try my best. So I will share my presentation with you. If you can just give me 1 second. Okay. Can you see the full screen? Just to make sure.
We can see the screen in presenter mode. So perhaps you could switch those?
Yes, I will. Okay. And now?
Yes, perfect. Wonderful.
Okay, thank you so much. So I will talk today about the changing of landscape of the threats that we encounter, but also highlighting some of the challenges to tackle those threats and the opportunities, and hence the needs for the One Health approach. So we start with the premises that we are in the age of interconnected crisis. We know that all the challenges that we face, from environmental degradations to economic instability to the food insecurities, the antimicrobial resistance, the zoonotic diseases, but also the geopolitical conflict, they are all interconnected. They are not isolated crises. And for that, we need to change our response from the sectoral response mechanism that Dr. Zinstag has mentioned, because it's no longer sufficient to do it this way. So because of the evolving nature of those global threats, we have to also evolve in our preparedness and our response to those threats. We talked about the One Health definition, and this is the way that they will give us the chance to address those complex challenges through this integrated unifying approach that aim to sustainably balance and optimize the health, not just for the people, but also the animals and the environment. Because of this recognition of the interconnectedness and the interdependence between those systems. And how it does it, it brings the sectors together, it brings the disciplines behind those sectors, but also it brings the communities at the different levels, from the locals until the global level. And the aim is to achieve optimal health outcomes through this collaborative efforts between the sectors and the disciplines. Now, what's the benefit of this One Health approach? It's clear when we combine our resources, when we share our resources, we achieve better efficiency and effectiveness, and we reduce the duplication and the overlap between the agencies and the actions. And so this One Health approach provides us with the framework of collaboration that ensure this cost effectiveness and efficiency in our limited resources that we have. And just to give an example from the zoonotic diseases, that the stakes are very high. What we used to witness every 100 years, we will have a global pandemics. Now it's reduced to every few years, and we are experiencing also a large number of outbreaks and epidemics, which has potential to become pandemics. And some recent studies showed that the probability that we will experience similar pandemic like COVID-19 is 2% in any given year, which means that any one of us will have the likelihood 38% likelihood that we will experience this pandemics during our lifetime. So the cost of inaction is far greater than the cost of prevention. We have to focus on prevention and reduce this risk of global threats, including pandemics. But what drives those threats? We know that the way that we handle our natural resources, from the land use changes that we make to the habitat encroachments and deforestations, to also the issues of climate change, extreme weather events, but also how we are producing our foods, the unsustainable livestock production and the value chain risk that we encounter, the agriculture expansion that doesn't take into account the natural resources and how to sustain it. And also we have the issue of the wildlife trade, most of it illegal. And again, we have our population growth and the issue of equity, poverty, and inequality. All those threats, they are underpinned by underinvestment in the One Health systems. We don't pay enough attention to risk reduction, to prevention, and we keep repeating the same mistake that we wait until the outbreaks or the pandemic is happening, and then we respond. And then once it is over, we go back to our comfort zone and to our silos of sectors and disciplines. And we disregard this economic case of prevention, that it's really very effective, very cost beneficial, and very cost effective to use the One Health and to focus on prevention. So we need to change this. Because of this, so far we have altered our terrestrial landscapes, 75% of it, and the same in the marine ecosystems. And this interconnectedness between animals and the humans, it increased the risk of spillover of the zoonotic diseases. Some of them has the pandemic potential, and this is just one example of the global threats. And we know for sure that 75% of those emerging human infection diseases, they originate from animals because of this drivers that I explained to you. So we need to change our way of working, focus on prevention, but this will require from us to put in place systems, policies, and procedures that enable us to work together. And we need to work on and focus on how to assess the risk, how to do early warning systems, and to avoid and mitigate and reduce the risk. And our goal is to reduce our vulnerability and exposure to these health threats. Those are examples, and Dr. Zinstaks also mentioned them in his presentation, like the food insecurity issue, the food safety risk, in addition to the zoonotic AMR and the vector-borne diseases. All those threats are complex, and they require from us multisectoral and integrated approach to address them. The economic case of prevention is very clear, and we just give here a few figures about this. The cost of prevention is estimated to be between 10 to 11 billion per year. But if we compare it to the cost of managing any kind of pandemics, which we have, it's like 30 billion per year. So it's clear that the cost of prevention is almost the third of what we cost us to respond. And if we have a global pandemic like COVID-19, where the global economy has witnessed 4.3% contraction in the economic value and outputs. So it's very clear that we have a huge return on investment if we invest in prevention. In addition, that this prevention is a global public good, so all of us will benefit from it. It's not if we prevent in one country, in one region, the whole world will be benefiting from these efforts. I give here some of the examples of the challenges that we face in our changing landscape. The first one is about animal health system. They are chronically underfunded. Although they are the front line of defense for all those health threats, yet they get only less than 1% of the total financing going to the health system in general. And the result, of course, that we have a lot of outbreaks happening, and our capacity to respond to them, to detect and to prevent them is very limited. And also there is an economic cost of this. And here just an example of African swine fever, which cost us around 100 billion economic loss since 2018. Another example, it's about AMR, and we call it the silent pandemic. And we know for sure that nearly 60% of the countries, they don't have the capacity to monitor antimicrobial use in animals. And we are projecting if this trend continue unchecked and we are not able to tackle this global threats, we will have a huge economic cost. But if we are investing in reducing animal use for antibiotics, we can deliver huge gain and again a huge return on investment if we achieve only 30% reduction of this antimicrobial use in animals. The third example is about climate change, and it's a threat multiplier. Because of this changing patterns of climate, which increase the probabilities of floods, droughts, wildfire, and other extreme events that we are witnessing around the world, including the heat waves that we in Europe, we had it now more frequent and more intense. This will expand the range of geographical spread of certain vectors, introducing them to new areas that they were not there before, or becoming endemics in those areas. And I just provided here some example of the economic cost of this climate-related livestock loss, which could amount to 20 to 30 billion annually. And the most burden will be on the small holders. So what can we do? We need to focus on the One Health approach. We need to make this approach operational. And for that, the quadripartite collaboration on One Health, which consists of 4 organizations, FAO, WHO, UNEP, and the World Organization for Animal Health, WOHA, we developed the joint plan of action with 6 action tracks that you can see on the left-hand screen here, tackling all those global threats that of concern to us. And we developed an implementation guide that supports countries and communities to go through a stepwise approach from a situation analysis to understand what do we have, what kind of problem we encounter, but also to understand what kind of legal frameworks, resource frameworks that we have in the countries, and then to help them to set up and strengthen those governance and financing and coordination mechanisms. And the third step is to support the planning and the prioritization of the One Health threats and actions that need to be taken. And finally, the fourth step is to support the countries to implement those national action plans and to link them to other relevant plans like the ones on health security or specific on animal health or specific on environment. And the final step is to monitor those efforts and to learn from them, to document the lessons learned and to share them widely. Importantly, we talked about the pathways of change. All those actions need to be going through 3 pathways of change to achieve the impact that we aim for. The first one is to look at the governance, the policies, the legislation, as I said, and the financing mechanism in the countries. And then the second one is to understand better what kind of organizational and institutional and sectoral integrations and implementation is available to us. And the third one is all actions need to be underpinned by data, by evidence, by science. And I will talk more about this science area in the presentations. And also we have a lot of operational tools to support the countries to make the One Health operational in the field. And we provided some examples of this from the zoonotic sectors, where we developed a lot of operational tools about joint risk assessment, but also on multisectoral coordination, information and surveillance sharing. And also we have done a lot of work on workforce development, including in the field epidemiology space. In One Health, in WOHA, I give you an example where we work on surveillance and early warning system for zoonotic disease. We started with a few countries in Africa, and now we are expanding to more countries and more sub-regional coverage to monitor the wildlife health through those multisectoral teams, and then to develop rapid disease testing and participatory surveillance that engage the community. As I said, a lot of wildlife health issues should be anchored into the community level. And then to share the evidence-based recommendations from this work with the public and the animal health sector, but also with the environment and the wildlife management authorities. And importantly, we need to raise the awareness of the risk when dealing with wildlife in the communities. This is an example of how we are operationalizing One Health in our projects. We have a lot in WOHA to work on One Health through many areas, and I will try to provide some examples going forward. In terms of collaboration with other sectors, I mentioned the quadripartite collaboration on One Health, where we work together to foster a unified approach to those health challenges. And as Dr. Zinsbeck said, we have our advisory group, the One Health high-level expert panel, to help us improve the science and the evidence for this actions. And as quadripartite, we have 4 strategic priorities. The first one is to implement the One Health Joint Plan of Action at national level. The second one, it's about more science and evidence for One Health actions. The third one is about advocacy and ensuring that we have the political buy-in and engagement to help us raise the profile of One Health into the political space. And the final one is about the economic case and how to leverage investment for One Health. And just to provide a quick snapshot of what we are doing in each of those 4 strategic areas, the first one is about the implementation. And we have actions at all levels, from the global to the regional to the country, where we have done a lot of workshop to sensitize the sectors and the partners about the joint plan of actions. And also we develop the operational tools to support the implementation. And then we go to the countries and help them to go through this stepwise approach for the implementation. You can find a lot of resources on One Health case studies, either on our websites or in the CABI One Health, which Jacob is the co-editor, and also on the Panorama website, which is for our partners. The second area, it's about strengthening the science and evidence. As I told you, we have the One Health high-level expert panel, which we established in 2021. And now we have the phase 2, which began just last year. And the current panel is helping us to go through an exercise to understand better what are the enablers and the barriers of the One Health Joint Plan of Action implementation. And they are also working on understanding the legal landscape for One Health in terms of legal frameworks relevant to One Health in each of the sectors. And finally, we will also update this inventory of the One Health operational tools and provide guidance to the country on its use. Another areas of work under science, we have a project called One Health Knowledge Nexus, where we have a community of practice which are open to everybody to join, from practitioners to policymakers, to students, to academia and private sectors. And we have now 2 communities of practice as quadripartite. The first one on return on investment, and the second one we just launched in April on the governance. And we encourage you all to join us in this community of practice to enrich our understanding of those issues. The third areas of work, it's about the global political agenda and advocacy. And for that, we engage with different political forums like the G7, the G20, but also the UN General Assembly and the different conference of the parties for climate change, for biodiversities, and others that deal with the drivers of the risk, to help us position the One Health as the way to achieve better prevention and reduce the risk. The last areas of work, it's about investment. And as you know, now we are in the climate of more contracted investment space, but we are doing our best to tap into all different kinds of investment opportunities, including the new pandemic fund, but also other avenues like the multilateral development banks and philanthropies. And for that, we developed as a quadripartite a joint offer to show the added value that we could bring to help the countries operationalize One Health and call for targeted investment into One Health areas. So the path forward, what we call for actions is if we are to build resilience against these changing landscapes, we need to invest in prevention. And we know that it's minimum investment if we compare it to the cost of responding to one pandemics. And we need to integrate our policies across the sectors. And we encourage everybody to look at the One Health Joint Plan of Action, which provide those alignment of actions. And we need to foster more our collaboration, not just the quadripartite, but also to the wider partnerships, including with the academia. And finally, we need to empower data-driven solutions and actions to support our operational tools and surveillance. So in conclusion, we know that the threat landscape is changing, and we have to change our approach to be able to respond effectively to this. So the time now is to work on prevention, and for that, we see that One Health is not an option, it's a necessity to help us achieve global health security, our economic stability, and also sustainable development. Thank you so much, and I am happy to take any questions. Thank you.
Thank you very much, Talia, for your lovely talk. Are there any questions in the room or perhaps online? I know we have some people joining us online as well. Are there any questions? I see a question.
Thank you so much for your wonderful talk. I have a question about the early warning system that you developed as part of your project. I wondered, how did you go about developing the system and made sure that the messages are understandable and actionable by communities and other stakeholders? Thank you.
Yeah, thank you so much. The early warning system, it's complex, as you know, and especially for One Health, because we need to bring the data from the three sectors, from public health, animal health, and the environment. And we need to understand each other. So we need to increase the interoperability of our data systems. But then once we have done the early warning system, how to communicate the results to different stakeholders, including the communities. And for that, we have different formats. Some of them could be a risk assessment report. Some of them could be a policy note or brief. And others will be just quick snap of the result of this, tailored to the communities, to raise their awareness, but also to inform about key actions that the community can take to counter this threat.
Thank you very much. Are there any questions online, perhaps? No questions online? Okay. Seeing that there is no questions online, I want to thank you again, Talia, for joining us today.
Thank you.
And then I suggest that we move on to our next speaker, who is Dr. Idoh Monnier. Dr. Idoh Monnier is a research fellow at the Living Systems Institute of Exeter, England, and his work is a prime example of multidisciplinary research as he implements methods of computational biology and structural biology in his work on a daily basis. Thank you for being here, Idoh, and we look forward to your talk. Everything okay? Perfect.
Okay. Morning, everybody, and thanks very much for the invitation and the organization. I'm just going to check if that's working. Yes. So I'm a marine microbiologist, and my specialty is the Arctic Ocean and climate change in the Arctic Ocean, and I try to understand. Yeah, perfect. And my lab, we're trying to understand the effect of climate change, sea ice retreat, the effect on Arctic microalgae, phytoplankton, and their virus and all those different microbial interactions that are being impacted by climate change. But today, because of the context of One Health, I'm going to show you some very recent results that we got with one of our algal model systems. And just to provide you some background on what I call phytoplankton. So they are microalgae. They can be of two types. Sorry for the biology lesson, but they can be cyanobacteria or they can be eukaryotes, so completely different. And usually when we refer to alga, we refer to the eukaryotes. And collectively, those guys are phytoplankton. They are, in terms of their morphology and their structure, they are massively diverse. Also in terms of their size, so here you can see a different scale from the smallest living cell, free living cell on the planet called Prochlorococcus, which is a cyanobacteria, up to massive colonies of Cyanobacterium trichodesmium. So you can see that they can be of vastly different size. And they are, like I said, massively diverse from a genomic and an evolutionary point of view. And in particular, the eukaryotic phytoplankton, so the alga, they can originate from different branches from the eukaryotic tree of life. And so just to give you an example, to contrast them with the land plants. So the land plants, they all originate from a single branch of the tree of life, so the Archaeoplastida, so that's the green lineage. So all the land plants are from the green lineage, whereas in the oceans, eukaryotic phytoplankton originate from many different lineages. So they are massively diverse compared to the land plants. And so why do we focus on phytoplankton? Well, in aquatic systems, in marine environments, they are what we call the primary producers. They are the analog of land plants. So they are doing what we call primary production through photosynthesis, which is probably the most important chemical reaction on the planet. They are able to capture CO2 and to produce from that CO2 that they've captured, they are able to produce sugars, which is essentially organic matter. So in the marine environment, those guys, they are the equivalent of the forest, okay? And they are responsible for about half of the primary production occurring on the planet, the other half being the terrestrial plants. So they are, from a planetary point of view, they are extremely important. So here you can see their position in the oceanic biogeochemical cycles where they capture CO2, they become essentially quite fat because they produce all that organic matter, which is then used by bacteria, zooplankton, and then grazed by zooplankton, and then through those oceanic food webs. So they are really pivotal to the ocean environment. And we can use many different tools to study them. So in the lab, we can use satellite imagery. They are very cool because they've got pigments to allow them to conduct this photosynthesis. So because they've got pigment, we can see changes in the way that the light is reflected. And we can use satellites to actually track their position using, for instance, chlorophyll A. And so you will see that phytoplankton, they need nutrients, so they need phosphate, they need nitrogen, and they need sunlight to be able to grow. And so you can see, using that satellite imagery, the hotspots of what we call the hotspots of phytoplankton. So, for instance, you have the coastal area where we have oceanographic phenomenon called upwelling, where basically you've got very rich, dense, deeper oceanic water masses that are being upwelled on the coast. And all those phytoplankton, they start thriving because there's all that replenishment in nitrogen and phosphorus. So what you see usually on the coast is very active, you know, like you've got seabirds, you've got whales, and you've got also a lot of human population. This is mainly due because you've got all those phytoplankton that are responsible for that, structuring these food webs. And so in the lab, we're interested in how those phytoplankton communities are reacting to climate change. And so we're looking at the effect, for instance, of pollution, of an increase in water runoff, especially from agriculture. Intensive agriculture would tend to have a lot of release on the coast of nitrogen, of nitrate, of ammonia, but also of phosphorus, which would then trigger the growth of phytoplankton, and certain of those phytoplankton can be dangerous. For instance, in France, on the coast of Brittany, there's been several cases of joggers that were basically running on the coast and basically died because of toxic gases that were being released by algal seaweeds on those coasts. And especially in Brittany, there's like that massive issue because of all the intensive agriculture and all the runoff on the coastline. So that in turn has impact on human societies. And so here you've got an example of a dinoflagellate. So that guy, which is called Carenia brevis, and is responsible for red tides that you can see here in Florida. And here you can see a coastline in Gold Coast in Queensland, Australia, that have been like closed because of the occurrence of red tide, which are massively toxic to fishes, to turtles, etc. So there's a big impact. There's also an economic impact on aquacultures. And those red tides and harmful algal blooms are becoming more common because of an increase of the water temperature of the surface ocean that can trigger the rapid growth of those dinoflagellates, which in turn become a bloom. So a bloom is like a super dense, mushy surface layer that you will see on the upper ocean. That's because there's like so many of those dinoflagellate cells. And similarly, it's not just in marine ecosystem, you also have that in terrestrial lacustrine ecosystem. So in lakes where we've seen, and those harmful algal blooms are mostly cyanobacteria. And we can see there's like some recent data showing an increase in those harmful cyanobacterial blooms. Again, with a massive impact on human societies. And here you've got a view of Lake Erie in the US with a cyanobacterial bloom. And like I said, my field of research is the Arctic Ocean. And we are interested in the way that photosynthesis in the Arctic Ocean is changing, in particular relative to the sea ice disappearance. So you probably have all heard of year after year, there's less and less sea ice across the Arctic Ocean. And that has a massive impact on phytoplankton, on algae community, because a lot of those algae are actually living either in the sea ice or directly below the sea ice. And those guys, they cannot really sustain a high intensity of UV. And under the ice, they have some kind of filtering occurring, so they are protected. So they don't have enough pigment to protect them from high UV. So if you remove that sea ice cap, you start to have phytoplankton that become stressed and some phytoplankton species that just completely disappear. And I'm not even talking about the physical consequences of the disappearance of sea ice, where the upper Arctic Ocean is going to be more exposed to wind, and so that in turn creates EIDs and other turbulences that completely changes the way that nutrients flow across the Arctic Ocean. And here you can see in a paper that was published 15 years ago that, so here you've got an increase in the temperature of the surface Arctic Ocean, and you've got a decrease in salinity. That's because sea ice ultimately is composed of fresh water, And as the sea ice is retreating and melting, you've got a decrease in salinity. And there's also an increase of permafrost thawing. So you've got an increase in river runoff flowing into the Arctic Ocean. And so that becomes a fresher Arctic Ocean, which in turn impact the way that nutrients are being cycled. And one of the consequences you can see here in this plot is that we see phycophytoplankton becoming more abundant than nanophytoplankton. So that means pico are very, very small cells, whereas nano are bigger cells. And I can show you an illustration here where we have a big, fat, juicy diatom here. And here we've got a very tiny picophytoplankton. So that's a particular species called Micromonas polaris, which has become super dominant across the Arctic Ocean, whereas the diatoms have become less and less abundant. And so that has massive consequences in the way that CO2 is being channeled by those guys. So you can imagine that a food web that is structured around big fat phytoplankton is going to be massively different from a food web structured around very small phytoplankton cells. And typically here in that kind of food web where those guys are dominant, your apex predator would be a jellyfish rather than, like being a polar bear, for instance. So in the lab, we're using that lineage. So micromonas, those very, very small cells, they belong to a lineage called the Mammilophyceae. So in the lab, we are using that lineage as model system to understand why Micromonas polaris is resilient to environmental change in the Arctic Ocean and also why it's so successful, okay? So in the lab, we're using 3 different types of species, but the most commonly used is Ostrococcus. So we don't really use Micromonas that much in the lab because although it's thriving in the Arctic Ocean, it's a slow grower because it's adapted to cold environment. So in the lab, we need to have like special resources to grow that bug at 1 or 2 degrees Celsius. And we're just using its cousin from temperate environment, Ostrococcus, because it's just a very fast grower and we can do a lot of different experiments with Ostrococcus. And so you can see here ultrastructure of Ostrococcus. And Ostrococcus is the smallest free-living eukaryotic cell. It's extremely simple. There's 1 chloroplast, the nucleus, and like I said, only 1 chloroplast and 1 mitochondrion. So it's super minimalistic and super easy to grow in the lab. And we've got a lot of data resource for Ostrococcus. So we've got genomes, we've got transcriptomes, and we also have a collection of viruses where we can use experimental procedure to see the effect of warming on, say, viral infection of Ostrococcus, and then try to translate that into models where primary production and the CO2 being captured by virally infected cells. But here I'm talking about Ostrococcus. Oh, so here you can see Ostrococcus. And like I said, it's a very small eukaryote. Here in blue, you can see the bacteria that are associated with our Ostrococcus culture. And you can see that the bacteria are actually bigger than Ostrococcus. And in red, you have viruses of Ostrococcus. And the other reason we're using Ostrococcus, it's a little bit our algal Drosophila. So we're able to use synthetic biology tool to transform, remove genes or add genes to Ostrococcus to try to understand, for instance, if we remove a phosphate transporter, is that going to change the way that Ostrococcus is going to be able to be more resilient to less or more phosphates? So it's essentially our model system. And one of the reasons we've been working with that system is to understand why they are becoming so resilient and so ecologically successful in changing oceans. And that's our big question, is that we don't really understand because they've got super small genomes, very compact, and in comparison to other phytoplankton, so for instance here, that's Thalassiosira, a diatom, which have big genomes, plenty of genes, and they've got plenty of wiggle room to evolve. So they, in theory, you should think that those guys with bigger genome, they've got more room to evolve and to adapt to changing conditions. But it's not what we see actually in the field. So that was our main question. And one of the hallmark of those tiny phytoplankton is specialized regions of their genomes called the BOC and the SOC. So for the big outlier genome and the small outlier genome. And those genomic regions, they are atypical because they have different composition in their GC. So, you know, your genome is composed of 80 GC, and those regions, those two regions, they are very rich in 80 compared to the rest of the genome. And all the different species that we've sequenced so far, they all have those two very weird regions. And we know from work that we did with our viruses, we know that that small outlier region is involved in viral resistance. So we see that, for instance, if Ostrococcus has a smaller outlier region, it's going to be more susceptible to a certain type of virus. But for the bigger outlier region, we had absolutely no clue what was the role of that region. So we've been using a multi-omics approach. So bear with me, this will be a bit of like technical slides, but if you want to ask me a question after the coffee shop, at the coffee regarding the different techniques, just come and ask me the question. So the first technique that we used is a technique called IC. So essentially, IC allows you to reconstruct the 3D architecture of the genome. So usually when you do sequencing, it's very linear. You're looking at the different genes, etc. When you're applying IC, you are cross-linking physically the DNA, and then you're sequencing, and that allows you to have information on the physical contacts of the DNA within the nucleus. Okay. So what we get is what we call an IC map, which is essentially showing you the way that the DNA within an Ostrococcus nucleus interacts. So when you've got a very boring line, diagonal line like that, it means that there's not very distant interaction between the different chromosomes of Ostrococcus, okay? That it's all a very linear with a lack of structure and a lack of organization, which was already observed using cryo-ET and using, you know, like proper structural tools. But what we did identify is that very weird region, so the big outlier chromosome, the BOC. We found that actually there was some structural resolution in that region, and that it also appeared to be insulated from the rest of the genome, like it was a little bit like protected from the rest of the genome. So if I zoom here, that's essentially the same map. And you can see here chromosome 2. And here you have the region with the low GC composition. And very clearly here, what we have is a domain that's insulated from the rest of the chromosome and from the rest of the genome, okay? And what was interesting, when we used transcriptomic methods, so transcriptomics allows you to determine the expression of genes within a genome, okay? And so we can quantify that, and what we found is that that weird region, the genes on that weird region were more transcribed than elsewhere on the chromosome and elsewhere in the genome. So massive transcription of those genes. And then we also found lower methylation, which also correlates with an higher transcription, okay? And finally, we found that most of the transposable elements in the genome of Ostrococcus localized in that region. So transposable elements, you can think of them as genetic parasites that are going to jump around the genome, and they can, you know, like severely mess up a genome. They can create duplication of genes. They can insert into introns and then mess up the regulation of a gene. But what we found here is that 99% of those transposable elements, they all co-occur in that anomalous outlier region. And we found the same thing when we sequenced the genomes of the cousin of Ostrococcus. So, for instance, Micromonas, remember, so Micromonas is the species that thrive in the Arctic Ocean. And we found exactly the same thing. So you've got that anomalous region where we've got higher transcription rates and also where all the transposable elements are co-occurring. And so our hypothesis is that that region is completely insulated from the rest of the genome and really acts as a trap for those transposable elements. So those transposable elements, they get stuck in that outlier region, and instead of being detrimental to the rest of the genome, they are basically creating some genomic innovation within that contain and constrain region, meaning that they can play around, duplicate genes, mess up genes, but those will have limited impact on the core function of the Ostrococcus genome. So what we did is that we looked at what type of genes were present in that outlier region by doing some ontology analysis. And one of the top one, phosphofontaine binding, was very interesting because it relates to a gene called polyketide synthase. So the polyketide synthase PKS is a synthase, an enzyme that is gigantic and is involved in the synthesis of polyketides. So polyketides, they are very interesting. We found them in bacteria, in fungi, and in plants, and they are essentially producing compounds that allows plants or microbes to respond to stress, to environmental stress, or to respond to pathogens. So for instance, many antibiotics are actually polyketides, okay? And so here you can see how a polyketide is actually working, but what I want you to remember is that they are modular. They are like Lego blocks. So if you change those Lego blocks, you're going to create a new polyketide, okay? And so what we found is that here you can see the polyketide in Ostrococcus, where you've got those different modules. And if you change those modules, then you're going to get a new polyketide, a new compound, which can potentially be an antibiotics or an antiviral. And to illustrate this, I can show you here an experiment that we did. We were monitoring the expression of that gene during an infection of Ostrococcus. And so in orange, you can see an infected Ostrococcus culture, and the expression of that gene, you can see that it peaks when Ostrococcus is infected by the virus. So what we next did is we compare the polyketide synthase within that region to other genomes of Micromonas and Ostrococcus. And what we found was like a huge variety of the modules and the combination of modules within that polyketide synthase. And what we did actually, we resequenced a strain of Ostrococcus tori that we had in the lab. And if you look at the two top ones, you can see that the structure is completely different. We did metabolomics to try to look if there was different polyketides between those two same species. It's Ostrococcus tori, it's the same isolate, it's just different cultures. And what we found is also using metabolomics, different polyketides present in those two different cultures, meaning that there's a lot of innovation and changes in the modules of those polyketides within that genomic innovation hub, if you want. And finally, and just to wrap up, and maybe related to One Health, what we are now implementing in the lab is that we have all those cultures of Ostrococcus tori, where we know that there's, because of that activity of transposable elements, we know that there's a huge diversity in terms of the module combination of the polyketide synthase. So what we're basically doing is like trying to harness environmental change and environmental stress to try to produce different types of combination of polyketides. From there, then we can try to screen, and that's actually what we're doing now. We've got different bacterial species and bacterial colonies, and we're screening the output of our single-cell colonies to try to identify new polyketides that could be that could be used as antibiotics. So what we're trying here to do is to have a natural and sustainable way to produce and to search for potential antipathogen or antibiotics using environmental stress that are mimicking climate change and what we're seeing, for instance, in the Arctic Ocean. And that was basically to wrap up and to relate it to One Health. And yeah, so those are all the people that were involved in that work. And yeah, thank you very much.
Thank you. Excuse me. Thank you very much, Dr. Monnier. Are there any questions for Dr. Monnier? Yes, there are. That's a shame. Try this one.
Okay. Yeah, thanks for this fantastic work. So do you also, in that transposon trap, do you also see signs like these PV RNAs in Drosophila, that they are domesticated to fight new viral infections?
No, we don't see them. They are mostly related to what we see in plants in Arabidopsis. And it looks like they are, in Arabidopsis, you have H2AZ histones that are basically involved in, the transposable elements are piggybacking on those histone variants, and we've got the same histone variants in Ostrococcus. So, and I'm not showing the data here, but it looks like the same mechanism where the transposable elements are using H2AZ to go towards this region. Yeah.
Thank you.
Thank you very much, and thank you very much for the question, Jens. In the interest of time, I suggest any other questions remain to be asked in the coffee break. Thank you very much. So the catering has just been set up outside. I hope it doesn't rain. We'll see. If you exit basically through the door that you came in through, you'll also note a bunch of posters being hung up around. So do have a look at that. We're a few minutes behind, so I suggest we get back here and we start with the next presenter at 55. So please be there by then. See you in a bit. Hi everyone, thank you for all being back. We will continue with the second part of the first session, for which I would like to welcome Ludovic Play, who will be joining us online. Dr. Ludovic Play is an animal health and production officer at the FAO, the Food and Agriculture Organization, and has a history in missions that address diseases including African swine fever and avian influenza. And Dr. Ludovic Play will talk to us about climate change and emergency management. Thank you for taking time out of your schedule, Dr. Play, and the floor is yours.
Good morning, everyone. Can you hear me fine?
Yes, yes, we can.
Okay, so I'm really sorry for not having the pleasure to be with you today. I'm based in the FAO office in Jerusalem, and the flights can be tedious to take in this strange period. As you mentioned, yes, my name is Dr. Ludovic Play. I've been working for FAO for the past 15 years, mostly as an expert in emergency management, which will be the basis of this discussion. I've been working mainly for more than 13 years in the Emergency Management Center, which I was the manager for 5 years. Emergency Management Center, which is a quite particular unit in FAO, working on emergency management. So I have the pleasure also, as a disclaimer, the views that I'm going to show you today are just engaging me and my experience in terms of as an emergency manager. They are not reflecting the views of FAO on emergency management. So I wanted to start quickly, and I'm really sorry because I cannot see you and I really miss the human interaction. I will start with some useful definition. Why looking into climate change and emergency management, especially from an FAO perspective, when we have been working many years mainly on animal health? Well, I will describe climate change as a series of unexpected events, like a challenge in the way of human beings able to address emergencies. So I'm going to start with the definition of the United Nations Framework Convention of Climate Change, which attributes climate change, directly or indirectly, to human activities. Human activities that will alter the global atmosphere and that would lead to natural climate variability, changes in what we think about regular climate, and they will have over a period of time that you can compare. I'm taking that picture of wildfire because the EMC was engaged some years ago in addressing wildfires in Peru, which was quite interesting for an emergency management center that were created for animal health at the beginning and then expanding to plant health and fisheries, showing that emergency management capacities and emergency management tools can be applied to different emergencies, affecting differently vet services. And this was a particular story in which the vet services were having to address wildfire affecting animals when it's basically not their prerogative as a ministerial unit. So when we talk about climate change, we're not talking about a change that will set up steadily in the future. You can see a shift in the baseline of what we know as a regular climate. So an expenditure of the lower or higher temperature, but the word that is really interesting for emergency managers is the probability. You have an increased probability of abnormal climate events. And this probability is really difficult to foresee, which you will see foreseeing is one of the basic of what we usually see in terms of emergency management. When you look into prevention or addressing emergencies, one of the tools that you're using is risk assessment, the capacity to foresee what could happen. And the system or the country that where you're going to apply, or the region where you're going to apply your capacities of emergency response or emergency management is heavily based on your capacity to foresee. Climate change is challenging the human being capacity to foresee what could happen. And challenging this capacity might decrease our ability in the future in the way we're doing business in emergency, on how to address and mostly prevent the future emergencies, climate being one, climate effect on production of animal disease, but also pandemics and new viral ecology. This slide is quite interesting because it shows that the climate change is basically rolling the dice. You have a chance of increased rainfalls. You have a chance of increased heat wave, and we have seen it happening more and more in Europe, but also in other parts of the world. And these changes, even in a short period, can have a huge impact in our ability to do emergency management. New disease ecology. This is a slide that I wanted to show. It's when I was a student in epidemiology and we were studying the epidemiology of influenza viruses. Things seem to be quite simple in a way. You would have bird flu that would be existing that was not supposed to pass over to humans. You would have human flu that was also quite specific in its term of host. And in the past, you would need a swine species, a pig, that would have the two receptors of the both viruses that would mix the influenza viruses from birds and humans, and then would be, let's say, the trigger for a new virus that could become a new pandemic. H1N1 was a perfect example of what we knew in terms of influenza viruses ecology. But what changes, and you can see now when you look into the news in ProMed and other scientific sources, is that avian influenza started to jump from avian species directly to humans, causing disease, causing mortality. We've seen that since 2006. And then it kept changing and adapting to new species. The pre-goose guandon lineage was basically a lineage that was highly adapted only to avian species, and the post before the appearance of this lineage. And the appearance of this lineage led to what you saw in South America, for instance, for the last outbreaks, in which it affected mammals like marine mammals. And what you can see today, sorry, I will jump after that, and even other mammals, and I will discuss in the next slide about the new issues. So expanded this variety of hosts of animals that are infected, which was not what we were seeing in the past. So we can wonder what is the new phase of the influenza viruses, and especially the avian influenza viruses. And this picture was taken from different species that were affected in South America. In terms of management of the crisis, you can imagine that usually the vet services are the ones that are responsible for disease control, disease prevention. When this disease is getting into species that are not for production, like mammals, marine mammals, vet services are not used in a legal basis in countries to address that emergency. It might be the Ministry of Ecology that is dealing with those species. The Ministry of Ecology has no capacity to answer this type of emergency. So not only you are facing the disease ecology that is quite different, but it's challenging also in the countries the capacity to answer to emergencies, because the different ministries that are involved in terms of control don't have the capacity to address this emergency. What you have seen since many years, we are going from epidemic phenomena of influenza outbreaks into more enzootic phenomena. The virus is getting installed in area where before we used to just kill the animal, clean, and think that the area would be free from the virus. And what we can see now is like an extension in endogenousity of those viruses throughout the world. I wanted through that presentation also to show what's happening also lately, which is the introduction of influenza viruses, and you've seen that in the US, into cows, with a sustained transmission between farms of infected cows. Those cows are not showing symptoms, pulmonary symptoms. They are usually showing mastitis. But the husbandry system allows the circulation of the virus, the spreading of the virus throughout the US. And you can see as in epidemiology, you have a virus that used to be contained into one species to a virus or viruses that have the capacity to go to different species, hence having the capacity to recombine more and more in the future, increasing the risk for a next pandemics, if we can talk about the next pandemics after COVID. What I wanted to make you think of, because that's the goal of this presentation, it doesn't have to bring any certainty, is that the world and so climate change is one of them, the new biology of viruses of disease, is putting us to expect more and more than expected. What we thought in the past seemed less and less a certainty. And it will be affecting our capacity to do emergency management. As I said, why? Because, and I'm going to present you what is the emergency management. Emergency management is based a lot on a capacity to foresee what could happen, to do a disease prioritization, to be able to do a risk and proper risk assessment. What is risk management? It's emergency management is based on a cycle, which is you prepare a country for an event. You prevent this event to happen to the country. You increase the country to its ability to detect the event. Of course, sometimes you're not lucky in the country, so you have to respond to the event happening. And after the response, you have to make sure that to put back the health system to its previous level through a recovery system. If you want to have more information and insight about what is emergency management, I would advise you to go on the FA website or only on Google and type Good Emergency Management Practice or GAMP. You have two good manuals that are describing what is emergency management. The first one is putting the basis of emergency management as a whole, while the other one is putting the emergency management cycle, applying it to an outbreak. So what is the main, for me, the main component of emergency management? In the past, vet services or even health services were really looking into response. How can you do a better response to animal disease? Well, if you just look into response, you're going to lose the war. Look into it as a war. I know that it's not a right politically correct terms to use in those periods. But if you go to war without being prepared, you're most likely sure to lose. So preparation to the event and preparation to the crisis is an extremely important pillar in emergency management. It has to be done before the crisis. It has to address what is needed in advance to address any crisis. And you have to use this period to build skills and capacities in the country to do response, to do and prevention, and also recovery. Everything has to be done during peacetime, as I mentioned, because during a crisis, you don't have time to think. You usually go to the field and address the emergency. So emergency management is also heavily linked to the policy of a country. And this is a nice picture from the Palestinian National Authorities, from the Palestinian Vet Services, in which you have avian influenza, avian highly pathogenic avian influenza standard operation procedures. What you would need when you do an emergency management in a country, you have to make sure that the country has an emergency preparedness plan. What the country needs in terms of capacity buildings, in terms of funding, in terms of human resources, you name it, in terms of laboratory capacities, not only in a day-to-day business, but to address increased number of samples in emergency, you have to have this part into the emergency preparedness plan. As I mentioned, one of the main components, not the only one, but one of the main components of your emergency preparedness plan is to which disease I will be prepared. And knowing to which disease you will have to do in the country a proper risk assessment, disease prioritization, and understanding the possible threats to your country. Climate change and the fast changing in the climate often put countries in a state of, I've done my risk assessment, but the nature or the reality puts me in a challenge in which my risk assessment is not valid anymore. And I will give a nice example of when I was working with the ministry on the Pluton in France, emergency and contingency planning. Contingency plan, you have to see it as a response plan. So I have my preparedness plan that is done. When my preparedness is done, I also have to know how I'm going to respond once the threat is getting into the country. That's the contingency plan, which I preferred calling the response plan. From this, you have the operational manuals, the expression of those plans on the field, because people are not going to be able to lose time during an emergency during different. So you will have standard operation procedures for people to, for example, know who to contact, where to get procurement during an emergency. And then you will have to have a recovery plan, how I can get my health system back to normal after the emergency. If you look into COVID, for example, how we responded to COVID, we didn't have any preparedness plan. COVID was totally an unexpected event. Response plan, we didn't have any. We tried to respond to the event as best as we could during the event. And the recovery, unfortunately, in many countries was not done. How many countries supporting psychologically not only the health workers, but also everyone that was affected, and we were all affected by the COVID, to get back to normal, business. One of the examples of how things can change due to unlikely events is, for example, in France, the Ministry of Agriculture had worked on an extremely well-defined preparedness and contingency plan on Bluetongue virus. It was such a neat work that the Ministry identified the first vector implantation in a little locality in south of France. What happened? And nature has a weird way of going around the plan whenever we have a plan, is the virus was not introduced in the south, where we thought would be introduced, but it was introduced in Northern Europe, where all the risk assessment was considering highly improbable because the vector that was in Northern Europe was never seen as suitable for virus spreading and virus multiplication. And you can understand that the entire system of response, even if it then was based on what had been defined originally, lacked the timeliness of being able to respond in a proper manner. So it's just an example of how, even with the best scientific data, with the best risk assessment and the best contingency plan, sometimes we're facing unexpected events that challenge our capacity to respond to disease. I wanted to remind everyone also that emergency preparedness cycle is not set up in marble for once for all, as maybe we might think. It's an ongoing cycle. You start with planning to develop framework, risk analysis, results mobilization, identifying disease that you want to be prepared. Then you have to equip the laboratory to equip in human resources, planning resources and money to be able to not only prepare to respond, then train your staff in countries to deal with the emergency. And then you have to test the plan. You have to test the emergency preparedness and response plan to see if everything is well understood in the country. Most of the time, we don't test. And many countries have really nice plans. They are not testing, and then they test whenever the disease is coming, which leads, as you might think, to some negative impacts, both economic, social, and human. And then you have to go back to the plan to adapt it after the testing. So how do we do emergency? How we still do emergencies even after COVID? Well, this slide shows that either we let the disease run its course most of the time, and that was some of the disease that we had in the past. 90% of the animals are going to die. We don't have much to do, and halas, it's done. Or we kill the rest of the animals to shut down virus transmission or disease transmission. Or we can also have vaccine or treatments to the disease in place. Is it enough? We are thinking also more and more into One Health. For example, I wanted to highlight the importance of risk communication in any preparedness and response activities the country or region of a group of countries want to have on disease. Unfortunately, I'm not with you today. I would have loved to ask you what is wrong on this picture. One of the risk communication, and it was done pre-COVID, is developed by a Ministry of Agriculture in one country, and the other one is done by the Ministry of Health. You can, through the One Health lens, already identify you're not looking about the content, but the idea behind those communication. You have two communication on one disease, increased risk of miscommunication and misperception from the public and the private sector of the farmers, and hence resistance to any policy you want to apply in the country. That's where One Health is needed. You need one voice. So we will face in the future, through climate change, through new disease ecology, unexpected events. Are we ready? Are we not ready? Did we learn anything from COVID? That's the question. And FAO used the PEP, the Preventive Pathway for Emergency Preparedness, which is a neat tool that assesses countries in their capacity to respond, to be prepared to an emergency. We have more than 45% of countries from FAO that answered to that tool. And unfortunately, 91% of all respondents have a low to medium preparedness capacity, meaning that preparedness is still not high on the political agendas of countries. Meaning that if a disease enters a country, we are most likely to use the old recipe of response than adapt and create a new way of doing emergency management. I put those two pictures from Mauritania. There was a quite interesting mission that we had in Mauritania on Rift Valley fever, which is a vector-borne disease in the middle of the desert through climate change impact, increased rainfall. The desert was green, increased number of camels and camelids to come and feed. And what happened is you had Rift Valley fever coming with mosquitoes in those areas, affecting camels, which were not supposed to be affected by the virus, but also affecting the human communities in that region pretty badly. I also wanted to show this extremely interesting thing that just happened in 2025. WHO was really happy with the member countries to have the first pandemic accord. Within the pandemic accord, you have mentioned also in One Health. in my personal point of view, and that engage only me, I would have loved this pandemic accord to have different organizations working on One Health to make it even stronger, as a stronger statement globally on how different UN organizations will be able to gather our strength and capacities in case of the next pandemic. And I really, really wish that the pandemic agreement that has been really well developed by the WHO will lead to a pandemic agreement that will be shared by different UN agencies. So what is emergency management, and why am I showing you the innate immunity of one cell and a complex mammal immunity? As an emergency manager, I still believe that we are dealing with emergency as a singular cell. We have something coming in, we are dealing with it, we're surviving more or less, and we are not learning enough from past emergencies. We're not learning enough to get into the next level of emergency management that would lead to be more flexible in terms of response and emergency preparedness. We need to go from a single-based response to a much more system-based learning from nature, learning from evolution on emergency management. We don't need a shift. We need to change the way we're looking in emergency. We need to change the way we're doing business if we want to face the future challenges of climate change on agriculture, agro-system, but also on new disease ecology that might lead to new pandemics. We have to get into a system thinking. We have to stop thinking about single event reaction, and we have to learn to get into more system. The system approach is going from addressing less and less predictable hazard to an adaptive emergency system that would be flexible to the unknown. I'm not saying that the risk assessment and the way we're doing emergency management now should be forgotten. We should learn from them and test the emergency system in countries for the unknown to see how much we're learning in terms of emergency management. So why did I put a picture of orchestra in a presentation of emergency management? In many countries, you have now good laboratory capacities. You have good training of veterinarians, of doctors on the field to do surveillance. You have a pretty good level of knowledge of people in terms of disease in many countries, not in all. What is missing is a conductor. When a pandemic arrives in a country, and we've seen that during COVID, we miss someone to put the music together for proper emergency response. Each of those are trying to do their good job together, but unfortunately, the emergency operations centers at national or regional level that should be system, like little centers that would gather the capacities of everything that you need in a country to have a system approach to an emergency, or not existing, or are not underlooked when an emergency is happening. Imagine having this system, these centers happening not only at the national level, but creating a network of these centers at regional levels as a backbone, as a skeleton for emergency management. That would not only increase your capacity to respond, but that would also increase your capacity to detect a single event in a country, activate a system to put into jointly capacities and respond to that event as soon as possible. So you're going to ask me, wow, it's nice, you're presenting maybe a new way of future of emergency management. But how can you test countries from now on how, on this system approach? So, and I'm really taking the last minutes because I think I'm getting closer to the end, on an excellent example in Senegal, which was challenged through a real-time event introduction of screwworm disease. And it was quite interesting to see that the screwworm disease was not part of any plan in Senegal, but the system as a whole was able to quite well manage the emergencies. The veterinarians in the field and the health officers in the field starting to see these things happening in the field from people, from farmers, and talking with veterinarians. They didn't know there was a disease that had an impact on animal health. They thought it was only from some of the farmers they were talking to, only affecting animals. The veterinarian didn't know there was a screwworm disease. They considered it was just another mysis in the country. And they approached the mysis the same way they would approach any mysis during this period, not knowing it was a highly zoonotic impact disease. Doing so, using the capacities in the country, doing the good expertise of the people on the field, they were able to limit the impact of this introduction of screwworm in the country. And when you look as an emergency manager in assessing and challenging a country, that's what we have to look into, not introducing new disease in the country, of course, but having workshops or challenging or assessment meetings in which we would put countries that think that they are ready into situations where they're not ready, to make sure that for unexpectable events, they are able to answer. And as Mark Twain was saying, and I found this quite amazing for the presentation, for the emergency management, it ain't what we don't know that gets us into trouble. It's what you know for sure that just ain't so. And I wanted to finalize this presentation to say that it's time to come to think outside of the box in emergency management and bring our emergency management to a new modern level. And I really thank you for your attention.
Thank you very much, Dr. Play. Thank you for the fascinating talk. Are there any questions for Dr. Play? Are there any questions online, perhaps? No questions? In that case, I have a question myself. So, Dr. Play, you've been talking about how we need to come together and do a bit of more international collaboration to deal with emergencies. How do you view and how do you deal with the current political situation in a world that's a bit more, well, let's say, not very constructive in that regard? What do you think we should do instead, and how do you look back on this?
I think your point is extremely important. The politics are really impacting our capacities to address emergency. It affected importantly our capacity to address the COVID-19. I think lots of emergency operation centers, the ones that were existing in countries, were not listened to. So most of the decisions were taken at the political level. And unfortunately, I don't see that the world is getting back into a more joint, addressing emergency, or at least addressing preparedness or prevention. I would say that it's part of the UN organization, but also with countries under the UN to get together and say, we have to work better on emergency. We have to do an after-action review on how we dealt with previous emergency. I think learning is one of the key factors for doing a better emergency response. I'm not so optimistic in the future, to be honest. I'm not sure that the world is ready or is willing to hear about a risk of the next pandemics. I'm really concerned about avian influenza as the next potential pandemic for us. We were looking into it a lot in the past, and we have seen in the last outbreaks that countries that had been supporting in the past to address avian influenza, for instance, were losing capacity. So, so I don't know if I answered correctly your questions, but I think there's still a lot of work I think there is an interest when we were working in when I was working in the Emergency Management Center in HQ in Rome. There is a lot of interest in countries. For example, Senegal is one of them, Cameroon is one of them, to get to a higher level of emergency management capacities, to have using the One Health approach, but not only to address potential emergencies. And I think those countries, and we have a lot to learn about those countries in terms of emergency management, even in Europe. And I think we have a lot of knowledge and capacity to get from them. Over to you.
Good, thank you very much. Thank you for ending on a positive note as well. I wish you had been here and we would have continued discussing this topic a little bit. For now, I want to thank you for being here with us. Thank you for the lovely presentation. And I suggest we move on to the next speaker. So to the floor, I would like to welcome Dr. Bruno Gonzalez Zorn, who is the head of the Antimicrobial Resistance Unit at the University in Madrid. And today he's here to talk to us about, antimicrobial resistance and climate change. The floor is yours. That's the one, right? Yes. Good.
Okay. Hello. So, hello everyone. It's a real pleasure to be here with you today. I came straight from Madrid just to be this 30 minutes with you, which means that it's compulsory to have 100% of your attention. Not only because I came from Madrid, but also because the subject, antibiotic resistance and climate change, is the most important subject in the world. So let's go 25 minutes. So this is the world in which we live, where we see, it looks nice, blue water and green places, etc. all over. But the fact is that in this world, many people are living. More and more people are living, and a lot of pressure we are creating and changing all the circumstances that are here with population and waste. And you've been studying this for the last 2 years already. A lot. So I'm not going to teach you about this, but the fact is that we have global challenges, and there's some global challenges that we have to face from a One Health perspective. And today I'm going to talk about two, as I told you, two of these challenges: climate change and antimicrobial resistance. What do these two challenges have in common? And what they have in common is that we cannot face them and tackle them individually. So there's no single subject, person, group of people that can tackle and solve this problem. What we have to do is to tackle this from a One Health perspective. So we need social sciences, don't forget anthropology, sociology, etc. We need medical, biological sciences, engineering, all different sciences working together to tackle these global problems that none of us, no single subject, no single person will be able to tackle. And both of these subjects are antibiotic resistance and climate change. When we see what I was telling you about, yes, people that are in this world, what we see is that we have not been many people. So we have been, during a lot of years, in a very good equilibrium with the Earth, being only 1 billion or 2 billion people on Earth. But suddenly then something happened here that made it explosion of people in the world, a complete disaster. Who produced this disaster? We produced it by 3 means. First, I could ask you, but this is not a lesson. Potabilization of water, very important. Second, vaccines. And third, and most important issue from today on for all of you, antibiotic resistance, and the discovery of antibiotics. So with the discovery of antibiotics, we have created this great problem, which philosophically means, should we work on health? Because this is health success. So with health success, we have created a tremendous ecological problem on Earth. But of course, who decides now who of these 8,000 million people should we kill? So it's too late. So we have to cope with this problem that we have now with so many people on Earth that we are able to cure and have been able to cure. So when we think about all these different people, we say, yes, we are very important. We are 8,000 million people. Great. But don't forget that each one of us is fully colonized from outside and from the inside by millions and millions of bacteria. How many bacteria? We have per gram of intestinal content as many bacteria as humans are on Earth. So 1 gram, 8,000 million, 8,000 million, 8,000 million, 8,000 million. So the real drivers of life on Earth are not us. We are not so important. The important is the bacteria that really master life on Earth. They were here from the beginning. They were the first ones to be here. Prokaryotic life was the first one. Luca was a prokaryotic individuum. And after everything, they will still be here. These bacteria have not been able only to colonize us externally and internally, but there's also no single animal on Earth that is not colonized externally and internally by bacteria. And there's no single ecosystem on Earth that is not completely colonized by bacteria, including a volcano that you know very well, that there are spores that if you take them out, they germ. So even inside a volcano at 1,500 degrees, there's still life conserved there. So bacteria have been able to adapt to all these different ecosystems. How have the bacteria adapted to so many different ecosystems and have been able to colonize all these ecosystems? Not peacefully. Not peacefully. It's a pity, but life on Earth is like that. So bacteria have been fighting with each other since the beginning. Some of them, many of them, have learned to produce some molecules that are killing all the others instead of cooperating, killing each other. And other bacteria, in all this time, they have been able to try to resist all these antibiotics. You see these small mutants here, which are bacteria that have learned from outside to learn to resist to this antibiotic because this bacterium wants to eat the apple alone. And that's why it's producing toxic things for other bacteria and other microorganisms because it wants to colonize an ecosystem. And this is how bacteria have colonized all different ecosystems on Earth. Since when? Since I told you, since more than 4,000 million years. So 4,000 million years is the Earth is the time of the Earth. Life we have more or less since 3,500 million years. So since 305 million and 500,000 years, all these bacteria, million years, all the bacteria have been colonizing all this ecosystem. In fact, we know that the bacteria from the dinosaurs are the same ones that we have in our intestine, most of them. So all these bacteria have been there, and Homo sapiens, they are there. We will extinguish, and the bacteria will still be colonizing all these things. Until suddenly, and it's very recent, even for you young people, it's very recent that somebody discovered that working with Staphylococcus aureus, a shit thing fall into his plate. And Fleming, when he found this in September after going out on holidays, he did not know how this thing was called because he was working on Staphylococcus aureus. His life was devoted to Staphylococcus aureus. And to all the microbiologists until that point, all of them had contaminants and contaminations with these shitty things that were falling on their plates. All of them, Robert Koch, Pasteur, they are all very smart, but all of them, when they were seeing one of these things, they said, shit, another contamination. I want to work with my Staph aureus, or my tuberculosis, or my Pasteurella, or whatever, so I will throw this away. So the intelligent thing of Fleming, who was not a very good microbiologist, but he was smarter than the others, he said, well, look at my Staph aureus nearby this thing that I don't know how it's called. My stuff work less good than here. So maybe this is the original plate. So maybe I should not work on this thing. Maybe I should work on this shit. And this observation is very important for your future lives. You will have PhD supervisors. You will in your life also be devoted to follow a line because your PhD supervisor tells you, because you think that that couple that you have will be the best one for your life. But in life, it's very important to look left and right to the things that are happening in our life. And many times, often, not only in research, also even in your personal lives, things at the left and at the right will happen to you that maybe bring you, or probably sometimes bring you to nicer and better and more gloriful paths than the path that you're following, that your PhD supervisor tells you, you have to. So please be aware that this, always be open to switch things, to switch paths in your life, because this will be much more productive and better for you than just following stubbornly the line that the society wants from you, okay? This is the most important take-home message for the rest of my talk. So with the discovery of antibiotics, this is what happened. Complete modern medicine developed, fully developed. All surgeries that we do in our hospitals, everything that we do in our hospitals, including cancer research, all surgeries, etc., are only possible because antibiotics work. You can take an organ from a person, put it in another one, and all the surgeries and all the modern medicine is only based on the fact that antibiotics work. So what happened? That people then copied Fleming, and they said, well, instead of that, I'm waiting until September. If somebody thought, let's go out there. There's no window here. Let's go out there and bring all these bacteria and whatever that are producing things, and they see then what antibiotics they can produce. And this is how we discovered all the antibiotics that we have until today. All the antibiotics that we have until today, we discovered it until 1990. It's 30 years that we have not discovered a new family of antibiotics. Okay, so this is like the golden time. So what happened here? Why are we so stupid to drop this? Because in the 70s, I was not born, but some older people that I see here, yes. And we had too many antibiotics, enough antibiotics in the market. So for every single disease, the prescriber could prescribe 2, 3, 4 different antibiotics, and all of them were working perfectly. So it's true. We didn't need new antibiotics. So the industry then concentrated in other diseases, and we heard about pandemics. What pandemic was that in the 70s and the 80s, killing many people worldwide? HIV. So then the industry concentrated on other molecules, for example, HIV. And today, luckily enough, the life expectancy of an HIV patient is the same as of a positive patient, is the same as an HIV negative patient, which was impossible to think of in the 80s. Okay, so it's good that the industry organized and developed other molecules, but antibiotics, they completely left it. So we say, okay, yes, but it's a long time, and we've been hearing about antibiotic resistance. Probably everyone, all the companies, everyone in the world is now developing new antibiotics. So we have done a study in the WHO to see how many antibiotics we are developing, and the fact is that if you see here, this is private companies, and private companies with more than 500 employees, blue bar, you see it here? Oh, me neither. So there's no company, large company in the world that is currently developing antibiotics. No company in the world that is currently developing antibiotics, even knowing that we have a huge pandemic and whatever, but there's no company. Why? Because it's not economically profitable. So companies are not non-governmental organizations, and they have to decide, what molecule do I do? Once against cholesterolemia, which I will then be treating half of the population in the world for 30 years, or an antibiotic that it will take me the same time to develop it, but in 3 days it will be overused, copied, whatever, resistance. None of us, even me, would go into antibiotic and discovery. So this is why today, luckily enough, finally, after many years of discussion, we are performing public-private entrepreneurships. So we have to give money to the companies so that they develop antibiotics that they are useful for us. So we are seeing what model we are using. We are putting there's one model of putting some money in a pot, and then the first company that comes out with a good antibiotic, we give them 10,000 million euros. This is one thing. Another possibility is to prolong the patent. So for example, imagine you produce Ozempic, and you produce Ozempic, and the patent is expiring. 1 year of extension of Ozempic is a lot of money. So maybe like this, we managed that Novartis is finally doing some molecule like this. So we are seeing how we can establish that the companies start to develop new antibiotics. I'm talking about antibiotics, obviously, all the time, and antibiotic resistance, but we also talk, in 2023, we included also fungi, okay? So we talk about antibiotic resistance, but also antifungal resistance, okay? And in May 2025, we came, what are we talking about? We are talking about E. coli, Klebsiella, and resistance to third-generation cephalosporins and carbapenems. Carbapenems is the last resort antibiotic. We use it intravenously in patients in intensive care units, and bacteria die. By the way, it's our last resort antibiotic, and it's a beta-lactam. It's a derivative of the penicillin. So imagine we discovered penicillin in 28, and 100 years later, we are still using a derivative of the penicillin as a last resort antibiotic. This is to what extent we are really running out of antibiotics, still playing around with modifying small residues of these old antibiotics. Then you say, okay, maybe we are then developing vaccines, because vaccine is a good way to fight against antibiotic resistance. If you vaccinate against a disease, viral or bacterial, viral as well, because if you vaccinate against influenza, you will have less bacterial diseases, complications. And if you have less bacterial complications, you will use less antibiotics. So it's not only vaccines against bacteria, but also against viruses. Then you say, well, probably we are developing many new of these vaccines. But if you have a look here, Pseudomonas, Acinetobacter, Enterobacter, all these bacteria, all these that are the top killers on antibiotic resistance are the ones that we are not developing any vaccines of. So we have a big problem there. So we have been using then antibiotics in humans, animals, and the environment, and this is right. And here's something that you may know, but it's very important to point out. When we talk about the use of antibiotics in humans, animals, and the environment, we are using antibiotics in animals, but we have no antibiotics in the food in Europe. The food in Africa, India, and South America is full of antibiotics. So it's very important that you do your masters here in Europe, but that you are aware that we are living in a bubble where food safety is very high. And in all our countries in the European Union, we take samples in the supermarket to measure with HPLC if there are residues of antibiotic, and if not, we throw all this food away, etc. That's we do only in Europe. But we've done analysis in India, Africa, and whatever. And while the animal is going to the abattoir, it still gets, a bit of tetracycline, so it doesn't get sick in the way. So the food is full of antibiotics. It's probably an important driver. So as a take-home message, the measures that you have to take in every single country to fight antibiotic resistance are very different. And I will show you what we should maybe do in Europe. But food, for example, it's full. And then some people think that because we are using growth promotion. Growth promotion is forbidden in the European Union since January 2006. I assume you all know what it is. It's giving small amounts of antibiotics to the animals so that they grow faster, but it's forbidden in here, but not forbidden in many other countries. So growth promotion is also probably an important driver of antibiotic resistance in many countries. So we're using antibiotics all over, and the environment and everything is full of antibiotics. The first patient that was treated with penicillin, you remember this fungus from the plate of Fleming? It's not producing a lot of penicillin. So it's very complicated to isolate the penicillin from there. So the first patient that was treating with penicillin, we were taking out the urine. I do like this, but it's not very nice. We were taking the urine. The urine was taken out of the patient. The penicillin was re-isolated from his urine and then re-injected to the patient. So it was to that extent complicated to isolate penicillin. And that also tells you to what extent penicillin comes out of the patient actively. So all the antibiotics that we're giving to the animals and to the humans actively, this is why I tell it here, actively go out to the environment and make pressure and antibiotic pressure in the environment as well. So they don't stay in the patient at all. Is it good or is it bad that really the environment and everything is also involved in antibiotic resistance? I think it's good, because that means that to fight antibiotic resistance, we don't only have to fight in the hospitals. We can do also things in the animals, in the environment, and that we must use a One Health approach to tackle antibiotic resistance. And we can help in a farm and in a river to save patients in the hospital. So we are all involved in this problem. When we think of, okay, we know the problem, so we'll probably are very careful with the use of antibiotics in the world. I assume that you all know, it's obvious, that the more antibiotics we use, the faster the bacteria become resistant to antibiotics. I think that we all we will know that. So this is how we use, you should know Spanish by now, in high-income countries, low and middle-income countries are low. And what you see here is that the amount of antibiotics that we're using in the world is increasing. So we are constructing hospitals in Africa, we are constructing hospitals in Latin America and in Southeast Asia. We are constructing hospitals, we are using more last resort antibiotics that we use in the hospitals, and therefore antibiotic resistance is increasing worldwide all over. And once there's an antibiotic resistant bacterium, it's the same as with any other virus or whatever, it spreads all over the world easily. So the prediction, as you know very well, is that by 2050, 10 million people will die by antibiotic resistance. It will be the same cost. I know it's a classical sentence. I don't like it very much, but it's, you have to say it. And today, there's another paper that says that today, 1.2 million people die from antibiotic resistance every year. From antibiotic resistance means patients treated with antibiotics and the antibiotics don't work, okay? And obviously with COVID, we have used more antibiotics, and using more antibiotics, there were more antibiotic resistant bacteria. You were seeing these intensive care units, a lot of respiratory, artificial respiratory apparatus, a lot of infections, and more use of antibiotics. So it accelerated even the problem of antibiotic resistance. And this is the last prediction that was published. So you see that the antibiotic resistance in children will probably drop in Africa because we are vaccinating. The vaccination programs in Africa are working very well. So we are probably going to have less antibiotic resistance in Africa, but we are going to have more antibiotic resistance in elderly people. So we are living more time. The elderly people have more comorbidities, and the more comorbidities you have, the more antibiotics you use. And as you can see, in Spain, it's the country in Europe where the antibiotic resistance will increase more. Why? Because we are producing elderly people and importing elderly people from Europe, that when they retire, they go to our hospital, to our beaches, and to our healthcare system. So our prediction is that we are going to use a lot more antibiotics thanks to you. No, we are welcome. But this is a real problem that because we are, with all these elderly people, the prediction is that we will need more antibiotics in our hospitals than we would use if we would not have that situation. So this is what we are preparing now for this pandemic. So you say, okay, Bruno, you're talking, you say that antibiotic resistance is important and the most important issue, because all scientists, we are so egocentric that we also always say that it's our health, I think, is the most important. But I have an objective data. In 2016, there was a meeting of the United Nations exclusively devoted to antibiotic resistance. Only 4 times in the world, there was a meeting of the United Nations exclusively devoted to a health issue. Only 4 times on life. It was always weapons, wars, etc. Only 4 times. HIV, Ebola, chronic diseases, and antibiotic resistance. So that shows really that the most important issue is antibiotic resistance. But the fact is that this was in 2016. Only in 2024, we had to repeat this meeting. So only 8 years after, we had to organize another meeting on United Nations only devoted to antibiotic resistance and only devoted to One Health. So we are really in an urgent situation where we are using more antibiotics, more resistance is gathering, and it's not only me, it's all the countries in the world that agree that this is the most important problem that we have in the world that we have to tackle from a One Health perspective. Is it true that bacteria flow, because we have this question, flow from humans to animals easily? So we have the Salmonella cases, Salmonella enterica, so real normal Salmonella or whatever, that we have more than 70,000 deaths per year in the world. Obviously, they are not here, but they are here, sub-Saharan Africa, mainly. All these people die, and all these people die with a transfer of bacteria direct from the intestine of an animal to an intestine of the human. All the Salmonella cases that we have in the world is Salmonella in the chicken or Salmonella in pigs that directly drives through food into our intestine. So yes, we know that every antibiotic used here in animals and every resistant bacterium that we create in animals using these antibiotics finally end up in a hospital in the intestine of a human. So yes, bacteria flow, especially in some places, directly from humans and animals. But my question is, here, this is the United States, for example, how many people have touched or have been really in contact easily with a cow? Not many. So what is happening in Europe, but these people are in direct contact. So in Southeast Asia, for example, the direct contact of humans and animals is very tight. So in some regions of the world, we have really to take care about the antibiotics that we're using in animals because they directly flow to humans. But what happens in our European bubble, where food safety is so high and you don't sleep with your chicken every day? This is happening. Half of the Europeans have a pet at home. Half of the Europeans. And most of them are very happy to say, look, I'm here sleeping with my cutie. So us, with our One Health and microbiological view, can see the flow of bacteria here all over, you know, in both directions. And both directions is important because we have studied bacteria that are present in small animals in Madrid. And what bacteria are these? It's the bacteria that we have in our intensive care units in our human hospitals. So you come out of the hospital cured colonized by the bacteria from the hospital. You go and you touch your pet, and your pet has the Klebsiella. He has never seen a carbapenem, intravenous penicillin, never seen. But you come out of the antibiotic, and the superbugs that are living in the intensive care units colonize then your dog. And this is it can be a very important problem. And this is what we're trying to tackle today. What happens with the people that come out of the hospital, colonized by all these hospital bacteria that don't stay in the hospital, that they go out, this is one health is so important, that they go out and they are spreading then this bacteria all over, including our pets. Are pets important as a public health problem? We don't know. We are starting to find, but what is sure is that there may be a public health risk. For example, when you say, oh, the children are missing their pets in the hospital, let's bring the pet. And if the pet, you know, is full of this bacteria, the pet is probably bringing more bacteria into the hospital than they have ever been in that hospital. So we have to be a bit careful. So I'm organizing a European thing so that we maybe test animals for vancomycin-resistant enterococci, carbapenem-resistant E. coli, Klebsiella, so to screen them a bit before just letting them flow into the hospital, including horses also that are used for therapy. We have to be maybe a bit careful. So not everything is happy flower, animals will come. We have to be also responsible of a public health problems. And this is one of the last things that I wanted to show you. One work that we have done in Ghana, for example, so we work a lot in Africa for many years. It is the wastewater of hospitals. What is happening with the wastewater of hospitals? Because in hospitals, you use we use last resort antibiotics, and what we see is that per milliliter of wastewater in the hospital, we find 10 to the 5 bacteria resistant to carbapenems. 10 to the 5 bacteria resistant to carbapenems per milliliter of wastewater. And carbapenems is this last resort antibiotic that is only intravenously used in hospitals. And this is flowing through the wastewater system. And you say, well, wastewater system, don't exaggerate. Wastewater system is, you know, but wastewater system in Tamale here in Ghana is this. Surface wastewater that directly is in contact with the animal, with the humans, in contact with animals, goes directly into these places. And if you know Africa well, this is drinking water, so it directly flows into the citizens again. So there is really a flux between the environmental bacteria and bacteria that we use in the hospital and against humans. You see here, so environment is obviously important. So you see here in this work to what extent temperature and the change on land of temperature is increasing antibiotic resistance to all these different antibiotics, carbapenems, E. coli, Klebsiella, etc. So the main driver of increase of antibiotic resistance in the environment is temperature. And if you see all these different parameters, population, antimicrobial consumption, international tourists, coverage, out-of-pocket expense, from all these factors that you would say they are very much related to antibiotic resistance, the most important factor related to antibiotic resistance is climate and this temperature. So there's a direct link. It's not antibiotic consumption, it's temperature is the most important link in antibiotic resistance. And as you can see here very well, this is the change in temperature in the United States in 3 years. And this is the change of resistance in the United States in 3 years. And you don't have to be very smart, but you see that this diagram does completely overlap this one. So resistance overlaps directly with the temperature increase in the United States. And if you see the projection to what is happening and what can happen with only 10 degrees of change in temperature, we will have 4.2% of E. coli that are more resistant, 2.2 Klebsiella pneumoniae that are more resistant, and 2.7 Staph aureus that will be more resistant. So clearly, the temperature in climate is a driver of antibiotic resistance. But sometimes you say, is it only because the bacteria then like multiply a bit more and then difficult to understand, no, really. So the consequences of climate change on antibiotic resistance are huge. In all terrestrial environments, and I will show you how, in all aquatic environments, there are shared drivers, there's harmful synergies between the human activities and the influence of microbial changes, there are shared solutions, antimicrobial influences climate change clearly, and also between health. How is this climate affecting, and with this I will finish, is this affecting all these bacteria? First, just 2 minutes more concentration. I don't disconnect, I see you. First, directly into the bacteria. Bacteria, when we increase temperature, bacteria increase the SOS response. The bacteria have an SOS response that manages horizontal gene transfer. There's more transfer of resistance between bacteria in all conjugation, transduction, and transformation. There's more mutation rate when bacteria are subjected to more temperature. And in this, we published it a couple of years ago, even in integrons with a platforms that acquire resistance genes, they are also regulated by the SOS response. So genetically, already we know that bacteria are directly related to temperature and the increase of temperature. But that's not the only thing. Also, the ecological environments are completely and related to antimicrobial resistance and climate. More antibiotics are used when there's climate stress, more diseases, more antibiotic use. Warming oceans expand resistant bacteria better than cold oceans, so even ecologically, bacteria spread better, and the environmental contamination spreads resistant genes. So obviously, also ecologically, antibiotic resistance is spreading more with climate change. With the climate change, we have more extreme weather. So all the floods that we have spread resistant bacteria. We have a flood, wastewater comes up and spreads all the fecal material through the population. So we know very well that every flood is leading to resistant bacterial spread. Droughts as well, because we reuse more wastewater and there's more antibiotic risk. Heat waves degrade antibiotics and vaccines, and permafrost thaws, and there are many resistant bacteria and diseases there, and they also go and then finally infect us and also the animals. So extreme weather and climate change and antimicrobial resistance is also led. Socioeconomically, this is very important. Low and middle income countries are the hardest hit by climate change, and they are also the ones that they have the more fragile health system. We know that healthcare systems in Africa are very dependent on antibiotics because the prevention systems are very bad. So as soon as we have impact in low and middle income countries of climate change, we have also on antibiotic resistance. Obviously, people can't pay and afford all these antibiotics that they need, and there's an uncontrolled use of antibiotics. People go out to the market and buy it because in the pharmacy the antibiotics are too expensive. I think you know that. And climate migration and wars obviously make the spread and creation of antibiotic-resistant bacteria. And last not least, politically, we have to fight against antimicrobial resistance because everything is interconnected. The climate mitigation is also AMR mitigation, so they go hand in hand. And we have many neglected pathogens that will also spread more with climate change. So we have antibiotic resistance, but there are also many things that we can do to fight antibiotic resistance. The clue is, as I told you, to work together, humans, animals, and the environment, but also to work all professions together. In this sense, the universities are also not working alone. I'm working and leading a European alliance of universities. So we are 11 universities, and our main pillar of activity is One Health. So if you're interested in One Health and PhD thesis and what do you want to do, this is the only university alliance that is working exclusively on One Health. So I invite you to join us. For example, the next 6th of November, we are doing a One Health seminar. We do it every year, and we're doing every year also a summer school on on One Health. Next year, it will be held in University College Dublin. It was called. We had one in Edinburgh, in Berlin last year. So there also you are invited to go. So as a final takeaway message, climate resilience policies are also AMR policies, and One Health is obviously essential to tackle both crises together. This is why I'm optimistic, because you are a One Health generation. And there are not so many One Health generations. There are people like us that have learned and created and disseminated One Health, but now you are a real One Health generation. So all my faith is deposited on you and how you are going to tackle all these problems in the future. And if you want to join us, obviously, you are very welcome. In Madrid, we always need smart people. So it's these people that work in my lab, but these people that have worked in my lab, so you are really welcome. And I wanted to thank you for your attention. Thank you.
Thank you. Thank you very much, Bruno, for the lovely presentation. I think we have time for one question in the room. I see here one question.
Thank you very much. I have one comment and one question. Could you maybe go back into your presentation? There is a cyclical representation with animals and humans.
Well, there are many arrows missing.
Yeah, but
if you want to pick that out.
Can we get back the slides?
Can you correct me? But in my understanding, the main risk, direct risk from animals is really Salmonella and Campylobacter. But otherwise, I'm not aware of much direct risk for human antibiotic resistance.
Yeah, but you're fully wrong. But that's no problem. Science is like that. The transfer, it's true that the direct transfer of bacteria from from animals to humans is Salmonella and Campylobacter, because there we have the whole bacterium that flow, and we find the same bacterium in the intestine of the animal.
Yeah. No, that's what we measure also, yes.
This is that I fully agree. But all bacteria have mobile genetic elements inside and plasmids. And what we are seeing a lot this lately, and you probably know that as well, is that we don't find very often the same bacterium, but we find the same mobile genetic element, the same plasmid. So this is why this thing is a bit
what is the evidence on that it is really coming from animals?
Well, sometimes it's coming from animals, and as I showed you, sometimes it's coming from hospital. I think the One Health concept is not so much based on pointing. What is it? The main driver depends.
No, but we need to know what are the main drivers of distribution and spread.
I know.
And on that,
I know.
I think things are not so easy.
No, of course it's not so easy. This is why I said that it's probably also ecologically dependent on the ecosystem. In Southeast Asia, the direct contact is very high. In Europe, where food safety is so high, probably Salmonella is not very important. Campylobacter maybe, because there are many cases. Probably pets in Africa is zero important, because people don't live a lot with their pets. But pets in Europe, probably yes. We are using a lot of, and that was the case in Switzerland, as you know, carbapenem-resistant bacteria in a Swiss hospital. So yes, I think it depends on the ecosystem. It's very complex, I agree.
And the last point is a comment.
Yes.
I don't think antibiotics were really driving population growth. I think it was general hygiene. TB declined way before streptomycin was discovered.
Yes, well, and we know, it's not an opinion, we know it. We know that it's the three factors. It's water hygiene, obviously that reduces a lot. It's the discovery of antibiotics with all the health systems on the hospitals, and it's the vaccines. So, there are many data that support it. But I thank you for your comments and your
Thank you very much for that question. Seems like there's enough room to discuss these topics in the break that's coming up. Before we go to the break, though, thank you very much, Bruno, for your lovely presentation.
Thanks.
And now to the stage, albeit online, I would like to welcome Dr. Max Kotz. Max Kotz works on climate change and the physical rationale behind climate change in the world and the implications, the implications of socioeconomics and on ecology. He works at the Supercomputing Center in Barcelona. And there he is, joining us online from Barcelona, I suppose. Thank you for being here, Max. The floor is all yours.
Yeah, it's a pleasure to be here. Thanks very much for having me, and I hope you can see my screen now. Yeah, maybe you could let me know if that's working.
Yes, we can. Thank you.
Awesome. Fantastic. Yeah. So thanks for the introduction. It's good to be able to speak to you today. And yeah, to learn a little bit more about this topic of One Health, which I've come to realize encapsulates some of the disparate aspects of my work quite well. So that's really nice. As mentioned, yeah, I'm a physical climate scientist who works a lot on changes in climatic extremes and also on their impacts on different systems. So I'm going to try to present to you today two recent examples of my work that look at the impacts of climatic extremes, on the one hand on ecosystems and on the other hand on humans. And hopefully that can be a little bit of a lens through which to approach this One Health topic. So I thought I'd start by just giving us a broad sense of the context of where we are with climate change. You may or may not be aware that last year, 2024, was the hottest year on record in sort of the modern instrumental observational era, exceeding even the 1.5 degree temperature limit that was agreed to be targeted in the Paris Agreement back in 2015. So obviously this is within our understanding of the long-term consequences of human emissions driving global temperature change. But particularly last year's temperature anomaly had quite a lot of climate scientists actually a little bit spooked in terms of the magnitude, and there's still a lot of work to go on and understand what the specific drivers of that year were. But it's very clear that this is in line with our understanding of human-driven emissions on the climate system. The point I want to make first of all is that this global phenomena has a wide variety of sort of local implications. And I think this is a nice little figure from The Guardian to sort of summarize that, which shows essentially the places in Earth in purple, where last year, 1 month at least was recorded to be hotter than had ever been previously experienced in that location. And we can see that it's about 2/3 of the world's surface, higher than that on land. And what this really means is that at the local level, the consequence of this global warming phenomena is that local ecosystems, local human societies, infrastructure systems are essentially being exposed to increasingly unprecedented, particularly temperature extremes, but also other types of extremes. So this is a really important aspect of this global change that we need to understand the impacts of. So I'm going to start with an example from some of my own work looking at impacts on ecosystems. And whenever I talk about the impacts of climate change on biodiversity, I always like to start with a deep time geological perspective, because I think it's really helpful for putting this in context. We know that through Earth's ancient history, there have been many events where large numbers of Earth species, over say 60%, have gone extinct in a relatively short geological period of time, often known as mass extinction events, which typically have a range of triggers, but which often involve rapid environmental change. And rapid environmental change is often considered some of the drivers of those mass extinctions. And we can see that quite clearly here from a nice paper that was published a few years ago, which essentially looks at the extinction rates in those events here on the y-axis against the magnitude of temperature change. And we can see this really clear kind of correlation, which also persists when we look at the rate of temperature change that was being experienced in those mass extinction events. And particularly this plot on the right-hand side can give us a little bit of context about the modern era, in which, as I mentioned, we've had about nearly 1.5 degrees now global warming over the past 100 years, which puts us on a scale of about 10,000 degrees per mega year, which is essentially 2 orders of magnitude off the right-hand axis of this right-hand panel. So essentially what we've experienced over the last 100 years, what we've driven through our own emissions, is climate change that is at least 100 times faster than the fastest equivalents in the geological record, which have driven mass extinction events. So obviously that's cause for concern, cause for potentially existential concern about the state of biodiversity on the planet today. But we also have a modern context, obviously, through which we can try and understand this problem. One important source of information for us is sort of the long-term monitoring of different species populations, with which we can try and get insights into their response to changing environmental conditions. In our particular study, we were interested to focus on the role of climatic extremes. A lot of studies look at changes in, say, average temperature, average precipitation conditions, but there's a lot of mechanistic, sort of physiological evidence as to why particularly high temperature extremes should likely play a substantial role in impacting a range of different types of species and different populations. And another thing that we were particularly interested to understand in our study is to really draw out the role of human emissions in terms of how much they've driven intensification of heat extremes and thereby how much they've driven impacts on these systems. And in the kind of language of climate science, what we would call this is essentially an attribution approach, which really tries to map out all the way from human emissions to environmental change to system impacts, which in this case is going to be ecosystems. So this study I did with some colleagues from Australia, some ecologists who are great people, and they're bird experts, also massive bird enthusiasts. So for the sake of this study, we were focusing on birds and impacts of heat extremes, really. So this top left panel is showing you the distribution of long-term monitoring of bird populations from across the world that we essentially have access to. There's fairly decent global coverage across different continents, different biomes, but there's obvious biases right towards North America, Europe, and Australia, where essentially there has typically been more money and more researchers to conduct this type of research. But it's the best kind of available data that we've got as a global kind of research community, so that's what we make use of. And we mapped this with data on direct pressure from things like human land use, human population density, using an aggregate metric called the Human Pressure Index. And we also then map changes in environmental conditions, changes in climatic conditions. We want to look at changes in averages of temperature and precipitation, but as I mentioned, we have this particular focus in this study on temperature extremes. So the bottom left map there is showing you the sort of thresholds of temperature for which we set a level to determine that daily temperature was an extreme, which shows this kind of geographic variability that you might expect, higher thresholds in hotter regions. And then in the bottom right-hand side, we can see how that exposure to temperature extremes for these bird populations has essentially developed over time. So in red, that's showing the aggregate number of days per year that have been considered a temperature extreme for tropical bird populations. And we can see how in the early 1950s, 1960s, we were sitting at levels of about 3 days per year. But by 2020, by the present day, we're looking at about 10 times that number of, say, 30 or more days, which are considered heat extremes per year within our study. And similar, increases, but much smaller across the mid-latitudes and higher latitudes. So within our study, we then start to take a slightly more complex statistical modeling approach, which I'm not going to take you through. I'll give you kind of the broad bones sort of intuition with which to understand it. It's called like a mixed effects modeling approach for those who do some statistics. But what we're essentially interested to do is to really look at how interannual variability in heat extreme exposure is related to interannual variability in the bird abundance. So essentially asking, in a given year where temperature extremes spiked because of local weather phenomena and climate change sort of combined, was there then a response in bird populations in the subsequent year? And we can do that while controlling for other known drivers of population abundance, including pressures from direct human land use change, population, and also while accounting for some internal ecological dynamics. And it's obviously sort of a correlative analysis, but I think there's a couple of points here that are quite nice to emphasize from a methodological perspective, which allow us to have a bit more of a causal interpretation of these correlations that we find. The first of which is that when we look at these interannual timescales, fluctuations in heat extremes are pretty much random. They're really determined by the chaos of the weather systems once we abstract from long-term trends. And that really brings us close to what we would really like in a sort of causal setting for example, in a randomized control trial to try and identify an effect of one thing on another. And a second point here is that there's no really plausible reverse causal mechanism at these interannual timescales. So there's no way that bird abundance changing 1 year to the next can thereby influence the heat extremes in that region. And with that, we can then, if we see a correlation, we can really be more confident that it's going from the heat extremes to the birds and not the other way around. So we do a lot of modeling work. There's a lot of details there. I just want to show you this, essentially the results, the main results that come out of this analysis. We really see that across different climatic conditions, heat extremes are one of the most important determinants of bird population growth rates and how they respond to changing environmental conditions. And this figure is really showing how those responses change geographically across space. So the y-axis is showing that essentially the response in bird populations to an extra day of temperature extremes. And in the red curve here is showing how that response varies across latitude. So there's a lot of previous work that indicates that latitude is an important determinant of species responses to environmental change for a number of different reasons. And we see that quite clearly in our context, that at low latitudes, tropical regions, there are substantial negative effects of increased heat extreme exposure, whereas at higher latitudes, these effects are much suppressed or even potentially positive. I think it's important to note here that the distribution of land area, which is shown in blue here, is much more focused in the part of the distribution here where we see these negative effects. So we essentially estimate that across 80% of the world's land area, we would be seeing negative effects of increased heat extreme exposure. And in black, we're just showing that kind of spatial distribution on the basis of biomes rather than based on latitude. And we can see a very similar pattern, which essentially implies that birds in tropical, low latitude regions are much more sensitive to increases in temperature extremes than birds in other regions, which is consistent with a sort of whole host of other kind of mechanistic case study level evidence. So on the basis of this kind of work, what we then wanted to do was ask more of this attribution type question, essentially asking, well, given that the birds seem to be responding to heat extremes, what do we think would have actually happened if climate change hadn't developed? If human emissions hadn't driven this massive increase in heat extremes, what would have happened to these birds? So to do that, we essentially have to first evaluate how human emissions have driven that increase in heat extremes, which we do with some methods from climate science that I won't really go into for the sake of time. We can then combine that with this impact model that I just showed you that describes how birds respond to heat extremes. And we can then use that to essentially build what we call a counterfactual scenario, which describes how the birds would have developed in the absence of human-driven climate change. Now, this figure is just going to give you sort of a high-level summary of the results that come out of this. And essentially here, every dot is showing one of these different bird populations that we were able to have to be monitoring. And the color is essentially indicating how much we estimate that bird population's abundance has changed due to climate change. And we're really looking at all of the impacts from 1950 up to the present day. And so, for example, if it's dark red, like it is here in Central Africa, that essentially means that bird populations today are 30% lower in their abundance compared to a world without climate change. And we can see there's that clear geographic pattern with larger impacts in tropical regions, which are typically on average around about a third, and then weaker impacts at higher latitudes, even some potentially positive impacts at very, very high latitudes. So this study came out last month, so it's a nice one to be able to present. There's a link there to the paper, Nature, Ecology, Evolution, that you can scan to have a look at, and also an easier reading version from a sort of journal piece at the conversation, on the right-hand side if you want to look there. And I think the main contribution of this piece was really to identify heat extremes as a major driver of bird abundance decline over the historical period. And it's been really interesting to see that because there's been a lot of reports from ecologists in the last 2 to 3 years from people who are really working in tropical, pristine forests, which are far from human disturbance, really not under any pressure of habitat degradation, but where they've really actually seen that birds are declining even in those habitats. And they've essentially not really understood why. They've posited climate change as a potential driver, but they've not really understood whether that's the case. And we think our study provides a nice piece of evidence to support climate change as a likely mechanism. Okay, cool. So that's first example done, heat extreme impacts on ecosystems and particularly on birds. And we're now going to switch our focus to this other aspect with regards to human well-being, essentially. And here I'm going to talk about it through the lens of agricultural impacts of climate change, which is a very widely studied topic. Farmers, people have obviously understood for a long time that different forms of agricultural crops are sensitive to weather conditions, and a wide range of modern research essentially bears that out. Obviously, there's potential beneficial impacts of CO2 fertilization, but what's very clear is that there's also nonlinear temperature responses of most major crops. So this is just one particular example from a recent study looking at crop frequency, yields, and overall production, and seeing how they respond to changes in temperature. You can see these clear nonlinearities that particularly mean that temperatures above, say, 20 to 30 degrees can cause quite substantial declines in crop productivity. And what some of my research has looked at in this context is some of the wider sort of macroeconomic almost implications of these impacts of heat extremes on agricultural production. And in particular, what we've been looking at is some of the implications actually for food prices. So there's been some interesting examples of that in the last couple of years. First of all, with regards to chocolates, you might not have noticed this because most of these price changes have been concentrated in international markets rather than hitting sort of supermarket shelves. But last year was really unprecedented in terms of a massive spike in cocoa prices in international markets that exceeded really anything that's happened in the last sort of 60 years. And that was essentially down to adverse weather conditions in West Africa, where 60% of global cocoa production is concentrated in Ghana and the Ivory Coast. They had big droughts and then followed by really intense heat waves that just massively damaged crops, reduce supply of cocoa to the markets, and cause this massive spike in prices. A little bit closer to home, if you live in Europe, is impacts on olive oil prices, which is one where we have actually seen this really play out on supermarket shelves. So it's one that you're more likely to have noticed. And again, this was down to substantial droughts in Spain, in Italy, around 2022, which then led to big impacts on yields, big restrictions of supply to the market, and large increases in prices over the next sort of 1 to 2 years. So these are examples from specific food groups, just sort of individual food items. But in some of the work that I've done with the European Central Bank, which has been trying to look more broadly, not just at individual food types, but at food price indices for sort of entire countries, which represent the general price of food for consumers. We looked at data from the last 25 years, looking at how, well, yeah, combining that with data on the exposure to climatic conditions and using similar statistical tools to isolate the impact of climate from other factors. And what we saw was that even at this aggregate level of food price indexes for entire countries, we can see clear sensitivities of food prices to temperature. So that's what this left-hand panel is showing. The y-axis is essentially the response of food prices to a given increase in temperatures. We can see how that plays out over time on the bottom axis here, where there are essentially these increases in food prices that persist for at least the 12 months following that increase in temperature. And we can also see some nonlinearities here, essentially such that higher temperature regions or higher temperature times of year, as shown in orange, for example, at 25 degrees compared to green at 12 degrees, they have a larger response of food prices to temperature increases. Now, what was really kind of important for my colleagues from the European Central Bank here was that this even has an effect through onto what they call headline inflation, which is a representation of overall prices in the economy. And that's what we show there on the far right-hand panel, which essentially means that for them, there's implications for monetary policy and sort of important macroeconomic effects there. So this study came out 2024. So again, a link for you to go have a look at it there if you like. And what's been particularly interesting, I think, for us as a research team since then, is that really last summer, there were even more examples of this phenomena really playing out in quite extreme ways with individual crop types, which we were essentially seeing getting reported on in media, with journalists actually contacting us to ask us about our study. So for example, in Korea, there were massive heat waves last summer, which caused big drops in the production of cabbage, then leading to really 70% increases in the price of kimchi over a matter of months. And that's a really important staple sort of cultural food product in Korea. Similarly, in Japan, really substantial impacts of heat waves on rice production that led to substantial increases, about 40% in prices. And yeah, that's the same example there from olive oil from some years before. And so what we've done in a slightly more recent paper that came out in the last few weeks was trying to essentially map different examples that we've seen really in the media landscape where people haven't had to do a technical, detailed statistical analysis, but industry experts, consumers have essentially seen this phenomena playing out for themselves. And it's been widely reported that adverse weather conditions have driven changes in the price of food. And we can see that there's really widespread examples of this from over the last 2 to 3 years. East Asia is a really prominent example of this with the heat waves from last summer, effects in India, China, South Korea, Japan, Vietnam, but also in Europe and North America. There have also been similar impacts from droughts in the last few years. So the coloring here is essentially indicating our analysis of the underlying climatic conditions that drove those effects. So in red, that's showing a heat event, brown is a drought, blue is a precipitation event, and the shading essentially indicates how extreme those climatic conditions were. So if we take the example of India, where there's large swathes of the country that were experiencing this very dark shading of red, that essentially means that those were temperatures that were hotter than India had ever experienced before in that location for that time of year. And we see particularly, again, for that East Asian example, that many of the heat waves being experienced there were essentially unprecedented and driving these spikes really in the price of food. Another part of this piece that we wanted to touch on was a sort of more interdisciplinary angle at looking at how increases in the price of food driven by climatic extremes could actually present wider risks to society across a number of sort of different sectors. So we had a quite interdisciplinary team, some health scientists, some central bankers, agricultural scientists, and we mapped out essentially 4 areas where we thought there was potential for these risks to sort of escalate through different systems. The first is quite an obvious one in relation to food insecurity and poverty. So it's clear from a lot of different work from food charities and also academic research that when food prices increase, the poorest in our society, the poorest households, often have to cut back actually on their expenditure on food because they don't essentially have sufficient income to buffer those food price increases. What's also particularly interesting is that some of the foods that they typically cut back on are normally some of the most nutritious, healthy food options, particularly fresh fruit and vegetables, which are some of the most expensive foods sort of per unit calorie. So it's not a good one to buy if you're just really trying to feed people. And so with that, we essentially, we think that there are likely going to be major health implications if this is something that's going to be playing out more and more in the future, which we discuss a little bit in this paper. We also spoke a little bit about potential impacts for monetary policy. So this is really connected to this point that we see that impacts on food prices can really then have implications for overall prices and overall inflation. And this is something that central banks are really having to start to think about. The European Central Bank in particular is doing a lot of really good work on that nowadays. And finally, we also discussed potential impacts on political stability. Now, it's kind of clear from sort of just anecdotal evidence from across history that volatile food prices can be a driver of political instability, but much more modern sort of academic work also shows that through kind of quantitative methods as well. And there's also quite interesting recent examples of that. So I mentioned that in Japan last summer, there was this very unprecedented heat wave, which drove increases in the price of rice. And since then, there's essentially been a major political crisis in Japan because of the affordability, general affordability crisis, but really the headline issue has been about rice. And it's caused the agricultural minister to resign, and really serious questions being asked about the incumbent political party, which has been in power for essentially generations in Japan, because they've got a very, very stable political system. So I'm going to close there with this broad slide, which shows the Earth, shows the context that we're in, temperatures at a global level becoming unprecedented and really driving these increases in extremes across the Earth. And hopefully these will have been two interesting examples to see how that increasing exposure to unprecedented climatic extremes can drive impacts across both natural systems and human systems with big implications for the welfare of both the natural world and the human world. So thanks very much. Looking forward to some potential questions.
Thank you, Max. Thank you very, very much. Are there any questions in the room or perhaps online? I see a question right here.
Okay. Thank you for your presentation. So I had a question. You talked during your presentation about so you did compare bird population without the climate changes. And I was curious, how did you create your model? What factor did you choose to create the theoretical model without climate changes?
Yeah, cool. So the generation of that kind of counterfactual is built on these kind of two methodological approaches. I mean, the first is the statistical model that I described to you in a little bit more detail, which matches and essentially uses the historical data to quantify how a change in heat extreme exposure is related to a change in bird abundance. And so that's what we have on the one side. And in that model, we're accounting for, also changes in habitat destruction, essentially through direct human pressures of land use change. And also, I mentioned in sort of internal ecological dynamics, by which I essentially mean what they would call in ecology like a Gompert-style growth model of abundance, where smaller populations to begin with will grow faster, and then as they get larger, they'll essentially saturate. And we see that dynamic playing out in the data. So that's the kind of things that we're accounting for with that statistical model. But part of that is a description of how birds respond to heat extremes. The other part to generate the counterfactual is then this assessment of how human emissions have really driven changes in heat extreme exposure. And there's a lot of work going on that in the climate science context. And we essentially use some of the methods from there. The two main different approaches would be to either use physical climate models, which can simulate based on essentially the laws of physics applied in a large numerical experiment, can simulate how weather conditions change under increasing human emissions. But what we do is we use some slightly newer techniques which use a detrending approach to essentially develop a counterfactual temperature scenario that essentially has a stationary temperature time series that doesn't have this big increase. And then we look at the difference between those two temperature time series to say, well, that's the change in temperature extremes that's been driven by a change in climate. And if we map that with our statistical model that says how, that has seen in the data how a temperature extreme change affects the bird populations, then we can put those together to start to build this counterfactual scenario of what the bird abundance would have looked like, how it would have developed in a world without that temperature extreme increase. I'll just leave it there because there's a lot of details. It's a fairly complex method, but you can look more in the paper if you want to have a bit more of an exploration.
Thank you for answering that question, Max. I'm sure the QR codes to the papers are a good source for this. In the interest of time, I want to thank you for this. Thank you for joining us. Thank you for taking the time today to join us. And before we move on to the graduate flash talks, I just wanted to mention that we, in the interest of time, we skipped over the questions that were asked online. During the break, we will approach the speakers and ask those questions to them, and then we will get back to you guys with a written answer. So during the second session of today, feel free to keep the questions online coming, and we'll do the same thing. So you'll get a response to the question regardless. Now, let's move on to a very exciting part of the day, namely the graduate flash talks. So we're gonna get a little bit of an insight as to what Idoh students do during their internship, the final semester of their masters, just before they graduate. And for that, 7 students are gonna come up here, have a presentation of 3 minutes. Please keep to your time. I will sit right here, and after 2.5 minutes, you will see my hand raise, and then please wrap up to be finished within 3 minutes. And we've also added a bit of a competition element. So on some of the posters around, you will see a QR code, and we'll project the QR code on the screen as well by the end. So after all the flash talks, please scan the QR code and put in a vote as to which presentation you find the most captivating, the most interesting, the most fun, whatever you think is the nicest to listen to. So let me welcome the first speaker, Tanjimul, I think. Good luck. And there's a microphone here, but there's also a microphone on the side in case this is too high or too low. Good luck.
So I'll speak here or with the mic?
Whatever you want. Either is fine.
Should you keep the time, or you should I start? Yeah. Okay. Imagine a family of 5 people: parents, young child, and their grandparents, sitting for a regular breakfast with cheese, milk, and vegetables. Life is beautiful, as they seems very healthy and happy. But what if I told you a tiny bug inside this food can lead someone from this room to hospital? This bug is called Listeria monocytogenes. And this is abundantly present in the environment, and through the animal food chain, it can infect human. And in human, it causes human listeriosis. And this is severe problem because it is not as well reported like other bacteria, Salmonella or E. coli. But dangerous is more even than that because it causes vulnerability to pregnant women, newborns, and mostly elderly people. In EU, it's reported 3,000 cases in 2023, and among them, 300 people were died. So we can realize its severity. So it's important to understand how it causes disease in human. So, because when it infects human, it's not affect same as to the newborn as to the older people. So in my research work, I address it with a study of mice. So I conducted a mice infection with Listeria, and I found that it has different role depending on the infection. And I discovered that there is a tiny enzyme called OTUD7B. It plays a role in restricting the infection because it has tiny factor called antimicrobial effector, and that kills Listeria and that protect us from this infection. But when you have deficient, Listeria will infect the macrophage, and then hence it causes a severe disease in human bodies. And these findings can be implemented to other pathogens such as Salmonella and E. coli. And it has a dual potential role, and nowadays it is also responsible for cancer and also some autoimmune diseases. So this OTUD can be work as a therapeutic agent, as a bridge between communicable and non-communicable diseases. So back into the breakfast table again. So when a family is eating something, inside is macrophage that's protecting them, and inside the OTUD7B, it makes this mightier. Thank you everyone for patience hearing.
Good job. Thank you for sticking to the time as well. The next student that I have on my list is Pima. Sorry, just press here. I don't think it works. I don't think it does. Ah, it does. Never mind.
Okay. This is Langa Hosichobo. He's a health worker in Mozambique. He's diagnosing a child who came with a complaint of fever, and this child was diagnosed to have malaria. But here's the question. What do you know about the child's home? Did the family have access to clean drinking water? What about the sanitation? And what about the level of caregiver education? And even the household assets? These are the information we do not usually hear when a child arrives at the outpatient department, but they may hold the key to why children get sick and the infection they may face. This is exactly what my study tried to do, to study the household characteristic and in children with infection under 5 in Mozambique. And I tried to do this with a One Health perspective, connecting human health, animal health, and of course, the environment health. My study was conducted in Zambezia province of Mozambique district. It was conducted in 2 health outpatient departments. And among them, we included 1,055 participants. So this is what we found. Among the 1,055 patients, we found that 38% of them were infected with malaria, followed by 24% of them with fever without focus, and 14% of them with lower respiratory tract infection, and finally, the 10% of them with gastrointestinal tract infection. All these 4 accounted for 85% of the total infection. So we took these 4 infections and compared to see what the household and environmental characteristic would look like. So what did we found? We found that malaria was concentrated in the children with the highest median age of 25 months year old. So, and the least was 15 months for fever without focus. So as you can see from the bar chart, we can say that we have an age varied across different diagnoses. Coming to the literacy of the caregiver, we found that 57% of the caregiver with children who were infected with malaria were illiterate. This imposed a significant public health gap in terms of health messages and the things they would do with that information. Coming to the wash factor, we looked at the water, sanitation, and hygiene. And we found that malaria and the GIT were concentrated in poor sanitation settings. And even the household, we saw that 32% and 22% of malaria were just have electricity and radio. So what does this finding suggest? To improve child health, we must look beyond the clinic and into the household through a One Health lens. My name is Bima Thapa. I graduated yesterday. Well, sorry, I just defended my thesis on the same topic, so it's very fresh. So if you want to know more information, just stop by and say hi. Thank you.
I believe the next person to be Ashley. Good luck.
Okay, maybe in the end this is better. So, it is estimated that there are up to 10 to the power of 31 viral particles in the world, but up to 99.9% of this so-called virus sphere could be undiscovered. This represents an extraordinary potential of viral diversity that could help us understand viruses that currently do and could in the future pose global threats. At the Holmes Lab at the University of Sydney, we use metatranscriptomics, sequencing of all actively transcribing RNA, to characterize wildlife viromes and expand the virus sphere. We use high-performance computing and our virus discovery pipeline on sequencing libraries from public databases and primary samples to assemble contigs and scan against protein, nucleotide, and virus-specific databases. We can filter out host and environmental sequences and ultimately detect both RNA and DNA viruses, including those too highly divergent for standard methods to detect. For my thesis, I characterized the viromes of Australian marsupials. These are an ancient mammalian group that evolved in isolation from all other mammals for 45 million years. They also are a great example of the current global biodiversity crisis, with 30% of species at risk of extinction or already extinct. So this group and studying these unique hosts offers the possibility to uncover hidden viral diversity found nowhere else in the world, and to better understand how virus-host dynamics shape ecosystems and evolution. Across 153 libraries and 22 marsupial species, I detected 11 novel hepaciviruses. These are the same family of hepatitis C virus, but they do not seem to cause disease in their marsupial hosts. By analyzing their phylogeny, I identified 2 distinct clades of marsupial hepaciviruses that mirror the evolutionary split of the marsupial hosts. This evidence suggests that marsupials and hepaciviruses were introduced millions of years ago and have been co-evolving ever since then. So what does this mean for the bigger picture? For marsupials, the interesting news is that despite global changes, they seem to have a relatively low viral diversity, which is reassuring for conservation efforts. More broadly, as climate change reshapes our ecosystems and virus ecology, I hope that I have persuaded you on the capabilities of metatranscriptomics as a tool for the surveillance of emerging viruses and to help us understand virus-host relationships. Thank you.
Thank you. Next up, Emma.
I talk to this mic? Yes, perfect. Good morning, everyone, and welcome to France, the country that invented Michelin stars and is famous for delicious food. Baguettes, croissants, quiche Lorraine, and even escargots. Let me start by asking you guys a question. How many people in this audience know how to cook one of these dishes? Please raise your hand. Okay. What if I would ask you the same question, but this time you are allowed to use a recipe? How many people are confident enough that they will be able to cook one of these recipes? Again, please raise your hands. I see more hands, that's very good. You may wonder why I would start this serious scientific talk with a question about cooking and recipes. But actually, this is a very nice introduction to the flash talk that I will be giving today on contingency plans. Think of contingency plans as if they are recipes that guideline veterinary services and governments what they should do in a step-by-step way and try to respond during an animal disease outbreak. So these plans are vital, as 75% of emerging infections in humans emerge from animals. And so that's why these plans are so important, and that countries are prepared when it comes to emergency preparedness. And that's why for my thesis, I analyzed how well prepared 5 African countries are when it comes to this emergency preparedness and the contingency plans. And to do this, I conducted literature review, and I also had interviews with international experts in the field, and I interviewed the respective countries of my study as well. And lastly, I had the chance to visit some veterinary laboratories all across the continent to really try and understand their emergency efforts. And so I asked myself, what makes a good contingency plan? Or in our analogy, a Michelin star recipe. Well, a plan earns 1 star in case they are able to compensate their affected farmers, so that underreporting of sick animals doesn't occur. They earn a 2nd star in the case they are able to include a wide range of stakeholders, such as the public health sector in the case of zoonotic disease animals. And these diseases are spreading from humans into animals or the other way around. The plan deserves a 3rd star when national legislation is up to date, for example, enabling the restriction of animal movement. Sorry, the star is there. So out of these countries that I analyzed, most of them had technically sound plans. However, However, most of them stayed on the shelf, and this was because of implementation challenges, like, for example, limited emergency funding, or even being unable to update their plans and include the emerging threats like the zoonotic capacity of avian influenza. So the question we should all ask ourselves is, how can we take these plans out of the shelves and try to really implement them in the future and make sure that everyone can enjoy delicious food at the end of the day? Thank you for listening, and please feel free to contact me during the lunch break if you have more questions on contingency plans, or if you want to share your secret recipe when it comes to escargots. Thank you very much.
Next person is Pratik.
Hello. Yeah. So, have you ever taken a sample from wildlife by yourself, or have you ever seen a video of wildlife technician taking biological samples from wildlife? So, if you have not seen that or not taken a sample from wildlife by yourself, I can tell you that taking the samples from wildlife is really, really difficult and risky for both humans as well as for both animals. Since 2 out of 3 human diseases originates from wildlife, taking samples and understanding the wildlife diseases is of utmost importance. So what if I tell you that you don't need to have a fancy equipment or fancy chemicals or tranquilizers to take samples from wildlife or to screen for diseases? What if I tell you that what if I tell you that taking a sample from wildlife is as easy as taking a water from a pond or taking a 45 ml falcon tube water from a water bin? So here I present a proof of concept study in which we are trying to figure out the feasibility of taking screening water from a wildlife associated water. So in my study, we screen for beta coronaviruses and antimicrobial resistance bacteria through the wildlife water bins. So the wildlife comes to eat the wheat as well as the water and potentially exposing their pathogens to the water bin. So we screen for them. So what did we find? We found many species of antimicrobial resistance bacteria, and we found it by by phenotypic identification, as well as we confirm it by whole genome sequencing. And for the beta coronaviruses, unfortunately, the results were inconclusive. So here I present a magic bin through which you can screen pathogens of wildlife, especially rodents. And for future direction, it can we can use this bin for even like a wider variety of wildlife pathogens, and also this could be also an important tool for a One Health perspective. Thank you very much.
Good job. Next is Irina.
Hopefully this works. Hi, everyone. So I completed my master project with Atana and Linnaeus University in an industry-academia partnership. My master project focused on utilizing the Atana QCM testing platform to develop a biosensor-based diagnostics for Lyme borreliosis. Now, Lyme borreliosis is a tick-borne disease caused by pathogenic spirochetes from the Borrelia burgdorferi sensulata complex, which is becoming increasingly more common due to climate change enlarging the ecological niches suitable for ticks to thrive. Now, this will also change things in terms of the IgG serological testing that we're currently using, because as background prevalence increases, it will make distinguishing past from acute infections more and more challenging. So this method kind of aimed to develop a combination between classical serological methods as well as merge them with quartz crystal microbalance technology, which has the ability to assess molecular interactions in real time on the surface of the biosensors. In short, the measurements are based on recording a frequency shift, which is directly proportional to the mass on the biosensors. What this means is that the method has the ability to detect the overall antibodies that are binding an antigen that is immobilized on our biosensor, as well as it can detect an IgG-specific response to that antigen. But furthermore, it can, through this real-time measurement, obtain data in terms of this interaction. So we can have data on the kinetics and on antibody binding and how strongly the antibody binds. So we can get a better idea of maybe the neutralizing ability of these antibodies. Now, preliminary testing has shown quite a lot of promise because we tested a small set of samples, in which case we were able to distinguish positive from negative samples. However, when we started going more into validation, we started to hit a bit of hiccups, which I call the plot twist of my project, in which case the biases are starting to show more and more variability. So we started to look into what possible causes for that would be, and it turned out that the antigen we were working with was actually a tetramer, which also meant that during the immobilization procedure, we ended up with a mixture on the biosensor of monomers as well as other multimers. Now, in terms of detection, multimeric structures are really good for ELISAs because we have multiple epitopes, it's great. But in terms of kinetics, monomeric and dimeric structures are absolutely necessary. Thank you.
Good job. Next person is Theodora. Careful. Good luck.
Thank you very much. If you'd be a cheesemaker in the Turrialba region of Costa Rica, this is how your dairy farm could look like. You'd be engaged in a century-long tradition of making cheese, and you'd probably have a recipe, a method, and tips and tricks passed on from the generations before you. You take care of freely grazing cows in the serene landscapes of the Turrialba region, which all of this sounds quite nice, right? However, there are also challenges. The increasingly competitive market pushes you to deliver a safer and better quality product, while maintaining a traditional and tasty recipe. Economically speaking, You want to extend the shelf life of your product without compromising its quality. At this point, as a cheesemaker in the Turrialba region of Costa Rica, you're faced with a challenge and you need technical support. And this is where our project comes in. In my internship, we looked at lactic acid bacteria coming from Turrialba cheese, Costa Rica's most popular fresh cheese, for potential antagonistic effects on Salmonella and E. coli. And the first question we have to answer is, why did we even do that? So as I said, cheesemakers from this area need technical support, not only to better understand the microbiota of the product that they're delivering, but also to increase its safety. Moreover, we have identified a knowledge gap. There is a lot of research on bacteriocins effective against gram-positive pathogens, but not against gram-negative pathogens as Salmonella and E. coli. So, how did we do what we did? So first, we isolated a few lactic acid bacteria taken from samples from the cheese producers in this region. We performed identification tests, gram staining and catalyzed tests, and at a later stage, mass spectrometry, and we conducted qualitative and quantitative inhibition tests. What did we find? And here the exciting part comes. By controlling for potential reasons for inhibition, such as pH value, we found one strain producing a bacteriocin effective against E. coli. This bacteriocin was produced by a lactic acid bacteria coming from Turrialba cheese, as I mentioned, which we identified to be Lactococcus lactis. We also found other strains with potential bacteriostatic effect, and we identified some improvement points in the production processes to increase biosafety levels on farm. And what does this all mean? Well, we have the potential to find other strains that produce bacteriocins and have antagonistic effects on other pathogens. We also have a potential, if we can isolate this bacteriocin, to bring it to an industrial level application. But most importantly, most impactfully, and most directly, we would help the producers from the Turrialba region, for whom cheesemaking is not just an activity that brings them money. It's something that connects them to their ancestors and to the place they were born in. Thank you very much.
Last but not least, I think we have Jeanne.
During my internship, I helped CIRAT to explore the ecoepidemiology of West Nile virus in Guadeloupe. West Nile virus is the most widespread arboviruses worldwide. And in 2024, an unusual episodic event occurred, making many neurological cases in horses. It was striking because usually the circulation was totally silent. But now, imagine you are on the scene of a crime. You know the aggressor, the virus. You know the weapon, mosquito. You know also the victims. Horses, but sometimes it could be even you. But you still don't know who are the accomplices that can maintain and amplify the virus locally. Birds, yes, but which species of birds? It was the core of my mission, and to do so, I deployed a huge fieldwork across 5 different areas in Guadeloupe, capturing and releasing birds after taking some sample. Back to the lab, I see for birds the presence of the virus and the presence of an immune response thanks to antibodies. In parallel, I also investigate the surgical status of dog population, trying to find a useful alternative host sentinel to replace the horse population that is now totally immune. I found at least 8 different species exposed, with a higher circulation around mangrove. But birds are not taking part to the same level of the amplification of the cycle. We have our carrier grackle that could be the main amplificator of the virus. We have also birds that are very exposed, like our common ground dove, or a raptor that could be highly susceptible to the disease, and plenty of birds that are not at all targeted by the mosquito. From the dog side, I found 1/3 of the population exposed. with many larger breeds. This work matters because knowing better the key player in the amplification of the enzymatic cycle and useful host sentinel can help to highlight some hotspots of transmission and address the early warning signal. In short, my work was finding the hidden accomplices and witnesses of our scene of crime. By listening the ducks and the birds signal, we are covering a missing piece of the puzzle toward a better prevention of outbreaks. Thank you for your listening.
Wow, I'm impressed for all the work that everybody's been doing. Good job, everybody. Let's give a hand to everyone. So, as mentioned, we're making this into a little competition element. So feel free to scan this QR code and vote for the talk that you found most inspiring, most interesting, most fun, coolest. I'll do the same. And then in a couple hours, we will announce the winner. And we also have a little gift for that person. Now, when you've done scanning this QR code that reads "Scan me," after talking about escargot, recipes, and cheese, we prepared some lunch for you. Lunch is outside. Please be back here by 10 to 2, 13:50. And see you then. Thank you very much.
Why do you think that is?
The presentation of AMR would have been the best example. But he was only focusing on public health. Look, the Canadian integrated antimicrobial resistance surveillance is completely integrated. Nobody even mentions it. I applied to ERC, to the Swiss National Science Foundation, studying everything in the integrated fashion, always in. No, the problem is these kind of projects are always evaluated by disciplinary specialists. They will always find a hair in the soup with regard to their own topic, and then it is rejected. And this is the big stumbling block why progress is so slow. No, at least it's on the agenda. I never thought that it would progress so fast. One Health has really taken the lead. But everybody talks about One Health, but very, very few.
Have you ever seen operations?
Yes.
There is?
We've seen a couple of views that
These integrated surveillance.
Yeah.
Mosquito, humans, animals in the same time. That's operational. We just had a breakthrough because we have transferred the integrated surveillance system in the cross-border context of southern Ethiopia and northern Market. And now we could establish mosquito surveillance with communities. So the communities have traps. They collect the mosquitoes. And I had a master's student, she extracted the mosquitoes, and now she found a West Nile virus case in a mosquito in a district laboratory, not even in Nairobi, but in a district laboratory. So these are the operational things that are passing. I mean, the Italians are at the forefront with West Nile virus.
Je sais pas.
Je crois qu'ils sont 8. But it depends also, of course, on the question.
On teste la vidéo là, c'est ça?
On essaye, oui. Activer le contenu. There we go.
Ok, je vais ouvrir le son.
Ok. Ouais, ça doit être ça.
Pour moi, c'est bon. Hein.
Ok, bah super. Rendez-vous à 15h45 alors. Merci.
Merci.
Hello. Hi, everyone. Hi, everyone. We would like to resume very soon, so please make your way back to the hall.
ça, il a de la place, s'il veut. Mais... moi, j'ai du temps là, j'ai du temps serré. Donc, si on veut plus séparer, c'est très moche. Donc, là, celui-là, il y a un, celui-là, il va aller à côté. Celui-là, si vous voulez,
Welcome back, everyone. I hope you managed to grab a few canapes during that lunch break, and that you're ready to engage again with us, because we're very fortunate to be joined by a rich array of transdisciplinary experts who, in their daily work, are tackling the growing pressures we face as humanity and exploring how we can adapt and overcome these increasingly harsh realities. And they will be offering us insights today into ways in which one can operationalize One Health by working collaboratively, creatively, and effectively with a systems thinking approach in order to safeguard the health of ourselves as people, other sentient beings, and the future of our planet. So let's begin the second session of Bridging Knowledge and Practice with our honored sponsor from Power Dian Energy, Antonio Vega from Tours.
Good afternoon to all. So I have to start after lunch, so not easy for you, not easy for me. Okay, let's go. So my name is Antonio Vega. I am acting as Chief Operating Officer at Bioinformatics, which is a company not so far away from Tours. So the company has been founded in 2013. Located close to Tours in La Ville aux Dames. Right now we are 21 employees, and our activity is to be a specialist in the use of the hydrogen vector aimed to the low carbon energy transition. And that's how we are going to make connection to health. So when you are talking about ecological translation, there is the link to reduce the greenhouse gases. And it means that at one moment we need to take care and to reduce what is the non-renewable energies like coal or oil, like you know. That is, we need to promote the use of low carbon energies. Among them, there is renewables. There is also nuclear, but this is also another aspect, another subject, but we are not talking about this. And we need to do this in order to meet the target. Talking about renewables, and there we are more in a technical aspect, the problem of the renewables is that they are intermittent. It means when they are available, you can use them, but yourself and every industries at the other hand needs to have reliable energy. It means that at moment on one side you have intermittent, on the other side you have users that need absolutely to have reliable energy. It means that there is only one way to face this, is to store energy. So we need to store them, and to store energy there is various ways to do it. Everyone knows urge means of storage that are dams. More or less the water is stored in big amounts in order to have potential energy. There is also batteries, and there's come why I am here, there is hydrogen. So hydrogen is one way to store energy. And there is also one thing is that we'll see later is that hydrogen is also depending on the way it is manufactured. Then after we are going to talk about what we call the colors of hydrogen. So this is also something we are going to explain. The activity of Bioinformatics is really to involve the hydrogen vector and to propose solutions to its end customers in order to have reliable energy and mostly electricity. And the products you can see here are generators of electricity based on hydrogen, or possibly also isolated sites that are using solar as a primary energy, and there is a storage of hydrogen. So in order to continue on this, there is a small movie, 1 minute and a half, that is going to introduce you what is exactly the use of hydrogen.
economic development is generating an increase in the demand for energy, especially electricity. In the context of the fight against global warming, this energy must be carbon neutral. These green energies also have the advantage of being available in all parts of the planet, including in the most remote and isolated places. However, these renewable energies are limited by their intermittent nature, and their large-scale use requires the ability to store them. The risk of power cuts is always present, regardless of the type of power supply used. To guarantee a reliable, continuous, and uninterrupted power supply, Pewdian Energy offers autonomous storage solutions based on hydrogen. Our SAGES autonomous station can be connected to photovoltaic panels, among others, to capture solar energy. This renewable, fluctuating energy is then stored by being converted into hydrogen using an electrolyzer. It is stored indefinitely in a tank and can be used at any time to generate electricity. When solar production can no longer power the home, the stored hydrogen is converted back into water and used to generate electricity via the fuel cell, and the energy is immediately distributed. Pewdian Energy's SAGES solution offers complete electrical autonomy 365 days a year, no costs associated with connection to the grid, reliable power supply, the implementation of microgrids on isolated sites.
Okay, I hope it is clear. So let's move on with the connection to health. So this diagram is coming from the World Health Organization, and it shows you that climate change represents an important threat to the human health. And as you can see, everyone has been impacted by the impact on our homes, the infrastructure, and also with larger events that are due to this. And you can see that there is wildfires, extreme floods, and also storms. So all of this has this impact, and one way is to reduce the greenhouse gas. So another way to represent this is the second sketch. More or less, it is hinting in the same. Is more maybe a better way to understand it. Is the climate change and the impacts on the human health, and also the link to the greenhouse gas. So when we are talking about the greenhouse gases, we can see that, of course, there is some of them that are natural causes that are counting for a quarter, but mainly, after you can agree on the figures or not, we're not going into this debate, but more or less 76% of the emission of greenhouse gases are coming from the human causes. As natural causes, you can see that there is volcanic activity, natural methane emissions for 24%. It means that is not total, but the main issue and the main cause is human on the emission of the greenhouse gas. On this greenhouse, 70% are coming from CO2 emissions, which is the main contributor. And this graph can show you from where this CO2 emission does come. And first of all, far away from all of them, with 16 billions of tons, is made by the generation of electricity and heat. Second by transport, and third by manufacturing and construction. So there is really a big issue on reducing the CO2 emissions. So this being said and set, just to give a figure where they do come from, the main contributor is certainly the largest countries and the heavily industrialized. First one is China. Second one is United States. Then after you have Russia, Japan, a little less Europe, India also, meaning the countries that do have a mix of energy that is mainly made from fossil energies. If we look a little into details, then you have a split among the countries. It's just to know where they are coming from. Europe can be very low because of the mix of energy, but also the fact that part of the production has been externalized. So we are not going to go into debate, is not the purpose. Coming on this, to give you some figures about what is the primary energy and what are the contributions in terms of specific energy, that is the energy that really you can take over, and on the other side, what is the CO2 emission. Let's start with coal. Coal is mainly made of anthracite, and 1 kilo of coal is giving you 8 kilowatts of energy per kilo, but then you are rejecting 2.4 kilos in the atmosphere. Natural gas is having the same impact, but for 1 kilo you have nearly twice the energy. We have the same figure for diesel and petrol that you put on your cars. Okay, the unity is 1 liter, but anyhow, you have roughly the same contribution, and the specific energy is a little less. And at the end, you have hydrogen, so you can say, wow, 1 kilo of hydrogen, there is absolutely no carbon emission, only water. It's fantastic. And the specific energy for 1 kilo is the highest, which is well known. So we can say, well, hydrogen is not so bad. In fact, it's true and not true. And then this introduced to this slide is what we call the colors of hydrogen. You have heard about green, blue, brown, black. Every day there is one color. Anyhow, just to give you a rough idea, the colors are depending on how the hydrogen is produced. And depending on the how and the way of the process, the hydrogen can be more or less CO2 emissions. So we have talked about zero carbon emission. Well, the green, but it's only part of 0.3% in the world production. It's peanuts. The second one, and far away from the largest, is what we call the steam reforming of natural gas, is accounting for 83%. It's quite the highest. But the cost in carbon is quite high. Second one is with the coal. So it's not so good. And there is one, so let me introduce to another color. It's like a rainbow. So this one is pink. Pink is linked to what? Is to nuclear. So we can be again or pro-nuclear, that isn't the purpose, but basically when you are producing electricity from nuclear, there is absolutely no carbon issued. After there is the question of the waste, I agree, but anyhow, today nuclear is 1.9 of the world production of hydrogen because of electricity. And this being said, it appears that nuclear is not so bad if we put aside the waste with a competitive energy source and most of all, the capacity to produce a lot of hydrogen. Anyhow, so, sorry. So the colors, the colors at one side, and everyone every day decides to put a color. So that's the reason the there is an European directive that has been issued in 2023 in order to define and to get rid of those colors for what is a low carbon hydrogen, and it is something that is having a CO2 footprint lower than 3.3 kilograms of equivalent CO2 over 1 kilo of hydrogen produced. Okay, so now you are a specialist of hydrogen. So let's go to something, a practical case. My company has been commissioning last year. And this is really the results. But before this, just to give you a last information on hydrogen, hydrogen is the lightest gas on the universe. So it means that if you have 1 cubical meter, the weight is only 89 grams. It's very light. And we need 1 kilo to have 33 kilowatts. So it means that to store and to transport large quantities of hydrogen, you need to compress it. And this is something that is not so easy because of the pressure that is involved. So if you have a classical 40-ton truck, more or less you have 20,000 liters of tank, and you can put 20,000 liters of petrol inside, 1 per 1. If you take the same truck and you try to put some hydrogen, with a pressure that is 30 times higher than the atmosphere, you only succeed to put 70 kilos, which is not a lot compared to the 40 tons of the truck. Okay, so it means that you need to increase the pressure, and you can see that on buses, trucks, or cars that are moved by hydrogen, sometimes you have a 350 bars tank or a 700 bars tank, and the reason is that the volume that is involved to store 1 kilo of hydrogen is reduced nearly twice each time you double the pressure. So that's the issue. What those tanks look like? Something like that. For low pressure, 33 bars is steel. After you can go for a composite or steel tank for higher pressures. And when we go to very, very high pressure, then more or less for the weight and the thickness of the walls, you need to go for a composite or rather fiber carbon tank. It is what they have in the cars, for the only ones that are there. Okay, there is another way to deal with hydrogen is liquefaction, to have the gas become liquid. In liquid, you can put 90 kilos of hydrogen in 1 cubical meter, which is more compact by 1/3 than 700 bars. The only drawback is that you need additional energy to have it liquefied, and the temperature is minus 253. On the other side, the tank is very simple. Anyhow, so just to give you a figure, the Ariane 5 rocket, when it is launched, in addition to the Powder rocket, there is 51 tons of hydrogen inside the rocket in order to perform the satellite final launching, which is not so bad. Okay, so now let's go for an example we deal with 1 year ago. It's a telecom site that has been installed in France. A BTS is what is more or less a radio station that every one of you has to communicate with when they are using a mobile phone. It is the basic cell to allow the telecom network. So we have had a customer that is TDF that needs to power temporarily a new BTS during the period needed to be connected to the public grid. That is, EIDs sometimes takes few months in order to connect the BTS to the public network. At the same time, this operator was willing to promote and to share feedbacks also an alternative solution to the classical diesel genset. So it was for him also a way to try to see what he was evolving in terms of safety, difficulties, response, performance. It is classical to perform one thing before to go to a larger deployment. So also to learn from this experience to define a strategy for the sites. Well, okay, so what we have put on site is hydrogen, a generator using hydrogen as a primary energy and delivers on the output a classical electricity feeding 230 volts with 6 kVA. So what the site looks like, so a BTS, there is the tower with at the top the radio transmission where your mobile is connected, and here you can see the assembly of the cylinders where the hydrogen is stored under high pressure. So here is the generator, electricity generator using the hydrogen as primary energy. And for those that are interested, some figures, it's the BTS average power was 1.7 kilowatts. The high pressure tanks were made of assemblies of 16 cylinders, so it means that at one moment on site we have 50 kilos. And we need to replace them nearly 2 times a week because of the consumption. Let's go to the results. First, in terms of power, the average power was 1.7. We have used 3,600 kilowatts, and the hydrogen used was 302 kilo, and because of the packing, there was a little more than that. Okay, so this is the inputs. Now let's go and see the carbon footprint. The carbon footprint on this, you can see here that the hydrogen produced was made based on renewables with electrolysis, so it means that's what we call the green hydrogen. And there, everything has been calculated in order to have a figure that was really making sense and that we can demonstrate. So more or less for 3 months of experimentation, we have close to 2 tons of CO2 that has been emitted in the atmosphere, taking into account first the hydrogen, but also the transport to the site, to be fair, and also the fact that there has been a couple of technicians that need to go on site. If we compare this solution to the hydrogen produced by natural gas, mainly CH4 reforming, then we have the global carbon footprint that is nearly multiplied by 2.5. So the bill has increased. And then if we compare to a classical genset, then we go to 5.5 tons, which is mainly 3 times. So hydrogen is good, but as far as the production is really made from renewables. At the end, more or less, the system has worked very good compared to the classical, genset with a very good availability. The customer has decided to move and to combine solar in order to reduce the hydrogen to be bring on site. So this is positive. At the same time, you have to know that hydrogen today is very expensive because the production is not in large scale. So the price to its deployment is really the main obstacle. And due to this, it is not very competitive to diesel groups. So we need anyhow to reduce the cost and to go in mass production. Is it something unusual? Yes and not. Everybody remembers 25 years ago when the solar panels were introduced. At the end, it was very expensive. Then after, it goes to mass production. And then at the end, today's solar production electricity is now competitive compared to other solutions. So can we afford to have this input money at the beginning? That is the question. And the same for the electrical cars. Okay, so anyhow, the results are there technically. What is missing is the cost. Okay, so this is to give you an example. Just before finishing and to show you hydrogen can be used in all those areas. It's very large, and hydrogen can be really replacing some fossil energies and reduce the carbon footprint as far as it is produced the right way. So it can go from buildings to isolated sites or to boats, why not? We have seen a BTS location, but we have another application in the Netherlands, which is a Rijnstad hospital close to Amsterdam. The customer target was to use renewables for energy self-consumption and green injection. And here is what looks like a quite large installation. You can see the 2 cylinders there are the storage that can store up to 300 kilos. And then after you have the containers with the electrolyzer and the fuel cell. And what is interesting is that the commissioning has been not done so far again, so there is already some results. But when the installation will be used over a year, ultimately they will have 150 tons of CO2 per year not rejected because of this. Second and last example is coming back to Ariane Group, which is the manufacturer of the rockets or the engines for the Ariane rocket. They are using very large amounts of hydrogen liquid, and this hydrogen is naturally evaporating and it goes in the atmosphere. So the customer wants us to gather, to harvest this hydrogen in order to produce electricity, first to save some money, and second to reduce its carbon footprint. So let's go back directly to the result. The result is that there has been some savings on the electricity produced. Also, there is the carbon footprint that has been reduced, and this system over 1 year ultimately will be economize nearly 13 tons of CO2 and produce nearly 200 megawatts of electricity. And the carbon in France is not so much carbonated. It's only 60 grams with the mix and the total life cycle of the equipment. So it's not so bad. Okay, thank you for your attention. And if there is some questions.
Any questions in the audience?
It's just after lunch, it's very difficult.
Yeah. What about online? Oh, we have one.
Thank you for your presentation. I was wondering, is there any risk of explosion with this kind of under pressured gas?
If the hydrogen is under pressure, there is itself the pressure doesn't perform an explosion. But hydrogen, like natural gas, when it is mixed with oxygen, there is a percentage starting at 4% up to 75%, where if there is some additional energy, then you can perform an explosive atmosphere. So yes, but no more, no less than natural gas, except that the window of inflammability is larger, and this is one of the points of hydrogen. But I was saying to somebody is that when you are putting some petrol in your car at the pump, there is a small area where it is explosive. But nobody takes care about it because it is safe and we are connected to the earth in order to avoid any energy. That's the reason electrostatic energy, which is only a few microjoules, can perform an explosion. And that's the reason people are connected to the earth on the pump in order to avoid this. But they don't know. It's just use it.
Thank you, Stephanie.
Thank you.
Thank you, Antonia. Okay, so next up, I have the honor to present our keynote speaker for the second session, Dr. Nusrat Khan, who's come all the way from London. So Dr. Nusrat Khan is leading the co-creation, implementation and evaluation of multi-sectoral interventions in Bangladesh, India, Indonesia, focusing on context-specific environmental issues, and is really concentrating on data-driven health interventions and striving to reduce health inequalities and the quality of care. Really, really excited to hear what you have to say a bit more in detail. And yeah, please come to the stage and welcome her with a big round of applause.
Bonjour, merci de m'avoir invité. Please don't be alarmed by my French accent. This is all I managed to learn on Duolingo so far. So I can assure that the rest of the talk will be in English. So today I'm going to share some of the work we are doing as part of the NIHR-funded Global Health Research Center where I'm based. And we're trying to tackle issues around non-communicable diseases and environmental change. It's quite a mouthful. And particularly focusing on a case study to show how we can meaningfully co-create a solution in such settings. I should mention that we are not focusing on animal health in this context. However, I hope you can learn how we can transfer and translate such methodology and process when you're working in similar settings. So, before we dive into our case study, I just wanted to reiterate the urgency to take actions now. As Barack Obama once said, we are the first generation to feel the effect of climate change and the last generation who can do something about it. And as we can all see, climate change related news is all over in our news feed these days. And between 2030 and 2050, climate change related deaths are supposed to affect approximately 250,000 additional deaths. Could be caused by malaria, diarrhea, malnutrition, and heat related stressors. And this really urges us to take action now. And now I'm going to tell you a bit more about this specific issue in Indonesia. But first of all, can I ask, how many of you have heard about using plastic as a fuel? Okay, few hands. So this is a relatively common practice in Indonesia. And how many of you have come across such practices in countries like the UK or France? None, right? So yes, in developed countries like the UK or France, we don't see such examples, but this is still affecting low and middle income countries like Indonesia, where a lot of plastic waste come from Western countries. And this is a picture of a factory, tofu factory in Indonesia. And you can see how they are burning plastics to actually produce food in such settings. Now, a recent study that was conducted in the UK has shown that we are now finding microplastics contaminating the very bottom of the food chain, and microplastics in beetles, earthworms, and you can see how that in the food chain, then the later parts it's going to affect. And putting that into context in Indonesia, you can only imagine how the amount of microplastic that are being contaminated in the food that's being produced, the animals and livestock who are eating this food and contaminating the land, and let alone the amount of exposure these industry workers are being exposed to. So it's really important that we need to develop solutions so that we can reduce such exposures in these settings. So my previous speaker has kindly presented this slide for me, so I'm going to skim over quickly. But really, this beautiful graph from WHO shows that how different health-related risks are linked to adverse health outcomes, so including air pollution, heat, extreme weather events, to various type of health outcomes, not only physical health, but also mental health. And this really calls for an integrated solution. And by now, you should have memorized this. I'm the third one to present this slide diagram. So reiterating the need for collective action and collaborative change in this setting through bringing in different sectors such as environment, health, and human health studies. However, as it was emphasized in the Lancet 2017 report, although we do recognize the need for such interventions, the progress that's been made in the research is really staggering. So when it comes to actually implementation, barriers to planetary health policies remain formidable, and it's often neglected by the research community. So that reflects in some of the recent research funding that has gone into developing solutions recently, and that's where our center's activity comes in. So as mentioned previously, so we are working across 4 countries and in 3 LMICs, including Bangladesh, Indonesia, and India. And in all these 3 countries, we are focusing on context-specific environmental changes and their links to health risks. To give you an example, on top in Bangladesh, we are focusing on coastal areas where climate change is causing more storms these days. And these storms are linked to increased water salinity in these areas, which evidently relates to higher cardiovascular diseases and hypertension. And in India, as one of my previous speakers mentioned about the impact of agriculture on health, there is the link to dietary diversity in public food programs. So we are trying to develop solution in how we can develop more locally produced food and in return have a benefit of environment and health. And finally, in Indonesia, as I mentioned, so we are working on reducing plastic burning events in our study villages. And in each country, we have both the health systems component to strengthen primary healthcare system by developing digital health tool, but also the multisectoral intervention component, where we are also bringing in a lot of other different sectors, NGOs, to collaboratively build solutions to try to tackle the issues on the ground. So I'll be focusing more on the multisectoral intervention development process in the later phase, and starting with the Indonesia topic. So this is a picture from one of our study sites. And as you can see, there are plastic, shredded plastics in all forms and shapes covered the areas. And to give you some facts about Indonesia, so it's the second highest plastic polluter in the world after China. The country alone produces 3.2 million tons of unmanaged plastic per year. And it's also a major recipient of foreign plastic waste, which is approximately 263,000 tons last year. And if you wondered how it equates, what it equates to, it's 2,000 blue whales or 40,000 African elephants. So that's a lot, essentially. And 48,000 households in the country burn plastic waste, even though it's prohibited. That's compared to under 10%, 9% in higher resource settings. And plastic wastes are used as fuel in food industries, such as tofu factories, brick making factories, etc. So just to show you where we are working, so our study site is in Malang, East Java. You can see in the map down there. And we are working in 6 villages. 3 are semi-urban and 3 are rural. And there are local industries that like sugarcane, tobacco, tofu, and various others who are contributing to air pollution. And we have found that the air pollution from factories and as well as home plastic burning are linked to increased number of cardiovascular diseases and chronic obstructive pulmonary disease. I'll just call it COPD going forward. So to understand how to develop a solution, we need to understand the context first. So it's called situational analysis. And this is very important, and that's what we did in the beginning. So first year, we conducted mixed methods research, including quantitative and qualitative methods to gather insights from the context, what works, what doesn't, why some people are burning plastic waste, and how we can actually tackle this. So to put this in some domains, thematic domains, so geographically, there is lack of public transport in the area, which hinders the implementation of plastic waste management systems and deliveries within the area. And where epidemiologically, in those specific regions where there are more plastic burning events, we found more COPD cases. From the socio-cultural and socio-economic point of view, we found there is a high level of community trust, and also there are already some community initiatives like women's associations, so which could be facilitators that we can build on. But at the same time, there is not enough budget from the administrative point of view in the village, so that means we need to allocate more money in terms of developing infrastructure, and transportation, providing transportation. Also, a lot of the people who live there are living in poverty, and that means they are working in factories. So that means there is a link of unintended consequences that needs to be explored further. Legally, there is no punishment or reward for burning plastic, so which means no one could be held into account. And finally, there are no strict regulations, although in the beginning I said there is plastic waste burning is prohibited, but there is no way to actually implement that into practice. And often, although plastic import has been recently banned in Indonesia, in small ports like Malang, there are often illegally plastics being imported because people make money from this. So there is a bigger policy level issue there. So the only way we can create a solution together is by working with the community, taking both bottom-up and top-down approach. Like Margaret Whitley said, there is no power for change greater than a community discovering what it cares about. So that's what we did. This is broadly the co-creation framework we adapted for the multisectoral intervention development in 3 phases. So the planning includes the situational analysis to understand the context. Then we conducted stakeholder mapping to ensure equity and all the relevant stakeholders are involved in the decision-making process. And sampling and recruitment of a co-creator group who could be involved throughout the process of decision-making. And then we provided training and planning for both the facilitators and the co-creator group. Then the middle, the main co-creation phase, we structured the activities using design thinking and systems thinking approach. So we took the double diamond design framework, which is around 4 phases, well, mainly 3 phases of discover, define, and develop. So discover is initially you want to map as many type of solutions as you possibly can find, and then we want to define the specific example that could be suited to that setting, and then we develop the specific intervention components. However, this is not a very linear approach, and it's an iterative process which is continually getting feedback and refining in the process. And finally, as part of research, we want to make sure the process, we evaluate the process, and as one of my speakers was saying, transferring these findings into implementable strategy, actionable implementation strategy is very important, so that's what we did. And I don't expect you to read this, but just to say, this is how it more looked like in terms of the specific activities and how we designed the overall process, incorporating a range of tools and frameworks. I have included, so this is in our protocol paper, linked, so if you're interested, you can read more about it. So the first step now is about goal setting. So what are we going to develop and what are we going to achieve going forward? So we started with preliminary theory of change workshop. So at first, we decided together what our desired impact should look like. So that includes reduction in air pollution due to plastic burning and reduction in non-communicable diseases due to air pollution. And we invited community members, healthcare professionals, policy-level stakeholders, environmental volunteers to come together, and we try to work backwards. So starting from the higher-level impact to long-term outcome, we try to understand what is our short-term outcome and what are the different activities that can help achieve this. So we mapped these activities like the picture shows, and then we try to understand what the community needs are and in as many categories as possible. Then we synthesized these in kind of 3 broader criteria. So infrastructure or interventions for plastic management, change in policy and strategies, and interventions for behavioral change. However, we had more questions whether we can implement new technologies within the timeline and funded the budget of the project as well as the budget from the Ministry of Health and the Environment. And how can we strengthen existing practices rather than developing something from scratch? Are the policy changes that we're trying to achieve going to be time restricted? Can we implement those? So all of those, including the behavioral change component, which is very, very crucial here, we went back to the community members to understand how we can define this. So next up, we conducted a gap analysis and prioritization exercise where we described both the interventions that were developed locally, and we also found interventions and solutions from global examples. And then we led a discussion around what would be the potential strengths and weakness, and then we taught them how we can use impact effort metrics to prioritize this intervention. So it looked a bit like this. Essentially, impact effort metrics tries to compare how the level of impact an intervention could make and the level of effort it would take to implement that. And given we have limited time and budget, so we wanted to understand what are the priorities of the community. And finally, we had our 10 shortlisted intervention components, which we then used a planetary health framework to assess whether the interventions will deliver the expected outcomes. And we went back to the community level environmental experts. We also consulted with international environmental experts as well as policy level stakeholders to assess the intervention components through this planetary health domain. So this was recently published a few years ago by Bruzel and colleagues. Essentially, what it says is intervention is in the middle, what we are trying to achieve. And then surrounding this, it's not only health and the environment, but also there are different domains that we need to take into account, including power relation, equity, prosperity of the community, as well as power governance. So some of the key considerations include cultural alignment. Is this intervention incorporating local knowledge and tradition? Are we ensuring equity for all community members? So if we are developing this solution, is it going to be accessible from those from different socioeconomic levels? Prosperity. So intervention should be building on local resources and expertise rather than importing a solution that was built somewhere else or implemented somewhere else. And finally, to ensure health and environmental co-benefits. So what are the potential health and environmental impact, but also think of trade-offs. Because whenever a solution is implemented, there will always be some level of trade-off. For example, we cannot just stop plastic use or tell people that you cannot use it from next day just because it's bad for your health. Because some people there are selling these plastics for their livelihood. So which means you're actually cutting off their source of income. So you really need to think of circular economy to make sure you're giving them the most sustainable solution. So thinking about those trade-offs are important. And also thinking of any unintended consequences, which could be both positive and negative, but there are these underlying issues, mechanisms need to be considered well. So based on that, we came up with final 3 intervention components. There is a subset for the multisectoral component. So we have developed regulations at the village level, working with the university and village government. We ensure there is a shared understanding of how we can implement those different regulations at that smaller scale. Then we are supporting them to develop technological infrastructure. So there are neighborhood waste cell banks where They can store and sort plastic waste temporarily, and then that can be transported to village level waste bank, which is a bigger area, and making sure, working with the district government, that there is transportation provided. But also we are working with them to develop incentive mechanism. So if, let's say, someone in village A has given 10 kilo of plastic to the village waste bank, so they can get something in return. So trying to develop a mechanism that positively influences this behavior. And also developing communication channels for waste collection and selling. And then training and education for community members and environmental champions. So we have developed 6 training modules to be co-designed with the community to be delivered through different channels. And this is very important component because often we develop solutions and implement without actually telling people what does it mean for you and how do you actually use it. So this is, while this seems small, this is kind of very integral component to it. Well, there is something gone missing. However, I haven't mentioned about the health systems component, but just to say, we also are developing an early warning system where those who have higher risk of cardiovascular and COPD cases, they will receive personalized messages when there is a higher PM 2.5 exposure in the area. So we have actually placed air quality monitoring sensors in the villages, and we are personalizing those messages, working with them. Again, not only collecting data, not only measuring, but making sure these are meaningful. Again, please don't try to read this. This is just to show that the theory of change, we did the preliminary work in the beginning that ended up being something like this. So this is how we brought in all the different activities and the pathway to change, and making sure these are measurable, and we have set the right level of indicators to understand whether or not these are working in practice. So the initial sticky notes that we had, so this is kind of what we prepared after this. Yes, so next steps. So we have the village regulations that have been drafted, the technological infrastructure, they're currently in progress. We plan to complete implementation by January 2026, and we are currently preparing all the process for evaluation planning. It's in one sentence, but it's a huge amount of work because we are trying to understand the impact, the process, and also cost evaluation. Our learnings from this process, so multisectoral interventions are inherently complex, and stakeholder buy-in at all levels are integral to success. Trade-offs and unintended consequences are often unavoidable when considering both health and environmental co-benefits, and this need to be considered, carefully considered. And engaging local communities, integrating local knowledge and expertise is of utmost importance when ensuring prosperity and long-term sustainability. And finally, climate change-related issues often seem too big and solutions inconceivable. So the key is to start small and empower local communities to scale up. So to end with a Native American proverb, we don't inherit the earth from our ancestors. We borrow it from our children. And the communities in Malang are already recognizing this, and it shows in the activity that they're currently already taking. This is as part of their incentives. You can see they're showing school children to talk about the dangers of plastic burning and plastic waste. And Indonesians love to take pictures, so you can see. However, we need collaboration and support at a greater level. As we can see from the recent news from last month, the Global Plastic Summit ended without a solution after 10 days of discussion across 180 countries. And this is just to show that we need to work together and across different sectors. However, we hope that the research we are currently doing will help make such changes, even though at a very smaller scale, but take a step forward. And that's all I had. Thank you. Any questions?
Thank you for your presentation. I have a simple question, but the consequences might be strange. Isn't there any way in the country, I mean, where we could favorize the use of more biodegradable or more ecological content for food or drinks that could be used instead of plastic then?
Yes, definitely. So that's one of the areas that we are also looking at in terms of, so you want to reduce the use. So to reduce the use, you need to introduce alternatives. And you need to make sure the local businesses are supportive of it, right? So to do so, you need to make sure that by just introducing this, you're not only introducing to those who can afford, it's affordable. So all those things need to be taken into account. And while we are considering this, I think this will be the next step to introduce new businesses where you can perhaps build on local sources. For example, there is a company at Imperial who use seaweed to produce biodegradable cutlery. So Indonesia being surrounded by the sea, they can use similar technology, but we want to make sure that's accessible, that's it's not too costly for the businesses to run. So yes, coming to your point, definitely a consideration, but we need to think of the unintended consequences.
Thank you.
Are there any questions in the room? Any more? Any online? Yeah, in the interest of time as well. Thank you very much, Nusrat. So next up is Nima Yagmai. He's an epidemiologist from Amsterdam, the Kit Institute, and is focusing his research on operation and strengthening health information systems with a focus on fragile settings in South Sudan and Afghanistan. So he's expanding Kit's expertise in disaster epidemiology and preparedness. And yeah, today he's going to have a beautiful presentation to show us. Thank you very much. And big round of applause.
Testing. Thanks. And do I point it to the computer? Uh-oh. I need to open my presentation, of course. Excel is in French. Is it diaporama? Just there. Okay. You got it? Okay. Off to a good start. Thank you for the introduction. My presentation is going to be on the intersection of disasters, conflicts, and our health systems. So you already learned a little bit about me. We won't dwell on that. You can come and talk to me later if you're interested in Kit's work or my work, or you have any questions. So we're going to start with our collective understanding of disasters. It's a little intimidating teaching or explaining European history to a room of Europeans, but I'm going to give it a go. But our understanding of disasters goes back quite a long time. So Lisbon in the 18th century was the epitome of a strong and prosperous European city. It was a network or a location for trade networks, and it was the capital of one of the world's strongest empires. And on November 1st of 1755, it was another typical glorious day in Lisbon, quite sunny, and it was All Saints' Day, which is a Christian holiday. And the city was full of people, candles were lit for the events, and something occurred that morning that changed the course of our understanding of disasters and much of European history. Sometime around 8 or 9 a.m., one of the largest earthquakes in European history struck off the coast. And the majority of buildings in the city were damaged, many collapsed, and civilians fled away from the buildings and the smoke and the debris to the coast, where they met one of the largest tsunamis in European history, which killed a lot of people, of course, and knocked over buildings, which knocked over the candles from the celebrations, setting most of the city on fire. By the end of the day, about 80 or 90% of the city's buildings had collapsed, and about 25% of the population of the city was dead. The French and Spanish leaders, kings, at the time were so shocked by the events that they actually contributed humanitarian aid to a typical rival, and the event triggered some philosophical conversations. These paintings kind of depict this unimaginable tragedy, but it caused us to think a bit more deeply about natural disasters, whether they are in fact, let's say, made by God or there's some sort of causal links to them. And this event also kicked off the science of seismology, the study of earthquakes. Now, this is your kind of typical disaster that we learn about or think about in our culture. And you can think back to ones that might have happened in our generation, such as 9/11 or the earthquake and tsunami in Japan, which is you have a perfect day, a perfect setting, and something horrendous happens. We also see it in our depictions of movies. You have Brad Pitt making breakfast for his beautiful family in this idyllic kitchen, and something happens, and Brad Pitt now has to save the world. I think this is from World War Z. But we also see it in our frameworks when we approach health systems in disasters. You have this health systems performance on the left over here, which is nice and stable. Something goes wrong, but obviously the amount that it goes wrong is not as good as the amount that we build our resilience later, and everything is positive in the end. This is not how things typically unfold, not acute disasters and not chronic disasters. They unfold more like what I'm about to present, a more typical example that I think of in history, which is the floods in China in the 1930s. So starting a few years prior to 1931, the Chinese Civil War had started, and there was a set of droughts all the way up until 1931. By the summer of 1931, much of the Yangtze River Valley was in a drought state, and much of the country was in conflict. 9 typhoons blew into the valleys of China that summer, and eventually many of the dams broke and the riverbanks flooded, and approximately 100 to 200,000 people were killed that summer in the flooding. In terms of indirect effects, approximately 1 to 2 million people were killed from infectious diseases, starvation, etc. In response, the Chinese government had some challenges. It was embroiled in a civil war, of course, and a few months after, their worst nightmare came true because the Japanese invaded Manchuria, collapsing the Chinese economy, Chinese bonds, etc. They weren't really able to recover much from this event. 3 or 4 years later, there was a similar flood event. And about 6 years later, the second big flood happened in 1938, which is partly man-made, partly not. So storms were obviously involved, but the Chinese National Army broke the banks of many of their dams to prevent the Japanese invasion, killing another 400 to 500,000 civilians in a couple weeks. This combination of events, kind of collectively call these things kind of shitstorms or really, really bad issues, is quite classic actually in the way disasters unfold. So I question the framework that I often use myself, because usually you end up kind of lower than you started, or over here it's kind of fluctuating oddly. And these you should probably look at it at 20 or 30 of these charts piled on top of each other. So where are we today in relation kind of historically? One of the best examples, I think, is the 2021 earthquake in Haiti. We had a couple thousand civilian deaths, over 130,000 buildings destroyed. This is in a country of only 12 million, so that's a lot of buildings. And the effects of the earthquake damaged approximately the economic equivalent of 10% of the national GDP, which I think in France would be something of a 300 or 400 billion euro disaster. But it didn't happen in isolation. For 4 years prior to the earthquake, the entire political system was in turmoil, and none of the public administration was functioning. And a few weeks prior to the earthquake, the president was assassinated. So response capacities were really low. In the response to the earthquake, gangs controlled much of the national infrastructure, which was blocking aid, and there was rampant kidnapping of doctors and looting of humanitarian supplies by these militant groups. You go forward a couple weeks, there was Tropical Storm Grace landed on Haiti in the middle of the attempt of recovering from the earthquake. A few months later, there was a cholera outbreak, which is quite typical in these events. And within 2 years, the IPC declared parts of Haiti in famine. This isn't an isolated one. This is one of the deadliest earthquake disasters in the last 5 years. Here are the other three. 2022, Afghanistan, geopolitical challenges to say the least. 2023, Syria earthquake killed over 6,000 Syrians, and the damage occurred on both sides of the front lines, so both in rebel-held areas and government-controlled areas. It also happened at the same time as a blizzard and a cholera outbreak. And this year, the 2025 Myanmar earthquake, where a ceasefire wasn't declared even after the earthquake. So even 1 or 2 hours after one of the largest earthquakes in national history struck, fighter jets were in the air bombing rebel areas and civilian targets. So those are the 4 deadliest earthquakes in the last 5 years. All of them seem to coincide with conflict. I don't know if anybody checked the news. There was an earthquake in Afghanistan 2 days ago that's killed about 1,000 people. And last night there was the largest landslide of the year happened in Darfur in Sudan. So it really is issues piling on top of each other. Let me introduce you to a term, fragile and conflict-affected states. Sometimes it's called fragile and conflict-affected settings. It can be controversial, but what isn't in global health? These are low GNI countries, so countries with a gross national income below 10,000 US dollars per year. Take a look at the map. And these are fragile and conflict-affected states according to the way we define it in my research group, but I don't know if we've updated this for 1 or 2 years, so don't point out like one that you think should be there. But as you can see, there's a good crossover between these two maps, but there are a number of countries that are low GNI countries that are not fragile. We call these FCAS, fragile and conflict-affected states, and the ones that aren't in that map, we call them non-FCAS. And there is a big distinction between FCAS and non-FCAS countries. Let's take a look. From health supply perspective, non-FCAS low GNI countries have substantially more physicians per 1,000 population. They have substantially more nurses and midwives, and their vaccination rates are substantially higher. So I know 70% and 85% seem quite similar, but the other direction to think about it is FCAS countries have double the number of unvaccinated children as a proportion of their population. You see these things in health outcomes. Life expectancy in FCAS countries are 6 years lower than non-FCAS low GNI countries. Infant mortality is double in fragile states compared to non-fragile states, and maternal mortality is nearly triple. And maternal mortality is a really good indicator for the functioning of a health system because you need a lot of things to happen right to prevent maternal mortality. So we've seen the relationship between conflict-affected states and health. Clearly there's an issue. Let's bring disasters into it. So we take 6,000 plus disaster events that have happened in low GNI countries in the last 20 years. A reminder of low GNI and FCAS. FCAS, people living in fragile countries make up about 21% of the population of people who overall live in low GNI countries. But fragile states or FCAS states make up 28% of disaster events. So there's a little bit of an overrepresentation. You can see the types of events that we consider disaster events. So again, although they make up 21% of the population, they do make up 47% of the disaster deaths. So they're extremely overrepresented in disaster deaths. This is not in comparison to high-income countries. It's in comparison to low gross national income countries. And they are overrepresented across the board, particularly in meteorological and climatological disasters. So as we saw, the links between coming from or living in a fragile and conflict-affected state and the health outcomes, we can also see the links between fragile and conflict-affected states and the disaster outcomes. So when we bring climate change into the perspective, now I'm not a climate scientist, but I've got two basic diagrams for you, and it's probably not a surprise to any of you. Climate vulnerability has a huge crossover with these regions as well. This is from the UK Met Office, and 9 out of 10 countries that the IPCC considers the most vulnerable 10 countries in the world to climate change, 9 of 10 of them are fragile and conflict-affected states. The only one that isn't is Bangladesh. So is this a conflict problem, a climate disaster issue, or a health issue? Obviously, it's all of them combined, but that's a bit of a complicated way to look at it from the work that we do. So you guys saw this already. I had to sneak this in there. This is the way it's usually looked at from a climate perspective, this framework. It doesn't allow us to dive too deep into the health side. This is a typical framework that is used for conflicts, which is, you know, what do you call it? The causes and then the effects that come from the conflict. But I like to use a pretty simple one. My D is moved. Oh no, now it looks terrible. It looked nicer before. I like to use this simple framework: need, demand, and supply for healthcare. Really easy, and it's actually quite useful to think about when it comes to disaster events. So here's an easy way to look at it. And these are supposed to go one by one, but okay. This is a publication from one of my colleagues in my previous work. We can look at the Typhoon Haiyan in the Philippines, and we see, if we look at it from a needs perspective, you have approximately 7,000 deaths. There was no immediate capacity for proper needs assessments done, but the assumption is that the health needs of children and women are higher. That's what we know from historical data. So when they look at the demand perspective, which is the demand as in people coming for health services, what do they see? They see a significant drop in patient admissions overall, which you wouldn't expect. They see the ratio of male admissions increase significantly, and they see that there's a decrease in the admission of pregnancy-related conditions. So just by looking at it from this perspective of needs and demand, you can start to see that there's probably not a needs issue, but there seems to be some sort of accessibility or affordability challenge that's occurring because there are people missing out on healthcare. And of course, when we look at the supply side, we can see your classic issues: hospitals struggling, staff struggling to reach hospitals as well. So when you're thinking of an intervention using this framework, you can start to see which part of the health system you need to target. So we've started doing a bit more research on the links between climate change or climate-related disasters and conflict. We have multiple decades of experience on conflict in health, but this is a new area for us, and we do a lot of operational research. We're not a university. In Afghanistan, we've been doing monitoring evaluation since 2017, and we work with a number of partners. This is a vehicle for data collection going through a river. It's a challenging environment. And we start to notice that there was a lot of disaster events that are occurring on top of the conflict challenge that we faced when it came to health service delivery, monitoring, evaluation. So we looked into the data, and we found in the last 20 years there's been 147 disaster events, 11,000 plus deaths, and 33 million people affected. So it's obviously a big issue. When you want to know about disasters in Afghanistan, the comment is location, location, location. It's a very strange country when it comes to geographic layout. You don't see this often. There's a massive mountain range right in the middle of the country, and the population lives on these peripheries around the mountain range. So right along the borders, but a generally hollow middle. And the disasters unfold according to this. So floods are concentrated in the valleyways coming down the mountainsides. Avalanches are obviously in the mountains. Droughts are in the river valleys that are at the bottom of this mountain range. Landslides are in the mountains. And earthquakes are in two fault lines, one in the north and one in the south. So with this understanding of where disasters unfold, we were able to approach need, demand, and supply and see what we could do in terms of understanding how to support the health system. So we know a few things. We know that direct impacts to health facilities affect the supply of services. Okay. We know indirect impacts to health facilities affect both demand and supply of services. I've lost control. We know that each facility faces a unique set of disaster impacts. This is great. Okay. And we know that each facility and community has a unique capacity to respond. So these are the base information that we're working on. These are supposed to go with the other ones. Okay. So we had a set of critical questions that we were supposed to answer. So we wanted to know, what are the risks to the facility? What are the risks to the population? How prepared are facilities to risks? And how can facilities and communities prepare for their risks? So these are the key questions. Down there, that's my institute. And we started by mapping facilities according to understanding the natural hazard impacts. We mapped local communities for this. We produced an assessment tool which you can use to understand a facility's preparedness status. So a simple checklist, you know, do you have your X-ray machines in the basement in case there's flooding, that type of thing. And we plan to, we haven't gotten to this stage yet, conducting workshops to have a bit of a bottom-up approach. Let's show you some of the maps that we produced. So here, for example, this is the map of Afghanistan. The brown lines are the urban road networks. And over here, you can see an urban environment with the brown lines. Again, those are roads. 2 red dots are the health facilities. And the blue coloring is the potential flood areas. So you can see that the health facilities are not going to be impacted by floods. But as you can see, there seems to be parts of the communities that will be affected, especially whoever is living on that side of the blue area will be likely disconnected from their health facilities. And when we produce the specific maps for each key facility, you get something like this that you can share as a form of assessment to partners. So Kunduz Hospital, for example, itself is sitting in an area that's not going to be impacted by floods, but that highway that leads into the city is. So when you think about it from a supply perspective, there could be supply chain issues. If you think about it from a demand perspective, of course, anybody coming from over there might not be able to reach. In South Sudan, we've been working on health system surveillance since 2018. South Sudan also has its fair share of challenges: civil war, sporadic violence, seasonal flooding, and has some of the world's worst indicators when it comes to maternal and childhood mortality rates. We don't have access to need and supply data, but we do have access to demand because we're doing surveillance. Based on this demand data, by collecting and analyzing the demand-specific health data, we're able to identify a few things. We're able to identify which health interventions are more or less successful. We can understand the relationship between these health interventions and childhood infections. We're able to find malaria seasonality, depending on climate zones. And during COVID, we were trying to understand a bit more the impacts of COVID-19 in terms of both respiratory illness and health behavior. So what is the role of One Health in all of this? Now I'm a bit terrified after Dr. Jacob's presentation on the definitions of all these things. So forgive me if this isn't One Health and maybe is something else. But there is a role for One Health in all of this. this map you're now very familiar with because I showed it, the fragile and conflict affected states. When we look at countries by majority of the population being urban or rural, you can see a clear overlap as well. FCAS countries are typically majority rural countries. And when we look at the share of employment in agriculture, we see the same pattern. So if you're working in fragile and conflict affected settings on healthcare, you can't ignore that most of the healthcare needs and impacts are happening in rural areas where there's a lot of association between agriculture, any form of domestic animals, a proximity to natural environments such as forests, and the population itself. So it'd be very ignorant to ignore these issues. As well, this is the last time you have to see this framework, the need, demand, and supply issue works for people, but it also can work for agriculture. So for veterinarian medicine, for example. So it's the same concept. Maybe cattle need vaccination. Is there a demand, as in do the farmers know about it? And is there a supply? Do those services actually exist? And linking these two can make immense progress. When a disaster strikes a rural area that's very dependent, is a pastoralist community, for example, and you want to set up health clinics and you're ignorant of their needs when it comes to agriculture or pastoral lifestyles, then you're going to fail your health intervention. So it's better to link the two. We'll start with, these were also supposed to come one by one, but we'll start with the tasks for epidemiologists on my side. We need to incorporate veterinary and agricultural data more so. At the moment, very little of this is done when it comes to health systems work. And we're forgetting our roots a bit. So epidemiologists obsess over census data or surveys or any form of data that measures demographics. But the first time in human history, any form of information was collected that was similar to a census wasn't on people. It was actually in the early kingdom of ancient Egypt 5,000 years ago, and it was counting cattle. So the first example that we actually have of the stuff that we obsess with as epidemiologists is actually from the side of agriculture and domestic animals, not for humans. So we need to, remember our roots a little bit. We need to improve our surveillance systems of vectors for infectious disease as well. There's been a couple presentations that have demonstrated good use of this. And we need to improve our understanding of AMR in fragile states. And this is something that we should be screaming from the rooftops. Antimicrobial resistance is on steroids when it comes to fragile and conflict-affected settings, because you have a high burden of infectious disease, a high burden of trauma and wounds, and you have a supply chain of antibiotics that is on and off. So whether it's tuberculosis treatment or any kind of other treatment that involves antibiotics, you have patients going on and off these regimens, which is further fueling antimicrobial resistance. For our One Health experts, I would say, don't forget fragile and conflict-affected settings. Try to do your research where those impacts are. I know it's a lot of challenge, to actually be able to do that, but it's an injustice to forget those places. Take-home messages would be, of course, climate change impacts and climate-related disasters don't happen in isolation. They happen in these complex environments. Conflict states are more vulnerable and more disproportionately affected. Epidemiologists like myself need to include different forms of data that we don't do a good job of at the moment. And researchers in One Health should try to prioritize research in fragile and conflict-affected settings. If you have any questions, let me know. That QR code goes to my LinkedIn. Thank you.
Thank you, Nima.
I keep this.
Yeah.
Okay.
Does anyone have any questions? Yeah.
Hi, thanks for the talk. You mentioned about through analyzing the data, you've understood like what interventions work well or don't work well in those settings. Could you share some examples?
Sure. So best example I could give is we received a phone call in 2022 from partners that we had in South Sudan that there had been a rollout of a community health worker program. These were, let's say, minimally trained health workers going into communities, and they're from the communities themselves. And the call was that doctors in the tertiary hospitals, these important hospitals, are saying they're receiving less patients because of these community health workers. So the call was to cancel the community health worker program. based on this kind of anecdotal feedback from a couple doctors. So we went and we used our surveillance data and did a study to look into it a bit more. And we were able to identify that there actually was a positive association with the community healthcare workers, specifically for malaria. So the community healthcare workers were being taught to try to treat or help diarrhea cases in children, but they were told to refer malaria cases. And so being able to identify that the communities and the regions that had more community healthcare workers or better equipped community healthcare workers were reporting more referrals of malaria to tertiary hospitals in the same moment that their community healthcare workers were picking it up, we were able to show that that's actually, you know, a successful or it's working well. In the counter, there were regions where the community healthcare worker program wasn't being successful because they weren't picking up cases of infections when they should be according to the seasonality. So things like this.
Yeah. Hello. I have a question about a diapositive earlier in your presentation where you show the 10 states who were the most vulnerable for climate change.
Yep.
And I wanted to know, how did you deem them the most vulnerable? Upon what data? And if so, how did you collect that data?
Yeah, that one you're going to have to ask the IPCC. Okay. So the inter something panel of climate change. The figure comes from them. I'm sure it's a combination of climate effects and the vulnerabilities of society, but yeah.
Thank you.
Sorry, I can't answer that.
Are there any questions online as well?
Anybody planning to do their thesis in a conflict-affected setting after this talk? No. Okay.
Thank you very much, Nima. Okay, so the third presentation before the break is from Alba McGeer, and she'll be tuning in from Panama City. She was an alumni of the Idoh cohort a couple of years ago, and now she's working at the Clinton Health Access Initiative and is supporting ministries of health in Panama, Honduras, Guatemala, Haiti, and the Dominican Republic. And her work involves improving community healthcare health worker networks, supporting commodity forecasting, and designing community-driven initiatives to accelerate disease elimination. But today she'll be talking about the work that she did with the LSHTM in London on the health impacts of extreme indoor heat among vulnerable communities in Bangladesh. Yeah, I had the privilege of being there for her master's thesis 2 years ago, so looking forward to what she has to say today. Thank you. Are you with us, Alba?
I am with you.
Great.
Lovely to be here. Can you all see me?
Yes. Yes, we can.
Brilliant. Well, I'll be sharing my screen. Let me know if you can see it. All right.
We can.
Brilliant. Thank you. Well, thank you for the introduction, and it's a real honor to be here today, especially as you were saying, as someone who graduated from this master's not too long ago. It's really amazing to be back here, and I'd like to start by congratulating everybody that is graduating today and the new cohort that's starting this adventure. Today I'll be presenting, as we were saying, some work that we previously did. So I'm now working for the Clinton Health Access Initiative in Central America and Hispaniola, but I'll be showing a little bit of the work we did in Bangladesh. And the question that we'll be talking about in this presentation is the question at everybody's lips: is overcoming climate change impacts possible? And to do this, I'll be presenting a case study on high indoor temperatures, where we'll be going through a few different steps. So first of all, how we worked through the hypothesis, how we saw if the magnitude of the problem was as big as we thought, and then some of the solutions we were able to find. But before we talk about that, I really wanted to highlight here why it's important to talk about One Health when we look at climate change impacts. And we've had a few presentations today that have been talking about this. But really what I want to highlight here is how climate change health impacts never affect only one of the bubbles. I'm going to put my laser here so we can talk about it. So it never affects one of these bubbles, right? We're always talking about it affecting either human and animal health or animal and environmental health. And I put some examples here. So for instance, how we have now malaria in the US. We've had some cases of malaria in the US because of vector changes, but also increased globalization. Then the impacts of human behavior. So with increased global warming, children are known to go to school earlier, as the tarmac on the wall, on the floor can be burning their feet sometimes, and that makes them more prone to have contacts with snakes, increasing the number of snake bites that we see in certain contexts. Also in terms of biodiversity loss. So we know that as biodiversity is lost, there is more contact potentially between animals and humans, leading potential outbreaks like we saw for the Ebola. And lastly, with the conflict-affected states that we were talking about before, and flooding, sometimes when we have increased floods, we can see there's more diarrheal diseases, and this is the environment being deteriorated, leading to increased health burden. But so in this context, really what I wanted to focus today is on, is there anything we can do about it? And here I'd like to present the framework of climate and health resilience. So climate and health resilience is a way of looking at the effects of climate change and trying to understand whether there's anything we can do upstream or downstream to reduce its impacts. So when we talk about mitigation, we really are talking about tackling the causes. So everything to do with reducing emissions, making the actual magnitude of the problem smaller. So we're reducing emissions, we're shifting to renewable energy, sustainable transport, healthy diets, basically reducing the emissions and making global warming hopefully less bad. And then the other part is adaptation. So once we have the problem in our hands, is there anything we can do about it? And here we're talking about things like heat action plans, putting cooling systems in cities, and climate health resilience, where we prepare the health system to have the right doctors, the right nurses trained with potential challenges that could come from health diseases. Or vector control and surveillance, having a good idea of the vectors that are there so that when we have an outbreak, we know how to tackle it. Or urban planning for resilience. So we could think of mitigation as tackling the root of the cause and adaptation tackling more the causes. And so here, moving to the case study we're talking about today, really we were interested in high temperatures and how high temperatures affect health outcomes. So we looked at literature and we saw that this is indeed a reasonably well-known fact. High ambient temperatures affect health outcomes, and both in high-income countries, middle-income countries, and lower and middle-income countries, where we have things like heat stress and heat-related illness, increased respiratory hospitalizations, but also changes in how vector-borne diseases are managed and others. But the question we wanted to answer here was related but a little bit different. We were interested in understanding indoor temperatures. And this is because outdoor and indoor temperatures are related, and especially so in places without heat mitigation. So you can think of heat mitigation as your AC that I've got on right now here in Panama, or a fan, or even windows, ways of modulating indoor temperature for it to be lower than outdoor temperature. And this is important because in many contexts, the majority of people's time is spent indoors. So here we really wanted to know, do high indoor temperatures affect health outcomes the way we know that high indoor temperatures ambiently affect health outcomes? And so we did this in Bangladesh, so the only fragile conflict state that is one of the top 10 countries affected by climate change. Bangladesh has a very high population and very high density of people. So we have almost 170 million people living in a country that is a quarter of Spain's size. So almost 4 times more people than in Spain in a quarter of the size. So you can imagine how densely populated it is. It's a lower and middle income country with a poverty rate of about 20%, and most of the people follow Islam. Fertility rate and vaccination rates are some of the health outcomes that have improved massively in the last few years. So changing from 3.5 births per woman in the 70s to almost 2 currently. And the majority of children, one could say almost 90%, are vaccinated and receive all recommended vaccines. These are really good health outcomes. But there's something that is potentially challenging this, and that is climate change. So as was presented previously, Bangladesh has been consistently in the top 10 countries most affected by climate change or at risk of so for basically all of this millennia. And this is for a few different reasons. Firstly, the country, a lot of it is at sea level, which means that a rise of level of sea could mean a lot of the country would be submerged. And this leads a lot of people to be climate displaced, a lot of which would move to high urban metropolitan areas like Dhaka or other cities. Currently, 36% of people live there. By 2050, it's estimated this could rise to 60%. And you can imagine this would lead to crowding and slums that are already very crowded being more so, and possibly a lot of other health outcomes. I put this graph here to highlight how this is potentially going to go in the future. So it's been around 30 degrees since we have health records, temperature records, sorry, and then we really can see how depending on the different climate forecasts, we will see different rise of temperature. So Bangladesh can be said to be a country that it will be highly affected by the rise of temperatures. And so what did we do in this case study? Well, we did a longitudinal study in a few different places, but I'll be presenting today the work we did in Chakuria. Chakuria is here, and it looks something like this. It's an urban area very close to the sea. And what we wanted to look at is how temperatures indoors and outdoors are related, but also how these affect health. So we could install data loggers indoors and outdoors, and we also gave monthly questionnaires to have an idea of how people's relation with health changed and how their behaviors changed with heat as well. And so to dive into this a little bit more, we put these funny devices, which are health loggers or data loggers, and with these measure temperature and humidity every hour. So every hour we could have an idea of indoors and outdoors what the temperature and the humidity looked like. And with this we could calculate something called heat index. And heat index is a much better approximation of how heat feels in the human body than just looking at temperature or humidity individually. And then we went to Chakuria. And here's a map of Chakuria, which we divided in different zones. And we went to 49 different villages and installed these data loggers, both indoors and outdoors, to have an idea of how the temperature was changing. We also wanted variation in the types of households that we chose and the types of settings. So we chose houses, restricted them here to bamboo and cement. And if we move to results here, we saw that the magnitude of the problem was indeed quite big. So in terms of perception of the people, we saw that almost everybody that was interviewed reported being uncomfortable in the heat at some point. And in terms of the temperatures indoors, we saw that more than half were above danger threshold. These are thresholds that vary depending on settings, but the danger threshold for this area was around the one you can see here. So you can see in orange. And this means that either the temperature was very high and humidity was low, or humidity was very high and the temperature was a bit lower. So 50% of the days were above danger threshold indoors, and 7.5 days were above extreme threshold, which meant that really the magnitude of the problem was quite high. And then we went, okay, well, we know we have high temperatures indoors. Does this affect health like it affects outdoors? And we saw that indeed, hotter houses reported more illness. So hotter houses reported significantly more cases of diarrhea, local site infection, and sore throat, amongst others. But these were the most significant ones. And so when we moved at this framework and looking at what interventions we could do, we really analyzed it the following way. So we've confirmed we have high indoor temperatures. Okay, this is a problem. And then we think that this could be linked with more cases of illness. But what could we do? We didn't want to just stop there. We really wanted to see whether there's anything we could do to reduce this problem. Well, the obvious one would be, okay, let's prevent global temperature rise. Let's force every country to stop emitting CO2 or whatever is necessary and make sure temperatures don't rise anymore. This is obviously not necessarily super possible for a small research group. And so we looked at some other things. We could improve housing. improved housing could potentially lead to the indoor temperature being less than the outdoor temperature, or at least a little bit lower. Or we could also provide coping behaviors, give behaviors to the people that are being affected by these high indoor temperatures, suggest things that they could do, and hopefully cut the transmission between high indoor temperatures and more illness. So really here looking at improved housing as a mitigation option for reducing the magnitude of the problem, and coping behaviors as an adaptation mechanism to reduce the context and the response of the problem to illness. So let's talk quickly about what we did in these two. Part one, mitigation. So really what we wanted to look at here was, does housing affect indoor temperatures? And is there any characteristic in a house that we could suggest or look at that would lead to this problem being less big? So we looked at wall material, we looked at shading, and we looked at some other factors like having a full ceiling, which is something that you see here, distance to the sea, and some others. And the key ones that we found had an impact were shading and wall material. So really what we were able to see was that the heat index, or the perception of heat in the human body, was less in those houses that were surrounded by shade, or at least had some shade. We also saw that this led to less reports of illness. So houses that had some shade or a lot of shade reported less illness than those that were not shaded. And this potentially could be linked to temperatures, as those that had some shade or a lot of shade showed less temperature indoors than those that had no shade. We saw something similar for wall material. So those houses made of bamboo compared to cement had higher indoor temperatures. And those that were made of cement also led to less reporting of illness, which means that potentially cement houses could be protective for not only reducing indoor temperatures, but also feelings of illness. Then we looked at the second options, adaptation. So we knew that this was an option, and then we looked at some other ideas. So adaptation. Adaptation really is about providing to the people who are affected different behaviors or different factors that one could do to reduce the magnitude of the problem, reduce the consequences in this case. So here we looked at a few different things, and I'll highlight just two. The first one we looked at was the storage of food. A lot of the cases that we saw of increased illness were things like diarrhea. And we know that storing food outside can lead to a higher propagation of microbes, leading to more potentially feelings of diarrhea. And so what we found is that a lot of people, despite having fridges available in about 30% of the households, the majority of these didn't use them. Only 20% of people who had a fridge used it to store food. A lot of them used the food outside, just covered. And in terms of behaviors, we saw that the majority of people, and here we looked specifically at women, the majority of women actually did know the behaviors that one should use. So they knew that showering could reduce temperatures or the feelings of temperature. They knew that turning the fan on or drinking more water would help, but they weren't always doing them. And let's talk about why that was. So in summary, can we say that there is a possibility to overcome climate change effects? My answer would be the yes and no. Obviously, mitigation and adaptation are things that we're doing from a health perspective to help reduce the impact of health due to climate change. However, climate change won't be overcome by doing mitigation and adaptation on health consequences, and reducing emissions is absolutely crucial. However, if we're looking at how we can mitigate and adapt our behaviors so that the health consequences are less big, there are some things we showed we could do. So focusing first on mitigation. So we looked at specifically improving houses. Obviously, there's a lot of other ways we could look at mitigating this effect. We focused on this one. Here we looked at wall materials. So we saw that bamboo indeed wasn't great for temperatures. It caused higher indoor temperatures, and it's also very vulnerable to sea level rise, meaning a lot of people have to rebuild their houses reasonably often. Then we also looked at shading. And shading did play a role in reducing indoor temperatures, likely linked to roof material. Roof material was consistently tin in all these houses, which meant that a lot of people could have had increased temperatures due to this tin roof. And we saw in another part of the study that indeed this did play a big effect. And some other mitigation factors have been done, like painting roofs white. And the second thing we looked at was adaptation, and specifically looking at protective behaviors. So we wanted to know whether people knew these behaviors, practiced these behaviors, and if there were any factors that meant they couldn't do these behaviors. In terms of knowledge, most people knew the behaviors that they should do. In terms of practice, these varied. Some people were very happy to do the behaviors that they were looking at, and some really didn't. And a lot of times, the reason that there was this discordance between the knowledge and the practice was environmental factors. For instance, while people knew drinking more water was beneficial and would probably lead to less feelings of illness and heat, they didn't necessarily do so, as they felt that the water they were drinking was unsafe. So sometimes, while knowledge and practice are not discordant, it's often due to environmental factors. And this is why we really have to be maximizing intrinsic knowledge. Certain factors that were protective were not acceptable by the communities in the study. For instance, one recommended factor is adaptive behavior, is removing clothing or wearing lighter clothing. But like I presented, most of the communities we're working with were Islamic, and that was not an acceptable behavior for these people. In terms of housing adaptations, while many housing adaptations are recommended in literature, when we suggested these or explored these possibilities, they were not feasible. For instance, adding windows is something that is recommended to increase airflow and decrease indoor temperatures, but people responded that they felt unsafe by having windows open, or they didn't like them because of noise and pollution. So this really highlights that the context of where you're doing the research really matters, and not all solutions are transferable. So while a solution could have been applied and worked well in certain contexts, we really need to be applying these at a local level. And research needs to be localized like this. We need to be informing our hypothesis directly by the affected communities. And this is where we're moving from a top-down to a bottom-up approach. A top-down approach where we look at hypotheses elsewhere and we test them in affected communities. And moving more towards a bottom-up approach where we co-create or we listen to suggestions of people that they already have, solutions that they're already working with, and then we can test those. And this is increasingly important. So going back to the graph that we showed of Bangladesh, these are the different heat temperature changes that we could see depending on emissions in the coming years. And this year has been key for global health for a bunch of different reasons, but I'll highlight just two. The first is withdrawal from the Paris Agreement. The US government has withdrawn from the Paris Agreement, meaning the second biggest contributor to world emissions has now no longer committed to reducing them. This means that we are at risk more than ever out of this increase of temperatures. And we also have had US EID cuts, either directly or indirectly, we've all heard about them. And highlighting just the climate change grants, we can see here how 98% of them have been terminated, which means that a lot of grants working on mitigation or adaptation of the consequences of climate change are now no longer going through. And these were things like technical assistance to address habitat loss and fragmentation that could prevent the next outbreak, but also direct effects due to mudslide prevention in Rohingya camps of Bangladesh, which is already shown in this year to increase number of deaths. In this context, it is more important than ever that we stay as connected as possible and we work not in silos, but really take the One Health approach of working together, really cooperating and sharing research and really making sure that we learn from each other, not by taking one thing and implementing it everywhere, but taking learned lessons that we've learned in one place and testing it elsewhere. One Health really helps us focus on prevention and building resilience. And these are key topics to think about right now, as climate challenges are here to stay, but there are things we can do about them. One quote that I love and I really think about quite often, someone told me, is climate change is like taking your phone and looking at a video, and that video becomes closer and closer of a disaster, so a flood, and it's closer and closer until you're the one recording it. And in that context, really staying connected and working together is what One Health teaches us and what we really should be applying. And with that, I'd like to thank everybody that contributed to this research, and I'd love to answer any questions if there are any. Thank you.
Thank you very much, Alba. What an interesting presentation, and quite alarming, that last statistic that you shared about the funding cuts. Is there anyone in the room that has a question for Alba? Online? Okay, in the interest of time, it seems that maybe we'll have to go, but we'll collect any questions that may be coming in from in person. Thank you.
Amazing. Thank you. Thank you for having me. And congratulations again.
Yeah. So we now have a coffee break, a well-earned one, and please be back by 5 past, because we're running late, and that way we can end the ceremony. Hello, everyone. I hope you had a little bit of fresh air for that coffee break. And this is the last section of the day. We are being joined by Max Claron, based in Paris now, with a Bangladeshi NGO called Friendship. And he's going to be talking about his work there, where he coordinates community-led initiatives focused on climate adaptation, health resilience, access to health and humanitarian settings, nature-based solutions, and poverty alleviation in Bangladesh. He has a strong foundation in systems thinking, project management, and strategic partnership building, and I'm really excited to hear what you have to say about the multisectoral development model, and a deep dive into what you're doing. Thank you, Max. Please come on stage and give a round of applause.
Thanks, Jade. I think slides are already on. Perfect, thank you. Yes, I'm going to be talking to you about Friendship NGO, which is a Bangladeshi organization that has developed a holistic multisectoral model in Bangladesh, which is a heavily climate-affected country, as we heard of in the previous talk. And we're going to start off with a little introductory video just to paint the picture, set the setting so that you can kind of visualize where we are.
আর নদীটা ওই যে চরে ছিল ওই যে চরটা আছে না তার পূর্ব পাশে ছিল নদীটা বন্যা আসলে আমাদের খুব কষ্ট হয়
Chores are so vulnerable. Climate impacts them daily. It impacts their lives, it impacts their livelihood, it impacts their social behavior, and unfortunately, of course, their economic and political behavior. And for them, you need to provide everything, whole ecosystem.
When I started Friendship 20 years ago, we started with 4 promises of saving lives,
climate adaptation, poverty alleviation, and empowerment.
And these are the 4 pillars on which Friendship today stands.
There we go. So you just saw a glimpse of Runa Khan, who's the founder of Friendship, and she founded the organization in 2002. So we're in Bangladesh. As Alba gave you a few figures, here is the comparison with France. A huge population density, which puts enormous stress on land and resources. That's something to keep in mind. And then on the left here of the screen, we have the adverse impacts from human-caused climate change as described by the IPCC. And I've just noted with Friendship's logos the areas of intervention across the different sectors where we intervene. Just to situate Bangladesh, under the Himalayas, where more and more glaciers are melting, so more and more water is coming down. All of the major rivers from the Himalayas end up in the Bengal Delta, which is the coastline of Bangladesh. And you can kind of see, if I can get, here you have the Brahmaputra River, and here the Ganges that meet and end up in this huge delta in this area here. And Friendship started doing interventions in the Char region. So this is a Char. This is a silt island in the middle of the Brahmaputra that is 40 kilometers wide during flood season, so slightly bigger than La Loire, which is 5 minutes away. And in the middle of the Brahmaputra, you have these islands where you have between 5 million to 20 million, depending on your data source, people living in these areas. This is to mainly show you our intervention areas. So as I said, we started in the north and slowly expanded to the south, doing coastal adaptation interventions. And we also have major operations in Ukiah, which is the main area for the Rohingya crisis refugee camps, which is a different type of intervention that we do that I'll speak a little bit less about, but if you have any questions, I'm happy to take them afterwards. Our vision and mission, key here is from Bangladesh, and that's part of the model that I want to tell you about. Not only the types of interventions, but how the way the organization was set up has led to us having this impact, being community-led and international. And the key to this is really friendship's wheel. So it can sound a bit cheesy, but I promise this is all true. We go by these 5 values, and they're the core of each one of our programs. From the values, you can move out to different approaches, so values-driven, needs-based, participative, integrated development model, and entrepreneurial mindset that then lead into 6 sectors, so climate action, education, health, inclusive citizenship, sustainable economic development, and cultural preservation, that each lead into 4 promises that Runa presented in the video. And so, as I mentioned, it started in 2002, and I'm not going to go into each year, but it's to show you how organically the organization was developed. It was, the idea of Runa was you have to start in an area where there is absolutely no health services, or there were no health services. So if you can save lives, people can then think about developing their own livelihoods, going to school, in an area where there is no education services either. And so that's how the organization started. LFH was the first hospital ship that we had, and I'm going to tell you a bit more about how that all functions. And then there were climate action interventions, which is for disaster preparedness at the very start. Then you can think about education and sustainable economic development programs. And then throughout the years, there were, through innovation, expansion, and work with the local communities, we ended up to where we are today, which is a fairly big organization. These are just some numbers that we don't really go about, but they're always good for metrics to have. And so the structure as it is today really helps to organize how a multisectoral organization can function, and to think about the governance. So Friendship Bangladesh is the headquarters of Friendship International Network, where I sit here at Friendship France. We are here. The sole purpose, if I'm to simplify it, is for fundraising, because most of the funds are going to be in Europe and the US. But most of the work I do, I'm actually more in contact with colleagues in Bangladesh than I am with my 4 colleagues in France. In Bangladesh here, I think the latest is slightly higher than this, but yeah, 3,500 paid staff. You can add almost the equivalent of that in voluntary staff. And I don't mean volunteers from Europe and the US traveling there. It's people from the communities who volunteer in disaster risk reduction, schooling, etc. And over 2/3 of the staff are recruited, of the paid staff are recruited from within the communities, which ensures a real local anchorage in the intervention areas. The interventions are set across 6 sectors that are supported by central supporting units. So this is, all the operations are really important. So admin, procurement, field operations, communications, fleet management for our fleet of hospital ships. All of these are central to every single one of these sectors. Obviously, finance, we're an NGO, we depend heavily on funds. And as you can imagine, these are dire times. And then partnership development is the key hub with whom we work to try and, we are really an intermediary between the donors that are here in Europe, for me specifically France, and Bangladesh. I'm going to go a bit more into the 4 commitments, just to give you an idea of the types of interventions that Friendship has put in place and how they all feed into it, and then I'll come into 3 projects and zoom into those a bit more. So saving lives, it really started with healthcare for all, and as I said, the Lifebuoy Friendship Hospital. Lifebuoy is the name of a Unilever product, and they were the first sponsor back in 2002, and that made this whole journey possible. This particular boat came from Dunkerque. It's a bit of a crazy story. Jean-Yves Mar, so who's French, he was an Air France steward, was a bit of an adventurer. There was a law that passed in 1996 that decided to narrow most of the French canals. So a whole fleet of river boats were going to become obsolete. He thought that was ridiculous because these boats could be used for many reasons. If I simplify it, he opened a map of the world, looked where there was the most water between the Amazon basin and the Bengal Delta. There are a lot more people in the Bengal Delta, so that's where he set sail for. Literally crossing the whole of France through its canal system, which was the easy part, out through the Mediterranean to the Suez Canal, and then out into the Indian Ocean, all the way up to Bangladesh. Couple of years to get there, and obviously a few scares, because any of you that have ever sailed know that riverboats aren't supposed to go on the sea or the ocean. So that's how it started. And then you have acute rescue when you have disasters like floods, cyclone shelter, water treatment plants, that we heard a little bit about to provide potable water, food relief after disasters once again. And this can be quite linked to climate adaptation, where you'll have climate compatible housing, adaptive farming, solar panel, shelter. I mentioned the cyclones earlier. And here, for example, is an elevated village that we call a plinth, that was designed with engineers actually from the Université de Liège in Belgium, that is oval shaped because when the floods happen, you can imagine that all around there are waters, and the oval shape limit river erosion, riverbank erosion, sorry. And so this can shelter, this particular plinth can shelter 200 families, and there is a school on one end and a community center on the other to ensure that the village life and the community life can continue during multiple weeks. There's an area for livestock, there's an area for vegetable growing, multiple weeks and months. There's a hollow middle to collect rainwater, to wash their clothes, because all the water around the plinth is going to become contaminated and polluted because of the floods, but also they can do agriculture and raise fish. Community-led adaptation. In each community where we have climate adaptation interventions, there is a committee of community members, that are going to decide and map out. I was there in May and blown away of the level of collective intelligence, where within the community center they actually have hand-drawn posters of all the recent floods across the years with very clear signs of, okay, we're this season, these are the risks, this is how we can mitigate for them. There's a map of the community that identifies all the vulnerable households. So you're going to have elderly, you're going to have young children, you're going to have pregnant women that are going to be identified, and flood volunteers will then target them for relief when a flash flood will happen. Poverty alleviation, this is really the next step to enabling development and empowerment. So one of our big interventions are the farmers collectives, where you'll have farmers club in our interventions area that will allow the sharing of innovative, sustainable agriculture practices and sharing of practice and knowledge between farmers in the surrounding area. They'll also provide an area to access markets, and so the farmers can sell their produce. This goes hand in hand. I don't think there's a photo here. It was probably in the other one. Yeah, with solar villages, where access to energy and renewable green energy was actually pivotal to not only farmers so that they could open their stalls in the evening after dark because they didn't have any light source, but also to school kids who could do their homework in the evening, and so that's a huge lever for development, accessing education. Which is where empowerment comes in. Friendship has developed a very big education program with schools across all of the country that have some of the best national results, where we don't only focus on the national curricula, but we also set it with their local environment. I think I'm going to talk a bit more about that in the roundtable discussion, but just about the risks and benefits, for example, of the river, and so that kids can grow without fearing the river. They have swimming lessons, for example, clean house, clean homes, clean schools, clean homes, sorry, interventions to teach them about the importance of hygiene and being in a clean environment, and the links between all those different components. Paralegal booths, gender equality, these are all linked to government services where we facilitate, for example, taking legal action for whatever reason. Usually it'll be conflicts around land ownership and being able to grow produce. But you also have a lot of child marriage issues in these areas, which is illegal in Bangladesh, but that still happens because usually families can't sustain the finances to for their daughters, and so they'll usually marry them to an elder man. And so we're trying to mitigate that as much as possible, as well as within the communities, but also taking action at government level. And so now let me just go into three specific projects that we have. So climate-adapted participative health system, where it relies on three tiers. We have the hospitals, 7 which are ship hospitals like LFH here, the satellite clinics, and Friendship Community Medicaids, which are community health agents that are recruited from within the communities directly. The ships will kind of anchor in one given area, and a camp around the ship will be built, and it will stay there for approximately 3 months before moving on to a different island. And during that time, you have satellite clinics that visit a community every month. So every day they'll visit a new community, and that community will receive the nurses and primary healthcare professionals once a month. And so they'll conduct the immunization program as per government recommendations, primary health clinics, cervical cancer clinics, and They also facilitate nutrition sessions, which are really important, looking at what local produce can the families use to try and avoid and combat stunting, for example, and underdevelopment. And all of this is backed up by the community Medicaids, which are trained into basic primary healthcare monitoring, so taking basic measurements, for example, for stunting. And then they are connected to satellite clinics and the hospitals via an internal software called mHealth, which uses a basic smartphone algorithm to identify whether a patient needs to be referred either to the nearby satellite clinic or the hospital ships. The hospital ships can take up to basic tertiary level healthcare. They won't do open heart surgery, but those patients, for example, if they require it, will be referred to by the boat ambulance to the nearest government facility. Yeah, so as I was saying, all of these are connected, and I have now, thanks to some work over the last couple of years, all the records are digitally kept. And so I was speaking to some fellow speakers here and saying how that can now be used also for further research. Recently, ICDDRB kind of validated the model, the 3-tier healthcare model, showing how adapted to climate change it is in an area that's highly prone to floods, but also how affordable it is because all the services are free. Then it means that we're highly dependent on donor funding, obviously. But yeah, that's one example. And then our mangrove afforestation program. We're now in the southern part of Bangladesh. This area in dark green is the Sundarbans mangrove forest. It's the biggest mangrove forest in the world, UNESCO World Heritage Site. The border to India is approximately here. And so you can imagine from the shading here, you could imagine an area that was probably at least this was covered by mangroves pre-British Empire era, where the land was heavily exploited for its resources by both the British Empire, but also local communities that needed those resources for fuel and cooking, etc. So we're approximately here, which is 30 to 40 kilometers away from the coast, but all of these water systems are still affected by tidal movements. And so it looks like this at high tide, and you can imagine that at low tide, it looks like this. You have an area which is highly dependent on shrimp farming and has very little other economic opportunities. So whatever you're going to develop has to improve the economic perspectives of those communities, and very fragile infrastructure. This is the only dam between the water, and you can see here some houses and other communities, that during a cyclone, for example, these dams will break very easily. And we were at a stage where dams would break every year because they would have a cyclone on a yearly basis. So to kind of counter that, Friendship started a mangrove afforestation program based on the community participation, where these are one of the maps that I was telling, similar to the one I was telling you about. Probably can't see much detail there, but a committee group will draw out the map and identify the areas of fragility within the dam, where the rural livelihoods dependent activities, so either the shrimp farming activities or if they're rice cultures, and where the people are living and where the vulnerable people. And we'll then develop nurseries that look like this. I always get asked why they round. We don't have an answer, but it looks pretty cool. Where we use 6 species that come from the Sundarbans, so totally endemic, because they will have different growth rates and also imitate a natural forest, which will have a greater impact at breaking waves and protecting the dams. And so this photo is, I took 2024, so when I was there 2 years ago, almost 2 years ago, and this dam, as you can see, has now vegetation growing on it. These are the mangroves that we planted, or that the community planted, and this dam hasn't broken since. This was 5 years after the beginning of this program, and we estimate that that's the time needed for the mangroves to be mature enough to have a fully protective impact. You might have heard a lot of mangroves because they're very trendy in the development sector. We really started it to protect communities and their livelihoods and avoid the dams breaking. But now we're seeing, within the first 5 years, you see biodiversity restoration, and you can tell by fishermen coming back to areas that they had totally deserted. And so that's providing another source of livelihood to the people that were highly dependent on shrimp farming, for example. You need to keep in mind that the protection of the nurseries and the plantation areas are key, which is why there's this photo here of a community caretaker running after a goat, which loved to graze on the small plants. And this actually, installing fences along the plantation areas was probably the most impactful adjustment that was made during the project, and that really allowed the trees to grow. And now goat owners totally realize the impact that mangrove is having on protecting them and don't want their goats anywhere near them. And then finally, I wanted to give you an example of a project that we launched last year with the French Development Agency. That's kind of a concentrated approach to all of Friendship's interventions and approaches, where we have one specific objective that's focused on health, one on empowerment and education activities, and one on climate adaptation and resilience, all within one single project, which in the development sector is fairly rare, let's say, and at least for us, it's the first time that one of our donors fund different programs or different sectoral approaches. And for AFD, it's also their first time via their civil society branch. These happen in 2 different areas. So Kurigram district is in the north, where close to where Friendship started, and then Shatkira is in the south that I just showed before with mangrove plantation. Here we're replicating the Friendship health system in an area where there are very little or poor level health services. Then we are strengthening 5 schools, and we have a huge program on fighting against child marriage, both, as I said, raising awareness within the communities, but also working with government to allow better detection by local authorities. And then, as I said, mangrove afforestation and the construction of 2 plinths in these areas. This is the project consortium. Such a project takes a lot of work to coordinate. Now? Yeah, okay, thank you. So because it's an AFD funded project, Friendship France, we're coordinating it very closely with Bangladesh, obviously. We have different technical partners. So RAW is an architectural association, IHE, Institute for Water Education, and they're heavily working on this aspect of climate adaptation. Action Against Hunger, which I'm sure you've all heard of, they're helping develop quality health services with a nutrition aspect, and Friendship across all of them. as this is really from a partnership level, so we're not in science anymore, but it's always interesting to understand how these projects and programs are built. AFD are bringing about 77% of the funding, but they have co-funding requirements where we have to go and raise minimum 20% of the total budget with other organizations. These are just the confirmed, but we're still missing some funding that we have to find before the end of the project. So yeah, this was just an example of how complex a project, the multisectoral project can look. These are just some research ideas. As I've been sharing with some colleagues, we're really, so we're a field-based implementation NGO that is slowly starting to look at external partners to better structure our data collection and also participate in studies, because we think, or as Runa says, who's here in yellow, it seems to work, but she doesn't know why, and it was done in an organic way. So now we want to try and model the friendship development model to see how we can better improve it, so maximize impact for the local communities, but also share it with partners around the world that could be inspired for different settings. I think these are mainly around food safety, but on any of the topics or sectors that you've seen, we have research ideas. Mangroves are a big one, the whole health system. So if you're interested in any of this, please feel free to reach out. Just some references, and thank you very much for listening.
Do we have any questions in the room?
Thank you very much. It was very interesting. I have a question. Do you work with another organization for animal health?
Yeah, so we're slowly starting to develop paraveterinarians in the communities in the same way that we have paramedics. And so the veterinarians will be trained, paraveterinarians will be trained by either in-house veterinarians that work within our sustainable economic development sector or with the National Veterinary Authority. But it's something that we're slowly starting to develop. So any ideas, we're very welcome to.
Thanks for the presentation. We spoke about this before, but I find it interesting. You flip my paradigm of like the supply side doesn't move, but the demand side does, because here your supply side moves around. How do you decide where the boat goes if there's some sort of extreme event? Because I got a sense that there's a routine set of locations it goes to, but what if something unforeseen happens? Do you reroute, or do you continue that?
So because route? The big hostile ships obviously take a lot, I'm not on the screen anymore, but the big hostile ships take a lot of logistics and setting up. Those will mainly stay set for those 3 months. However, we have a network of smaller speedboats that can provide relief and referrals to the hospital ships or other government facilities during a flash flood or another type of emergency. And all of this will be monitored live by the digital software that was identified, where community Medicaid can flag any emergency live, and that will send a message to the head office in Dhaka that can then deploy the fleet and services as needed.
Thank you very much, Max. So for our final presentation of the day before the Idoh Roundtable Award Ceremony and Graduation Ceremony, I welcome Dr. Hongying Lee. She's tuning in from Columbia, US, and she's a senior program manager of engagement and impact at Columbia Climate School, where she fosters a transdisciplinary and cross-sectoral approach in working closely with communities, academic institutions, policy stakeholders all across Southeast Asia, China, and Africa. And she works on strengthening resilience and inform evidence-based policies. Are you here with us, Hongying?
Yes.
Hi.
Hi, everyone.
Yeah. Hello. We can hear you and we can see you, so fire away.
Thank you.
Thank you.
All right, so thank you so much, first of all, and thank you for sharing those exciting work. In previous talks, I'm going to carry the spirit to share with you a little bit more about my work. I'm going to share my screen. Oh, wait. Can you all see my screen?
Yes, we can see your screen. Thank you.
Okay, all right. Thank you. First of all, good afternoon, good evening, and this is the last presentation, so I will make sure it's not data heavy and give you some fun moment to watch some videos. And thank you so much for having me here to be with you for this infectious disease and One Health Day, and also the celebration of your graduation. So today, my name is Hongying Lee. I'm working as a senior program manager at Columbia Climate School. But today I'm going to share with you a little bit more about my research, also my journey from research to implementation, and you can perhaps see how One Health concept has been shaping my journey along the way. So at the very beginning on this figure, I want to show you the origin and emergences of infectious disease. We all know all the microbes are essential part of our ecosystem. So for human beings, we are hosting different microbes. They are very important for our health. The same for the animals. So all the animal species, they're co-hosting, coexisting with different microbes, which could be fungal, virus, different organisms in a harmony way, unless there's some changes happen that's disrupt the dynamics between the animal and those microbes. That's when those microbes will be jumping from species to species and sometimes between animals to humans, causing we call zoonotic disease. So usually what happened is the changes we made to the environment that cause those cross-species transmission. So when we talk about emergent infectious disease, usually we will say the animal are very dangerous. We always put the blame at the animal, but it's actually our human behaviors. So this is what we're talking about, the underlying driver of emergent infectious disease. It's usually land use change. It's we will converting forestry into agricultural land, and also climate. So if the climate change, the weather changes, it's going to affect the reproduction of the mosquito, and then a lot of mosquito-borne disease is going to change. So this is a basic knowledge of emergent infectious disease. So to address this issue, one of the things we have been doing is to look at what are the viruses, what are the different microbes among the wild animals. So in the past decades, I had a privilege to be part of those research, looking for viruses in wild animals. This is back to SARS. When SARS happened, all the scientists have working on to tracing where SARS come from, where the coronavirus came from. So they find that bats are the natural reservoir of SARS-like coronaviruses. Since then, we have been spending a lot of time searching among bat species in China and Southeast Asia, trying to find out more viruses that carried by bats. So we go out sampling bats, tested them for viruses. We find viruses. Whenever we sample bats, that's natural because it's natural for them to have host different viruses. But not all the viruses can infect human beings. But there are a few of them we find in a lab environment. We find those viruses can be potentially infecting human beings. So this is the surveillance we have been doing in wild animals. In addition to that, this is where the One Health approach come into the way a little bit is, yes, we find viruses in wild animals, but that don't mean anything. Then we need to find the evidence or need to know if those viruses has jumped into human being, has those viruses been affecting human health. So in addition to working with wild animals, most of my responsibility was to lead these efforts to doing human surveillance. It's both behavioral surveillance and biological surveillance. So we do observation to see how people interact with wild animals and domestic animals in different scenarios. So we call it human-animal interfaces. Usually we would think about wildlife trade, but in most cases, it's just where they live in local community. So we observe those practice, this daily practice of local community to know how they interact with wild animals. And we interview them to understand like their daily routine and how they come into contact with wild animals. We also do questionnaire survey to know more detail about what animal do you contact every day? What is the frequency and how you contact with the animal? It could be indirect by, through contaminated environment. It could be direct when people are hunting that animal or they are bitten by a bat or rodent. So at the same time, we also collect biological samples to test for antibodies. So the logical behind this is we find a virus in wild animals, and then we want to test a sample from human for antibodies against these viruses. So if we find an antibody in humans that against the virus we find in wild animal, that means the virus has jumped from animal to human beings. So this is what we have been doing, different surveillance, and also trying to link this evidence to certain type of behavior. So we know what type of behavior is most risky, so we need to work on that behavior. So we find evidence, but we find antibodies in human, but we didn't find any evidence showing that those virus actually cause disease or illness among human beings. So far, we don't know yet. So this comes to a point to think about how we can prevent those type of events, because it's so much work we do with the community to identify the evidence. Now we know there's a potential spillover event happen, what we do. So this is a part, really a lot of reflection among myself, thinking about how we can translate those evidence into practice and policies. And I also think about those years we're working with the community. Why? Because eventually we want to protect them. We want to prevent the disease. So there's something we need to do. So that's how I moved beyond the evidence into next step, looking at the policy and the behavior change, focusing on two major human-animal interfaces. One is wildlife trade, including farming practice, because this is one of the most systematic human-animal interaction we know, and there are also many high impact emerging infectious disease happened related to wildlife trade. Second is the human-bat coexistence, because we know bats host several viruses, and some of the viruses are potentially zoonotic to human beings. So looking at the wildlife farming and trade, I think you have already heard from previous presenters, it's always how we are going to address this issue. It's either up-down approach or bottom-up approach. So here I'm looking at both approaches. So first is about behavior change. So, but thinking about behavior change, we need to first think about who are the people we want to change behavior. Because when we think about wildlife trade, the whole supply chain, there's so many different actors. It could be hunters, it could be farmers, it could be consumers, you and me. Although most of us do not think we're involved in wildlife trade, but another study we're working on looking at the fashion products in wildlife trade really tells the stories how Western countries purchasing a lot of fashion products is related to the wildlife trade, wildlife farming in Southeast Asia and China. So it's different type of behavior we're looking at. For consumers, well, the most straightforward way is just don't consume wildlife or wildlife products. But that's different, depends on what type of wildlife products we're talking about. For farmers, because wildlife farming or wildlife trade is usually, especially for rural community, is a very important part of their income, their livelihood. So it's really unfair or unrealistic to tell them to stop doing this. So then another angle or perspective we're looking at is how we can make their practice safer or sustainable. Good for human health, it's also good for animals. Of course, at the same time, we're also looking at the structural barriers, because before behavior change happens, there's a lot of things we need to do. It's about knowledge, it's about access to resources and different things. Another approach is looking at the policy. This is really a question arise during the COVID-19. When we see how China responded to COVID-19 when the outbreak happens, everybody was asking questions, who is managing this? Who should be taking responsibility or accountable for all of this? So this is a figure showing the different policy or the different departments who were involved in the COVID response in China. So we can see it's not only public health issue. When it's to do with wild animal, zoonotic disease, and in a wildlife market, it's forestry department, agriculture, market regulation, and even to do with transportation management. So we can see this is a typical One Health issue we're facing. It's not only one department can do everything, it's really require all the different stakeholders to take action into this. And this figure shows you how zoonotic disease is managed in China. We can see clearly there's 3 major departments into this. Human health, agriculture, because it's more developed for the domestic animal compared to wild animal, and the forestry department. So we can see clearly there's a lack of capacity among the forestry department. There's a little collaboration between human health department and the agriculture department, but not very much. So by looking at this, we can get a sense about the landscapes. What are existing policies? What we can build upon those existing efforts. And the most important thing is how we can bring them together for this very specific zoonotic disease issue, the One Health issue. We did a similar work in Vietnam, basically for wildlife farming, because when Chinese government closed down when COVID happened, Chinese government closed down a lot of wildlife farm in China. So there was a discussion ongoing about, okay, maybe this can drive the wildlife farming industry in Vietnam. That's why we wanted to focus on Vietnam to see how this is working. So in addition to do policy review and analysis, we also talk to different government officials from CDC, from agriculture, from forestry department to see what are the existing efforts, what are the gaps, and what they're thinking about the current situation, what are the needs. So by bringing them together, we really create the platform for them to start the dialogue, to start the conversation the first time, maybe not first time, but the first formal time to discuss this issue. We find similar situation in Vietnam, similar to China, is they have all those policy existing, but the enforcement is another story. And in a workshop we did together, they also have been talking about the lack of information sharing. For example, agriculture department, the forest department has been building up a wildlife farm monitoring system. They have all the data about where are the farms, wildlife farms in Vietnam. However, the veterinary under the agriculture department didn't know those data. So, but they do have the knowledge and the capacity to help to do the monitoring, to do the veterinary care for those wild animals. So this type of information sharing was actually one of the entry points we identified through this type of workshop, this type of policy engagement work, to start sharing the information, to start forming the collaboration or building up sort of a coordination mechanism between those departments. So this is type of the policy example I can show you, like showing like this is really a One Health issue and it requires different stakeholders to take action in. And then we look at behavior change. This is pretty much focused in China, but it's very interesting. It was conducted before and after COVID. First of all, at the very beginning, I wanted to do this wildlife trade related to zoonotic disease. It's very interesting because wildlife trade has been talked as a conservation issue for a long time. But now I want to talk about the wildlife trade as a public health issue, because the first time a wildlife market was closed down in China was not because conservation, not because we care about animals, it was because SARS. So I still believe that public health is more related when we are talking about our audience or talking about the public. So before doing this, we wanted to know how much people know about the zoonotic disease, how much people know about zoonotic disease specifically related to wildlife trade. So we did this survey among population in southern China, majorly in 3 provinces we know have a lot of wildlife trade activity ongoing. So it's not unexpected. People didn't have sufficient knowledge about zoonotic disease. Even many of us have experienced SARS in our lifetime, but people tend to forget. Even there was a huge threat, a huge emphasis about the threat of SARS during that time. There was also an article, study came out right after SARS, people saying they were not going to consume or engage with wildlife trade because they were concerned about zoonotic disease. But the fact that COVID happened and the fact that people still cannot recognize many zoonotic disease related to wildlife trade activity, that means behavior change really require more than one time emphasis on the threat of the zoonotic disease. It really requires consistent building of knowledge and sustained awareness raising across timeline. So as I said, people said they're not going to consume wild animals after SARS, but COVID happened. After COVID, there was a similar study about people's attitude about wildlife trade, saying people said they're not going to consume wildlife because of COVID. So, but it's still ongoing. I want to find out why it's still ongoing, what happened, what are the motivations, why people are doing this, how we can stop them. This comes to the second study to look at the driver and the inhibitor of the wildlife consumption in China. So this study was built on a certain behavior change framework called theories of planned behavior. So I try to quantify those behavior factors, and we can see that although I keep saying attitude change don't mean they're going to change behavior, but through this study, among the same population in southern China, we still find attitude is a very strong predictor of behavior intention. At the same time, subjective norm, it's also a strong predictor. Subjective norm is like how much I care about other people think about it, how much I care about the overall environment, the traditions of this, which means, yes, although it doesn't mean it requires consistent work to enable behavior change, but by changing attitude and a subjective norm or social norm, there's still a potential we can help to change behavior. And it's very interesting if we look at into details, like what are the beliefs people are still holding that's going to drive their consumption behavior. We can see at the bottom, the belief that wildlife can improve our health, wildlife can cure disease, still motivating people to consume or to purchase wildlife or wildlife products. One thing we find out from this study is also the key population, which were males and more than 35 years old and who had a higher income, are the key population still reporting consuming wildlife. So this data really give us some insights about behavior change strategy, who we should be targeting, what type of belief we should be talking about, and we need to change attitude and change the social norm around wildlife trade. So those are the example about how we're doing behavior change, the conducting behavior change research to inform like actual implementation to address wildlife trade issue from the policy, from the behavior change aspect, bottom up and up down approach. And then next, I want to share with you, also building upon all those previous research, papers, data, thinking about how we can really make something different, bring tangible things to the community is I have been working with local communities in Thailand to develop or maybe just to refine the solutions that can maintain a positive relationship between human and bats. The reason I wanted to do this was because for this many years, I work with local community interacting with bats. It's not that simple as we saw on social media. You know, when we hear about bats, we think about zoonotic disease. I think that's one of the least things they are concerned about. So there's more things inside this human-bat relationship. And I want to tell the story, but the most important is nowadays we're looking at how people can live with nature, live with the changing environment, is that we can learn so much from the local community. We can learn so much about what they have been doing, have been addressing. So I want to, through this project, I can help them to become confident about talking about their knowledge, their practice, and make decisions about what they can do to protect their own community, their own health. Because the zoonotic disease is just one of the many things they're facing as a challenge in their daily life. In Thailand, the climate change is very obvious. Flooding is an issue every year, and the dengue is very serious this year because climate change. So it's about building the capacity of a local community and improve the resilience. So these are the three communities I'm working with. One, they are representing different types of human-bat relationship. One is a community who collect backgrounders as fertilizer. So it's business. It's pure business. It's good business. And they have been running this for more than 60 years. Another type of the interaction is bats in temple. This is different because temples in Thailand and Southeast Asia, they're always either they're in caves or they are a sanctuary for bats or wild animals. So you can see bats, monkeys in temple because hunting is not allowed. And the third type is conflicts between human and bats because we know bats eating fruits and there's damage for crops. There always some concern around this issue. So by working on these three type of human-bats interface, it's not only about the zoonotic disease prevention, it's also about their cultural preservation and how we can make their life more sustainable and how we can build the resilience of a local community. So we use the similar method, but at a different stage of those projects. We provide training, we do interview to get feedback, we do focus group discussion for people to share their concern. And of course, we also always do observation to look at how they're doing this. I want to share some video. I hope it works. You can see those are the bats. This is one of the side I'm working at the background collection. So this every Friday evening, there's a local market, and every evening the bats flying out for foraging, flying over the local market. And then next to this market, it's a background collection site. People go inside this cave and collect the guano, the bat feces out, and then pack them and then sell them as fertilizer. And this is a temple, the cave belongs to the temple. So it's a community thing happening here every Saturday. So yes, it's a good business. Actually, I was there last month in July, and the owner of the business told me if you want to order more background, you have to wait until December. So it's a business they have been running for 60 years, and they only collect the guano every Saturday because they want to make sure the business is sustainable. Because of this, they do protect the bats in order to protect the incomes. In this case, we sample a lot of bats and testing a lot of human sample here. We find some evidence, but we never find any sickness in those human beings. So it's unrealistic to say you just stop doing this because it's too risky. No. So what we're doing is to help them to make this business more safe for human and safe for bats. Because when people are sick, if they go inside the cave, they could transmit the disease to bats as well. So we identify a few high-risk behaviors at this site, like people eating, drinking at the site, people not washing their hand very properly, and they don't use much protection themselves. And we test all those interventions. First of all, hand washing. We fix the sink so people can wash their hand, and we provide all the soap, and they can also wash their feet after work. So we provide all those resources and follow them for 6 weeks to see how they're doing. The second is we're trying to help them to wear mask, but it's really hard. But we do this training. We train them how to wear N95 mask. We provide the mask every Saturday morning when they come to work, and follow them for 6 weeks. The third intervention sort of is we set up a designated space for them to eat, for drink. And people are not supposed to smoke in a temple, but people are still smoking. So we set up a different area for them to do this. So I can tell you this don't work because people are still very much concerned about the like contamination, because this food, drinking, eating space is very close to the site, working site. So they're saying it doesn't really make difference here. And if I'm wearing my dirty clothes to come to this site to eat, it's still very risky. And the mask didn't work because it's too much for them to wear. And during our focus group discussion, people complaining how uncomfortable this is. And based on our observation, you know, when the temperature is high, humidity is high, the number of people who wear masks has dropped significantly. It didn't work. And the hand washing, that was the only thing that worked very well. People feel more comfortable after they washing their hands. They feel more confidence going back home, and they really appreciate this work. So we were talking about with the temple. So they agreed to supply the soap and make sure to maintain this hand washing facility at the site. So this is a little test for those interventions we're thinking. And talking about face cover, it's still very important, especially given that most of the disease viruses we find in bats are respiratory. So we're looking at what they have been doing. This is what they're doing locally. They use a closet or a t-shirt to cover their face, their nose and the mouth. So we're working with them to think about how to, next step is how to disinfect, how to washing those things after work every time. So we're still working on that. And the second place is in a temple. This is a complete different thing. It's not a business, but it's really about appreciation of bats. So bats has been living in this place for decades. One of the things when I talk to them is really, they're talking, you know, they don't think they own the land. They said the bats has been here for the hundreds of years. We're just guests here. So you can see this is a school inside the temple. So they really appreciate the bats. They have bats on their logo. They have bats on their syllabus. They put bats on everything they created. So we're working with the school to provide education to the teacher and the school children. Very simple thing is very simple thing, for example, do not play under the tree because the bats are roosting on the tree. And they also cut off the trees around the playground, so bats are not roosting there. We're also working with the clinic, community hospital to train the health volunteers so they can go to each household to tell them to educate them to how to deal with bats in their house and how to deal with dead bat bodies. So this is a complete different scenario relationship with bats. So what we do now is just learn respectfully to learn about their culture, their tradition, and to work with them to make their life more safe living with bats. And this is another video. So this is the daytime. When you go to the temple, the school, you saw all those bats roosting on the trees. So it's a thing. But for local people, they get used to that. They don't care. They don't think about that too much. And during the sunset evening, all the bats are flying out for foraging. By that time, all the people already goes inside their household, and in the morning they come back. So this is just part of their daily life. They do appreciate bats being here, and they want to protect them. And the last thing, I haven't got a chance to get into too much, but we're working with a community in Thailand who has been experiencing a lot of damage from bats. So, but we did some preliminary interview discussion with the community. It turned out that bats are not the most concerning thing for them, because they know bats are coming to eat the fruits. So when they plant every year, they already counted the damage from bats. So they don't mind, but the thing we want to work with them because they do set up nets to trap bats. And some of the people, they reported they eat the bats after trapping the bats. So that's something we want to work with them to make sure they use a better method to protect their foods. And they also use very harmful chemical to scare away bats. But it turned out what they're more concerned is about the elephants. So the elephants are in this community, they damage more crops compared to bats. So we're also reaching out to some conservation organization to work on human-elephant conflicts to see how we can work together to address those human-wild-animal interaction issue. So in the process, of course, we also developed a series of different educational materials based on the different scenario people come into contact with wild animals, and based on local resources and what they can access to provide some recommendation how they protect themselves. And of course, we keep emphasizing the value of wildlife to our ecosystem and our daily life. And also most important is about the local context. We adapt all those books into different country, different community. I think it has been translated into more than 6-7 Southeast Asia language has been used in different scenarios. And they are all open access. You can take a look online to see if that can be useful for your work. And thank you so much for this. I also watch birds. That's one of my favorite things when I go out, in addition to watching bats. So this is a bird in Thailand, very popular, you can see. And any questions, welcome. And if you, I know we're probably out of time. So if you have any question, please feel free to reach out. Thank you.
Thank you very much, Hong Ying Lee. Is there any last questions? It's your last chance. Oh, we have one over there.
It's actually two questions, if I may. So you mentioned the serological examinations you made. So can you comment on the seropositivity of persons in that region on certain viruses, for example, beta coronavirus? And secondly, so giving the exposure to bats that you showed in these communities, so it's pretty clear that you need an intermediate host maybe to amplify these viruses and make them more adaptable to other mammals. So is there an ongoing surveillance in these farm animals that in China? Can you comment on that?
Yeah, thank you so much. That's a great question. Yeah, so the serological evidence is mostly on alpha coronaviruses because unfortunately all the surveillance has gone because the federal funding issue, because all those projects has been conducted, supported by USAID and NIH, the US federal grants. But so far, yes, we developed a series of panel of different alpha coronavirus we identified in bats. In China and South Asia, we tested them. We find serological evidence. Although I have to say I'm not an expert on serology, and also it's very difficult now because everybody was vaccinated for COVID. So it's a little bit, it's challenging to distinguish if this positive is from COVID vaccine or it's from actual exposure to bad coronavirus. That part still needs a lot ongoing work. I'm not working on those type of project anymore, but I know some people are still trying to get more information, finding more samples. I think everybody was looking for samples before COVID now, human samples. So that's probably can give more clear answer about this exposure. And in terms of intermediate host, yes, I know another project ongoing on those side is they're going to sampling collect sample from the domestic animal, mostly cats and dogs on this community, because they're full roaming dogs and cats in this community. That was their hypothesis. As you said, they think perhaps those are the intermediate hosts, because we find the virus in bats. We also sampled the macaques on those sites and the rodents as well. We didn't really find much. So that's really next step. But in terms of wildlife farming in Vietnam, we did collect some data, but mostly looking at the cross-species transmission, because a lot the farming facilities are very complicated. It's not always like we think. Some is backyard farming, they mix with different species, mix with domestic animals. So that study was looking at the cross-species transmission, definitely a higher risk of cross-species transmission, but I'm not sure if there's any ongoing surveillance. Of course, we need more surveillance, but it just, unfortunate time, not much work ongoing. And one thing is China back to farming again, because all those economic loss. So all the closed down farms now seems they're reopening, and the government is giving more flexibility to farm registration nowadays in China. So it's people forgetting all of this, and I think everybody is almost forgetting the pandemic, but we still need to do more work to raise awareness for prevention.
Thank you very much, Hong Ying Li, coming from Colombia. Yeah, it was wonderful to have you here. So now for the roundtable, Stan, I invite you on stage to introduce it all.
Hello, there we go. Great, okay. So, I know we're running a little bit late on schedule. I'm very sorry for that, we are. We're gonna continue with a small roundtable session. Afterwards, we have 5 more minutes in which we announce the winner of the flash talks. And then afterwards, we go to the graduation ceremony. So, in order to discuss a little bit with you One Health and education on One Health, we established a panel of 6 people that we would like to invite on stage. So we can start with Dr. Jakob Zinstag, one of the speakers of today. Please, the keynote speaker of today, actually. Please take a seat, as well to Max Claren and Nusrat Khan. And then additionally, I would like to invite 3 of the coordinators of the master's degree of Idoh, of which we have the fresh graduate sitting right here. Namely Joachim Segales, who is the coordinator in Barcelona, Jens Bono, who's the coordinator in Hanover, and Jerry McLaughlin, who's a coordinator in Edinburgh. I believe the microphone should be on. So thank you very much for being here. I think the mics are on. We'll find out, I suppose. So we have a couple of questions prepared. We can see how it goes, and then we can also take some questions from the audience in case you're wondering something. One of the first questions that we received for this panel discussion included how can One Health education move beyond just technical training to also build the interdisciplinary policy and leadership skills needed to address real-world challenges. Does any of you have any thoughts on this huge question, which has also come up today quite often?
Well, I can try something. However, I believe that this is the key question probably, because at the very end, I believe that, well, you are demonstrating we are getting next generation scientists or personnel on the One Health side. And this is a big step compared to 20, 30 years ago. So from this point of view, I believe that we are in a good trend from this point of view. However, what is really important as well is when we are surpassing the part of knowledge and education towards the real implementation of the One Health. And probably this is one of the issues. I must confess that today I have been so happy because I have seen many success stories. And I believe that when you are tackling One Health, first of all, you have to define your objectives. And the clearer the objective, the much likelihood of trying to solve or approach the problem. So from this point of view, we think we are still lacking certain practicalities of the One Health. However, we are increasing in a systematic way what we expect from that. And very importantly, I believe that the One Health concept, which is very important, should not be implemented at the age that we are talking about nowadays. People, graduates or postgraduates, the One Health concept should be embedded in the education of the primary at very young people. So otherwise it would be very difficult to make conscious to the whole society that how important is this topic.
Wow, what an excellent answer. Anybody else have some thoughts?
Yeah, thanks.
Oh.
No, this one doesn't work, I've been told. This one should work. Thank you. I'm going to give an answer from the partnership development side where there's a role of, I think, researchers and practitioners to also really advocate for donors to fund multisectoral projects. I flagged a project during my presentation that's the first of AFD's civil society branch to fund health, education, climate adaptation within one project. And that took a few years. We had to take also people from the head office into the field to show them how our development model works practically. And it also took partnerships with other organizations such as Action Against Hunger, as I mentioned, an architecture workshop organization. So there are practicalities about reaching out to people who you're probably not used to working with, that will have different approaches to and different definitions. And it's being able to compromise, understand each other and work together that you're going to be able to leverage impact for the communities and that can then be turned into policy.
I'll just add quickly, completely agree with Max. And I think capacity strengthening on the ground is really important because as you've seen from the past few talks of this afternoon, a lot of this work is being conducted in other countries, especially LMICs, but we often take our ideas there and sometimes it doesn't translate to how people perceive this in that local context. So actually working with the community, building capacity on the ground, training, and developing a shared understanding is probably the only way to translate this into real life.
Excellent addition. Thank you very much.
I think this comment sounds pretty much like one of the comments we got from the EU reviewer of the grant. So Aurelia, hopefully you took some notes about the answers that we can put them in the next application.
I do feel, to quickly add a question, I do feel like this topic has been coming up quite a lot and also for a long time, right? So do we see any improvement in the way that we handle our sort of bringing ideas and changing our ideas to local interpretations and such? Or do we still think the situation is, I don't know, as bad as it has always been?
To answer that, I'd probably touch on how policy is being developed maybe, and the need. I'm a firm believer that systems thinking should be kind of mainstreamed across the sectors that are concerned with One Health implementation, because it gives you a tool that can, so that you can hear the different perspectives, beliefs from the different sectors and bring that together, even if without being a veterinarian, without being a doctor, etc. And so key methods like that, and maybe we very quickly touched upon this with Jakob yesterday, I think key methods such as systems thinking are a real driver for allowing that sharing of knowledge and practice between different sectors.
Thank you very much. Thank you very much. To continue, we also got a question on whether any of you would like to talk a little bit about your own experience in educational One Health programs. So some of you have taken One Health programs, some of you are coordinating One Health programs and are giving courses. Would you like to give some experiences on this, particularly you who have relatively recently graduated from a One Health master's degree, and for the others perhaps how One Health degrees have changed or become more attractive over the years?
I mean, I guess from a University of Edinburgh perspective, you know, we really enjoyed being involved in this Idoh course in the first few years of it before the disaster of Brexit, and which was great. But you know, obviously we see now that the funding for the program's running out, and it's proving difficult to keep the course going when it's providing good training in the area. In our college, the University of Edinburgh, we have a similar One Health PhD program that in the first year has a lot of top components and delivers a lot of skills and trainings, and then the students do a project. But again, you know, it's funded by the Wellcome Trust. It's run for 4 or 5 years. It's now about to run out. It's not been refunded again. So, you know, there are good initiatives, but they don't seem to be able to be maintained. I think that's one of the issues.
That's quite interesting, because at the same time everybody is talking about how One Health is such a key thing that everybody needs to take into account for combating any single disease. And I mean, everybody was exposed to the whole COVID crisis, so everyone knows what One Health is about nowadays. And yet there's some funding issues for the long-term planning in these things, at least.
I mean, there's definitely more awareness, but it needs more funding. Right. And again, within our college, the vet school, Roslin Institute strategy for the next 5 years is all based around, you know, being a kind of super cluster for One Health, integrating social sciences and veterinary clinicians and the researchers in the institute. But the one thing it doesn't really include that I can see is the lots of links to human medicine.
Yeah, just one comment of our experience in Barcelona, because in fact everything started with a local master in which it was entitled something like Zoonosis and One Health. But the major problem is that those local masters sometimes do not have the right funding for being kept over time. And of course, the co-financing with the Erasmus Mundus master that we had, it was a kind of win-to-win situation, because we could run the local master together with this international master. But again, is what you said exactly, and what happened as well in Scotland, that sometimes you get funding for a period of time, but there's no sustainable over time. And even, I would say that all the stakeholders are supporting that the One Health initiatives are compulsory, are very important, etc. Those is not just education, it's what's coming up after education. And this is a complex scenario. And if we are not getting the funding, that could be public and private anyway, the point is to try to make sustainable something like that, because what is not very logical is to, for a period of time, generate a number of professionals in the One Health sector and then stop and not having them for a period of time. So it wouldn't make sense, really.
Maybe different type of answer, probably more related to my perspective as having been a student on a different One Health course that was led by the London School of Hygiene and Tropical Medicine and the Royal Veterinary College that I graduated from in 2023, where it was really, I came into it really inspired and thinking, oh, there's going to be loads of very cool people on this course. They were very cool people, but we weren't many. And that was a real shock because of, as you said, One Health was everywhere. It's hugely politically trendy, etc. And then when I was talking to the course directors, they said, well, multiple reasons for that. One of which is I took the course in London, London being a very expensive city. We spoke about Brexit, how now European students have to pay international fees, which are over twice as expensive as home fees, home student fees, etc. So there's a lot of outside of education factors that come into it. And then in terms of the course itself, it was the next shock was how interested I became in medical anthropology, which was one of the compulsory modules. Coming from a biomedical background, so very technical, scientific, and how medical anthropology kind of was hugely challenging. I mean, I hated that assessment, but at the same time, it was hugely rewarding. And how systems thinking at the end of that, I'm coming back to this, but was the last module we did of the course, and it really helped us use the knowledge we'd gained in epidemiology of infectious diseases, medical anthropology, economics of One Health, agents of infectious diseases, so more on a biology level, and all of that we were able to use for a big group project that we did via systems thinking, using methods such as theory of change that you spoke about in your presentation. During the course of this, I was thinking also that the alumni we were hearing about were all researchers, and we weren't getting an overview of what people outside of research and academia were doing. Not that I dislike research, I've been doing a bit of research on the side to try and keep a foothold in it, but it's also, I think, showing how you could apply transdisciplinarity and multisectoral approaches to other sectors, other disciplines, which is hopefully what I try to do a bit today with Friendship NGO, but there are other organizations out there. I think speaking a lot about the political economy of One Health can be appealing to people that aren't biologists or vets. It can also be interesting to analyze the networks and how the power dynamics work. So yeah, just looking at the variety of opportunities that there are after such a broad kind of degree.
Thank you very much. Does the audience have any questions for any of our panel persons? If that is not the case, then I'll leave you with one more question just before we move towards a graduation. Is there one thing you would like to say to the fresh young graduates? Is there anything as a sort of message, a mentor message that you wish to give to some some people ready to change the world in the realm of One Health?
Well, what I would really recommend you dare really to engage in a study plan that samples humans, animals, and the environment in the same time. I mean, this is what is really missing. Doctors keep studying humans, vets keep studying animals, but nobody works together. So really dare to work together. If they don't want, you take somebody else. But you will find people that will work with you. And do everything professionally. If you are a vet, don't study, you are not looking after the humans. It's the doctor who looks after the humans. Do everything professionally, but your competence now is to work across sectors and use it. I mean, we are still so weak in these integrated studies, and that's the urgency that we have, and that's my hope in you, and to go forward with that. Good luck.
Hear, hear.
I would shortly say, so keep your curiosity and your motivation, because that will help you in times of doubt and when it's not working as you plan, but this will keep you going.
I think also on the back of what Jakob said, there are going to be times, and I have them regularly, where it could feel frustrating to not feel like you're an expert in a specific field. But it's sometimes really important to step back and actually realize, well, but I have much broader knowledge than if I was, you know, an expert immunologist on this specific interaction between this species of animal, this human, in a specific setting. You're going to be able to interact with that expert, with the policymaker, with the other authorities that are needed. And that, I think, is really important to keep in mind, and also to try and communicate to wider audiences and the other sectors that you're working with on the added value of working together, etc. And also remember to drink water while you're partying tonight.
Yeah, all this great advice. Just to add that, utilize your network. You have a great network now. Those who are graduating with you and will be coming forward in the next few years, keep collaborating, connecting together. You can be the mentor, and you can also be the mentee. And by building these collaborations, you can build better projects and get more real life impact down the line. And well done, everyone, and good luck.
Well, I believe I have to subscribe all the comments that have been said so far. But anyway, one thing that remembers me always, an African proverb that said that if you want to go fast, go alone. But if you want to go far, you need company. So the point is, get this company. This company means intersectorial communication, intersectorial collaboration, etc. Even yourself, you have different backgrounds, so the possibility of the network that you created already and the network that you will create afterwards will help a lot in your professional life. So at the very end, enjoy life, which is important.
Yeah, not much more to add. Networks and collaboration, don't reinvent the wheel. Find people to work with that you like to work with and enjoy it.
Thank you, guys. Thank you very much for answering all the questions, and thank you for giving such great advice. Let's give them all a big round of applause. And now let's find out which was the most popular Flash talk.
Can all the students who participated in the Flash Talks come on stage, please? We've been really, really blown away by the effort and enthusiasm that that each of you have brought today. Not only yesterday was it a 30-minute tough thesis presentation, but then to come up on stage and to continue with your 3-minute pithy presentation, we were all very impressed, really. And yeah, what a way to finish your master's degree. So thank you, and I can announce that the votes have been counted and verified. So now I invite Frédéric Tersac, who's been organizer of the Idoh Day and Idoh coordinator, to announce the winner. Thank you.
Well, Thank you for such a welcome. Oh, okay, so I will grow a bit. Okay, so I always dreamt to do that. And just to say, the winner is Theodora Teresa.
Now, let's go to the fun part. And let's be real, one of the main reasons why most of you guys are here. Let's move to the graduation ceremony. Sorry, and to start the graduation ceremony, here we have Stephanie Germont, another one of the coordinators of Idoh here in Tours, who will do the official part of today.
Yeah, so now it's my turn to close this fourth Idoh Day. As previously mentioned, this day was organized by former and current Idoh students, and I would like to give special thanks to Jade, Stan, 3 for the 5th class, Christina from the first one, and Valeria and Julia for the 4th class. Unfortunately, Julia and Valeria were not able to come. I hope I don't forget any students. If so, I'm very, very sorry, and forgive me, please. So they took over from Pat, Mariana, and Dera, who were the main organizer of the previous 3 editions. This day would not have been possible without your efforts, and you were supervised and supported by Frédéric Tersac, the local administrative manager here in Tours, and Aurélia Hiron, who is now in charge of the Idoh program. You used your network to connect us with renewed speakers, and I would like to warmly thank all the speakers for the inspiring presentation. We learned a lot today, and I hope you took advantage of the opportunity to network. I'm delighted that students from the local master program in infectious disease, immunology, and biomedicine participated in this day, and thank you, all of you, for your participation. I'm sure that everyone who took part, whether online or in person, enjoys that day. I would also like to extend my warmest thanks to Benoit and Jean-Philippe upstairs from their tremendous technical support. I would also like to thank all the university departments that contributed to this day. Of course, nothing would it be possible without funding. So I would like to thank the University of Tours, INRAE, which is the French National Research Institute for Agriculture, Food and Environment, the Loire-Valais project, and the company Powedian for their financial support. I'm also, of course, very grateful to the European Commission for supporting this master degree as part of the Erasmus Plus program since 2016. This financial support has enabled us to welcome students from very diverse geographical backgrounds, particularly students from low and middle income countries, for whom studying in Europe is an incredible life-changing opportunity. And I prepared some slides, but I realized that I didn't open my presentation. Okay. It's always like that, technical problems. Okay, so you can see that on this slide we welcome 7 intakes with 156 students selected from 3,000 applications. So they were really, the game was very, very competitive. Our students come from all over the world. I'll let you count the different countries, but you see that there is some numbers everywhere. And they all follow one academic path from France to Spain, and then either from Edinburgh for the first run or Hanover for the second one. And at least 1/3 of them are pursuing doctoral studies, and some of them have successfully completed them. So for those who don't know him, let me introduce you Pat, one of the organizers of the Idoh Day. He recently graduated from the University of Edinburgh, and here you can see him with the Edinburgh coordinators, Christine, Jerry, and Darren. Today is a very special day for me, as I've been coordinating this Idoh master degree for nearly 10 years now, and I will be stepping down from this activity tonight. It has been an incredible journey, and I'm very grateful to have met so many highly motivated students and to have been exposed to such multiculturalism. I was fortunate to work with fantastic colleagues from Spain, Germany, Scotland, and everywhere, and I think, or at least I hope, that we all really enjoy working together. Unfortunately, we were not able, as we already said, to obtain a new funding from the European Commission, and I hope that we will be able to find other financial support to continue this wonderful adventure and secure scholarship for students. And this year, we are welcoming the 8th cohort with only self-funding students. So I'm really happy to welcome them today on board, and if you could just either raise your hand or just raise you, so that we can see you. So we do hope that other ones could arrive, but I mean, we have some French visa issues. So I won't take too long, as I know that some students on my left are a little impatient for the graduation ceremony to begin. I know that some of them prepare testimonials about their experience at Idoh, so I will let them speak, and then we will begin the graduation ceremony.
We're not only scientists, but also artists, with Sarah, who created this wonderful group picture. Handmade, please.
Okay. Bonsoir à tous.
Buenas tardes a todos. Guten Abend, liebe Menschen. I feel like we can add another LinkedIn qualification to our profile, being able to speak 3 different languages after traveling all over Europe. And on top of that, starting with this very important master's title, the Erasmus Mundus Masters in Infectious Diseases and One Health.
So for those that might not know us, we are Tanaka, Emma, and Sarah.
We are part of the Idoh Cohort 7, composed of 22 wonderful individuals representing 18 nationalities and covering 5 continents. And we are graduating today.
Oh, sorry. So we studied in Tours, Barcelona, and Hanover, as Stephanie mentioned, and we completed our internships all over the world, from Australia to Costa Rica and Guadeloupe, and from Kenya to Finland and Sweden.
And this evening, we want to reflect about this incredible adventure that the past 2 years have been. And since we will become certified scientists in a couple of minutes, we wanted to discuss everything as if this was a very well-written scientific thesis that we wrote during our internships.
With the only difference for this one that we didn't submit it 59 seconds before the deadline.
So let's start with the first chapter, the introduction.
A little over 2 years ago, we arrived in Tours as complete strangers after coming from all over the world.
And some of us got some help with moving their luggage, from superhero Mina, for example, who went to pick up Fumbi in the middle of the night and traveled with her and her luggage from Charles de Gaulle all the way to Tours.
And then Sarah, Emma, and Jeanne saved everyone with their French.
And even more importantly, Frédéric and Stéphanie saved everyone dealing with visa issues and all the other silly questions we might have had. And there were many.
However, they could not save Claudia, who didn't know that on the first day that we arrived over here, it was a Sunday and supermarkets would be closed. And so she had to survive the whole day with only one croissant as food. But eventually, we started the Idoh adventure.
And so the scientific experiment started.
Chapter number 2, the methodology. Experiment 1, surviving 8 a.m. classes. Dear scientific audience, the first experiment was a brutal one and would definitely never have been approved by an ethical committee, as we learned during our laboratory animal sciences classes. But the question we tried to answer was, what would it take for young ambitious scientists to suffer as much as possible?
Possible options, French bureaucracy.
Lectures with black slides, like completely black slides, on microscopy.
Or 8 a.m. lectures.
Luckily, our cohort started organizing wonderful Idoh Insight sessions with an autumn walk by Jean and Sarah, a Pakistani tea session organized by Zoha and Jahan Zaib, wine yoga organized by Fernando, and we even got to visit the wonderful castles in France.
Other wonderful memories includes going to my first ever ice skating experience and having a wonderful movie night at Martha and Reze's place in Tours.
Until, unfortunately, the neighbors came to knock on our door as we were apparently screaming while we were dancing Just Dance.
And at the end of the semester, we had the opportunity to go to Brussels with the whole group to visit the European institutions and discover how scientific policies are made.
We were over there chaperoned by the wonderful Frédéric and Stéphanie, who made sure that we didn't miss a single metro or train. So thank you very much for it.
And the exchange of gifts with a Christmas Santa.
But the best gift of all was given by Tanaka at the end of the semester while he was dancing and ripped his pants on a night out.
Experiment 2, croissante con mucho chocolate. Another semester started, so then another question. How do you make sure that you don't get addicted to another university cafeteria?
And especially the croissante con mucho, mucho chocolate.
First of all, we distracted ourselves with getting to know new classmates, and new classmates meant introducing ourselves.
And please join us on this one. Hi, I'm Sabrina
from the US.
Or even better, Tanaka trying to show off his limited knowledge of Spanish and accidentally flirting with the professor.
And of course, we also attended classes on antibiotics, animal diseases, zoonosis, and we had really fun group discussions on the rights of cats. And Theo was very, very adamant about cat rights, so.
Meanwhile, the biochemists tried to stay undercover at a faculty full of vets and worms and prions that would eat your brain.
And then came the crazy part, where they trusted us with entering a BSL-3 lab, where we were allowed to work in a room full of bulletproof glass and 3 pairs of gloves under very strict supervision. But in the end, we were only working with a fake virus, so don't worry, we weren't the ones who released COVID out there.
During that semester, some people also distracted themselves with finding love during San Jordi. And no, don't worry, Bima, we're not looking at you.
This was also the semester with the most trips made by our classmates. They traveled to Sitges, Nice, Madrid, Lisbon, visiting Lucia's house in the Pyrenees, Rome, Bilbao, Valencia, Sevilla, Girona, and everything was, of course, captured by our photographers, that is Claudia, Jean, and Pratik.
And at the end of the semester, unfortunately, my complete diet composed of croissants con chocolate, nuts, and grapes got destroyed after having so many lectures on food safety and realizing that all of these foods are contaminated with toxins.
Experiment number 3, cold winters in Germany. So the last setup of Our experiment was in Hanover, and it was absolutely wonderful. We got modern studios with working ovens, surrounded by nature, our very own washroom, and spacious rooms.
Wait, Sarah, I believe you're forgetting this was a single blind setup experiment. While half of the experimental objects or classmates was enjoying their modern accommodation, others were exposed to the phenomena called House M, sharing one bathroom with 16 other people.
Luckily, there was not a lot of time to process House M as we embarked on 3 excursions. We started with a trip to the World Health Summit in Berlin, where we got to exchange with the creme de la creme of public health policy around the world.
Our next trip was to the wonderful country of Windyland, a fictional place with an unknown virus outbreak, where we got to practice our diagnostic skills with a mobile lab.
And lastly, we went to the very far and cold north of Germany with Jens to visit FLI, a BSL-4 lab built on an island.
To survive the cold, we found warmth within the group. Sabrina organized a Thanksgiving dinner, Ashley a pub quiz, and Germans gave us Oktoberfest and Christmas markets.
They also made sure to make us sweat a little bit when they decided to dismantle a bomb from the Second World War and had the whole hospital evacuated. And they also made some of us sweat when we kind of accidentally ended up at an opera that was completely in German.
Chapter 3, Results. Despite the fact that lab experiments can go wrong sometimes, our 3 semesters and experiments worked very well.
And after some difficult calculations with our studio, the experiment even enabled us to start internships all over the world.
Which meant we wouldn't see each other for 6 months, but at the same time, we would be able to experience incredible adventures. However, when we asked our classmates to share some stories of their internships, it remained suspiciously silent.
Apart from some stories that made it all the way back to Europe, like this lady here who got stuck at a border in Uganda while trying to travel back to Kenya.
And some of us went to catch kangaroos down under.
And then this woman, an impressive boss lady, was leading and coordinating a project involving 7 countries during her internship.
Also some less fun stories, like someone who broke their foot in the last month they were in Costa Rica.
And while in Gottlob, someone forgot to bring bird net when they were catching birds.
Well, as a very smart man once said, la vida no es perfecta. But what turned out to be perfect were those thesis dissertations.
6 months of blood, sweat, and tears, mostly tears, resulted in 22 dissertations. Oops, sorry. And us standing here today. Chapter 4, Conclusions and Way Forward. First of all, dear professors and program supervisors, thank you for your endless support and your kind supervision. We know that sometimes we were a little bit difficult to handle, especially during heated debates on dual-use research of concern, or when you were trying to patiently explain us concepts that... but because of you, we made incredible memories, and we tackled all sorts of difficulties. And also, I want to include friends and family. Thank you for your constant support with phone calls, emails, hugs, and even LinkedIn likes.
Dear first-year students, you are starting 2 incredible years full of jokes, memes, and heartwarming moments. If we can give you 3 pieces of advice as old, wise, and soon-to-be Idoh alumni, let me start by the first advice. Be ready to constantly correct people when they are trying to pronounce Idoh, or Idoh, or Idoha, Idaho. Good luck with it. Second of all, please make sure to survive this journey without losing your wisdom teeth, appendix, or breaking your foot like we did. Third of all, and last but not least, say yes to every opportunity to see the world and connect with your classmates. To cite a wise lady called Fumbi, grades fade, memory stays.
Dear classmates, standing here today, we feel an overwhelming sense of gratitude. Over the past 2 years, we have journeyed together across France, Spain, and Germany, not just as classmates, but as companions who have grown to struggle, laugh, celebrated side by side together. We have created a family, a community bound by shared experiences, late-night study sessions, countless coffees, and the joy of discovering new cultures together. No matter where life takes us, we hope to always remember that we were not just friends of students of the Idoh program, but we also are each other's biggest cheerleaders and inspirations. Thank you for making the 2 years unforgettable.
Unfortunately, our experiment and scientific presentation have come to an end, and probably it will not make it into any fancy journals, but we hope and we are sure that all of our classmates will 100% succeed with their future careers.
Thank you to all of us, and we want to take just one little moment to wish Claudia a happy birthday. And we would also like to congratulate Rezi and Marta for their engagements.
Thank you.
Come on, let's say thank you.
Thank you.
Okay, so now I will need the help of the other coordinators from Barcelona, if he still has the time, or perhaps he already left for his train. So he left for his train. So from Hanover and Tours, so Relia, you can come, yeah, for this diploma ceremony. So please come on stage. So as you have just seen, I mean, we had 22 students in that class, and they have just finished the program yesterday with the defense of their master thesis. They all achieved good results, and 6 of them have already secured funding for a PhD, while 4 have found jobs. So finally, it's not so bad for one day after the defense. For some of them, you had the short overview of what they have done during the flash talks presentation. So now we will start. Ready, guys? So yeah, perhaps few guidelines. So you are supposed to come here with the stairs, and you will receive your provisional certificate of achievement. So please don't lose them, because we will need about 1 year for the diploma, the real diploma. So keep them, okay? And so you will come, have your certificate, and then you will go back on my right, okay? Perfect. So the first one is Josephine from Germany. She joined the Friedrich Laufer Institute to work on skin-related neglected tropical diseases and One Health, and would like to continue on this topic. The second one is Tangimul. Originally from Bangladesh, he stayed at the MHR and explained to us how a microbe could run our breakfasts. So he studies the role of an enzyme, I don't remember the name, in Listeria infections. Lucia from Spain. I've learned recently that she survived to a previous journey in Ghana with Bruno and preferred to stay to Switzerland to work on mechanism of cross-resistance to antibiotics. So coming from Pakistan, Zoa joined the Freie Universität in Berlin, sorry for my poor German, to work on Asperger's viruses. So the second one, I hope, is awake. Jahan Saib. After a last-minute cancellation for his internship in France, has demonstrated his ability to bounce back and work at MRR on coronaviruses. Mena joined a group in MRR to develop a vaccine against HIV, so perhaps my president has some read, and he will continue to with this topic in his doctoral studies.
Thank you.
Jeanne, as a detective, went to a crime scene in Guadeloupe and looked for West Nile virus invertebrates. I would like to thank her for the beautiful picture of birds she sent me. So Claudia, happy birthday. At WOHA, she better defines the hazard landscape and the role of veterinary services in the context of emergency. I think that Ashley was the most relaxed yesterday because she had already defended her thesis in July, so that she could start a PhD in Europe on time. So the next one is Ricardo, but he was not able to join in Tours. And yesterday he explained us from Malta the regulatory and risk management strategy to fight listeriosis. Marta spent a full semester in Edinburgh working on bovine natural killer cells and finally met Darren and Jerry in Tours only yesterday. Fumbi went to Limoges in France and explored how to monitor respiratory colonization in mechanically, I will arrive, ventilated ICU patients. So Sarah is a Belgium or French or whatever. I mean, it depends of the day. She studied biosecurity practices in live animal markets in the Black Sea Basin and will keep on working on risk management. So Sabrina, so apparently the rest of the class is supposed to say from US. She traveled to the other side of the world to investigate Streptococcus-specific adaptive immune responses in a human challenge model of pharyngitis. I don't know how to pronounce that. And she will be back soon in Australia. So now 3 students coming from Nepal. So Bima, while being in Spain, defines the household characteristic associated with infection in children under 5 in Mozambique. Rabina, she went to the FLI again. I mean, again, not her, but I mean, many students went to FLI. So apparently, even if it's very in the North Germany, it's still fine. And she studied ticks and their pathogen in Northern Germany. And the last Nepalese, but not the least, still at the FLI, Pratik enjoys screening the coronavirus diversity and antimicrobial resistance in wildlife. So now 2 people from Romania. So the first one, Theodora, showed us that Costa Rica could be the second country for cheese after France, of course. And Irina, she worked on the development of a Borrelia detection system in the context of an academic and industrial cooperation. So coming from Zimbabwe, Tanaka. He continued the internship work he had done during the summertime between the 2 years of the master degree, and he focused on how the varicella zoster virus modifies the host immune response. Fernando from Costa Rica assessed the spatio-temporal risk of West Nile virus transmission in equids in Spain. The last one, Emma. She spent her semester in Africa, and I've just learned this morning that she took cooking lessons while I saw she was working on guidelines.
Thank you so much for meeting me.
So congratulations to all of you. So perhaps you could come back on the floor for general picture.
Isabel. Check here. Is it nice? Wait a minute. A full picture.